Welcome to the ultimate Excel mastery course. Are you ready to unlock Excel secrets most users never discover? In the next few sessions, you'll learn everything from building your first table to mastering advanced functions, powerful lookups, creative charting, and even scenario analysis. You'll get hands-on with formulas, automate your workflow with inbuilt functions, and discover hidden tools like pivot tables and Power Query. Imagine turning raw data into dynamic insights, stunning dashboards, and making your work super efficient. Are you curious to see what Excel can really do? Let's dive in and transform you into an Excel pro, starting right now. Hello and welcome back. In this video, we will discuss the Quick Access Toolbar, commonly known as QAT. You can find it at the top left corner of the Excel window. It provides easy access to frequently used commands. You can add or remove commands, making it highly customizable. Some popular default commands include New, Open, Quick Print, and more. You simply need to select a command, and it will appear on the toolbar. You can then use these commands with a single click, helping you save valuable time. Additionally, Excel provides shortcut keys for these commands. If you press the Alt key on your keyboard, shortcut numbers like 1, 2, 3, 4, 5, etc. will appear over each command. These numbers will work shortcut key for these commands. Then, just press the number corresponding to the command you want to use. This feature is extremely useful. You can even create a VBA macro and assign these VBA code to an icon of your choice. This icon will appear on the Quick Access toolbar. You can then access this in single click. We will cover this practical aspect in the VBA section of this course. If you want to add more commands, click on More Commands. By default, Excel shows popular commands, but you can choose from any tab. For example, if you want to insert a command, select the command, click Add, and it will be added to the customized Quick Access toolbar. If you want to remove a command, just select it and click Remove. Once you're done, click OK, and you'll see that command on QAT. Now, if I press the Alt key and the shortcut shows 6, then pressing Alt then 6 will activate the filter command. You can also move the Quick Access toolbar below the ribbon instead of above it. However, I prefer keeping it above the ribbon because placing it below takes up more space, and I like to maximize my workspace in Excel. But of course, it's completely up to you. In the next video, we'll discuss more options in Excel. Stay tuned. Hello everyone. In this video, we'll learn how to enter data in Excel. First, we'll begin by adjusting the screen using the zoom feature to make it easier to work. Then, we select any cell and start typing directly from the keyboard. For this example, our task is to create a table related to employees, including their salary, joining date, and a few other fields. Let's start by typing the headers, beginning with serial number. Press the Tab key after typing. It will move the cursor one cell to the right. Continue entering other headers such as name, date of joining, salary, and if needed, time. Now that the headers are ready, instead of pressing Tab, press Enter. This will move the cursor to the first cell in the next row. You can also navigate using the arrow keys to move up, down, left, or right. However, keep in mind that pressing Enter moves the selection downward, not back to the starting point of the row. Let's begin entering the data. Type 1 for the serial number, press Tab, then enter the name, followed by the date of joining. When entering dates, it's important to use a valid format, such as 1st January 1981. After pressing Tab, Excel will automatically recognize it as a date. Internally, Excel stores dates as serial numbers, and we'll discuss that in more detail in the upcoming section on data types. There's also a helpful shortcut to enter the current date, Ctrl plus semicolon. This will input today's date automatically. You can find a complete list of shortcut keys in the PDF attached with this video. Now, enter a number in the salary field and press Tab. Excel will recognize it as a number. If you need to enter a currency or percentage, go to the Home tab and look for the number section. Here, you can apply a currency format or other number styles. For this example, I'll skip applying a currency format. Next, let's enter the time. You can type it manually, such as 11:30 a.m. or p.m. as required. To enter the current time quickly, use the shortcut Ctrl plus Shift plus semicolon. If needed, you can change the time format from the Home tab using the formatting options under the number section. If you want to enter both the current date and time together, use the combination of both shortcuts, Ctrl plus, followed by space, then Ctrl plus Shift plus. This will insert both values in one step. After that, if you press Ctrl plus Enter, the data will be entered, but the cursor will stay on the same cell, allowing you to continue editing or formatting without moving to another cell. To make changes to an existing value, either press F2 or simply reselect the cell and edit directly. You can also customize the format of the cell as per your needs. Now, you can download the practice sheet attached to this lesson and try entering more data into the table. If you have any questions, feel free to leave a comment or send me a message. Thank you for watching and stay tuned for the next video. Hello and welcome back. In this video, we'll explore the interface of Microsoft Excel. In the previous section, we talked about the Quick Access toolbar. Just below that, we have the menu bar, which includes several tabs such as File, Home, Insert, Page Layout, Formulas, Data, Review, and View. Each tab contains related commands grouped by their functionality. By default, the Developer tab isn't visible. To enable it, simply right-click on the ribbon, choose Customize the ribbon, and then check the Developer option. Click OK, and it will appear. This tab includes options for macros, VBA, and other advanced tools, which we'll explore later in the course. You might also see extra tools or add-ins from software installed on your computer, though they may not be necessary. Now, let's take a closer look at the Home tab. As mentioned, commands are grouped based on their purpose. For example, in the Clipboard group, you'll find Cut, Copy, Paste, and Format Painter. In the Font group, you'll see text formatting options. The Alignment group handles alignment settings, and the Number group manages number formatting. If you go to the Formulas tab, you'll find everything related to Excel functions and calculations. Back in the Home tab, you may notice a small arrow in the corner of some groups. Clicking this opens more advanced options. For example, clicking the arrow in the Font group opens the Format Cells dialog box. Here, you'll find detailed formatting options such as number, alignment, font, border, fill, and protection. We'll cover these in more detail in upcoming videos. Now let's move to the Formula bar, which is just below the ribbon. This is where you can view or enter data, formulas, and functions. Below that, we have the Excel grid made up of cells. A cell is simply a small space where data is entered, such as numbers, text, or dates. Even though you enter data into a cell, you can also view or edit that data in the formula bar. You can input formulas here directly as well. For example, typing equals 1 plus 1 or using a function like equals sum of E10 and E11 will show the formula in the bar and the result in the cell. Excel also helps by suggesting cell references and functions as you type based on your data. If you want to see the formula used inside a cell, just press the F2 key. This lets you view and edit formulas within the cell itself. Each cell in Excel has a unique name, defined by the combination of its column and row. Columns are labeled with letters like A, B, C, and rows are numbered like 1, 2, 3. So, a cell in column H and row 13 is named H13. This name appears in the name box, and both the row and column are highlighted when the cell is selected. Next, we have the scroll bars. These let you move horizontally and vertically through your worksheet. While they're not used often for complex tasks, they're helpful for navigating large sheets. More importantly, on the bottom right of the screen, you'll find the Zoom toolbar. This tool lets you zoom in or out of your spreadsheet. You can choose a specific zoom percentage, like 100% or 200%, or use the slider. There's also a zoom to selection option. For example, if you select a specific area using the Shift key and arrow keys, then choose Zoom to Selection, Excel will focus only on that selected range. Sometimes, when you zoom in or enter wide data into a narrow column, you might see hashtags instead of values. This just means the content doesn't fit, and you need to adjust the column width or row height. We'll cover those formatting tips later in the course. Next to the zoom options, you'll find the view settings. Excel offers three main views. The default is normal view. The second is page layout view, where you can see headers, footers, and how your content will look when printed. The third is page break preview, which lets you manage how pages are divided for printing. This view is great for adjusting page size and layout. Now let's look at the structure of an Excel workbook. An Excel file is called a workbook. Within a workbook, you can have multiple worksheets or sheets. By default, there's one worksheet, but you can add more as needed. For instance, you might keep sales data in one sheet, employee information in another, and profit and loss data in a third. Excel allows you to organize your sheets easily. You can insert, delete, rename, move, or copy them. You can also protect sheets, assign colors to them, hide or unhide them, and even select multiple sheets at once for bulk actions. This structure helps keep your data organized in one place. As we continue this course, we'll go deeper into more advanced Excel features. Whenever we introduce a new tool or function, I'll explain it in detail with practical examples. So, stay tuned for the next video. Thank you. Hello and welcome once again. In today's video, we will learn how to save a file in Microsoft Excel on your computer. Saving your work is crucial, and fortunately, Excel provides an easy and universal shortcut for this. Whether you're using Windows or Mac, the shortcut is almost the same. On a Mac, you can press Command plus S, and on Windows, it's Control plus S. When you press Control plus S, a small window will appear. If you have already set a specific location for saving files, you can choose it from the options. Otherwise, click on More Options or Browse to select a different location. You'll see a list of recent folders on the right-hand side. Select any desired folder, choose the location, give your file a name, and ensure that the file type is set to Excel Workbook. Excel offers several file formats, which we'll explore in detail later. But in most cases, about 95%, you'll save your file either as an Excel Workbook .xlsx or as a macro-enabled workbook .xlsm if your file includes macros or VBA code. There are other formats too, like XML data, which is useful when transferring data between platforms or software, and Excel template .xltx for reusable templates. Sometimes, data is also saved in tab-delimited text format. However, the default and most common format is .xlsx, which is the latest Excel file extension. If you're working with an older version of Excel, the file might open in compatibility mode, and you'll need to resave it in the latest format. Additionally, you'll find options to enter details like the author's name, tags, title, subject, and manager information. These fields help in quickly locating files through search within your computer. Since I have already saved this file, I won't save it again. But if you want to save the same file with a different name, use the Save As option from the File menu. This allows you to create another copy of the same file in a new location or with a new name. You can also share your file directly by clicking the Share button. From here, you can send the file as an Excel attachment or as a PDF, which will automatically attach it to your default email client. Excel also provides an option to export your file as a PDF or XPS document. Keep in mind that Excel sometimes autosaves files in the background, but it's a good habit to press Ctrl+S every 2 to 3 minutes to avoid losing your work. If you forget to save and something goes wrong, you could lose all your data. So always save your file frequently and at the right location. In the next video, we'll explore more options available in Excel. Thank you for watching. Hello everyone and welcome back. In this video, we'll discuss how to navigate an Excel sheet without using the mouse. I'll show you how to use shortcut keys, especially combinations involving Ctrl, Shift, and the arrow keys. These shortcuts are essential, especially if you're a beginner, so it's important to learn and practice them regularly. To help you, I've provided a downloadable Excel file with 10,000 rows of order data. It includes various types of data for your practice. Now, let's talk about moving efficiently through this large data set. Suppose I want to jump from the top of the sheet to the bottom, then to the far right column, and finally back to the starting point. Using the Ctrl key with arrow keys, we can do this quickly. Press Ctrl plus right arrow to jump to the far right of your data. Ctrl plus down arrow takes you to the last row of your data. Ctrl plus left arrow returns you to the beginning of the row. Ctrl plus up arrow takes you back to the top. This is a fast and effective way to navigate large datasets, much better than using a mouse. Now, let's learn how to select data. Before copying or moving data between sheets, you first need to select the relevant cells. This can be a single cell or a range of cells. Using a mouse is easy. Just click and drag. However, it's not ideal for large datasets. Instead, use the Shift key with arrow keys. Hold Shift plus right arrow to select cells across a row. To speed up selection, combine Ctrl plus Shift with arrow keys. Ctrl plus Shift plus right arrow selects all columns in a row. Ctrl plus Shift plus down arrow selects all rows in a column. Together, Ctrl plus Shift plus right, then down, selects the entire data range. You can also press Ctrl plus A to select the current table. Pressing Ctrl plus A again selects the entire sheet. But be cautious. On very large datasets, selecting the whole sheet may slow things down or even crash Excel. Let's summarize the process. Press Ctrl plus Home to go to Cell A1. Use Ctrl plus Shift plus arrow keys to select data quickly. Use Ctrl plus C to copy and Ctrl plus V to paste. We'll go deeper into copy-paste and clipboard options in future videos. Now, let's explore the End and Home keys. Press Ctrl plus Home to return to Cell A1. Press End, then an arrow key, example, right or down, to jump to the edge of data in that direction. This doesn't select cells, but moves the cursor. Pressing Home without Control moves the cursor to column A of the current row. When you press the End key, look for End mode at the bottom of your screen. That means the next arrow key you press will jump the cursor to the next edge in that direction. Let's review everything. Ctrl plus Home, go to Cell A1. Ctrl plus Shift plus arrow keys, select large ranges. Ctrl plus A, select table or entire sheet. End plus arrow key, jump to the edge of data. Ctrl plus arrow keys, navigate large sheets quickly. To switch between multiple sheets, use Ctrl plus page down, move to the next sheet. Ctrl plus page up, move to the previous sheet. All these shortcuts are essential for efficient Excel navigation. Don't forget to download the PDF and practice file linked below so you can follow along and reinforce what you've learned. In the next video, we'll dive into more shortcuts and explore useful tools and commands available in the tabs, menus, and ribbon. Thanks for watching and stay tuned for the next video. Hello and welcome once again. Navigating within any software is crucial, especially when working with large datasets in Excel. Working quickly and accurately is equally important, as you often have tight deadlines to meet. My goal is to help you become a smarter and more advanced Excel user. This video is designed to help you do exactly that. To become highly proficient in Excel, we must learn advanced techniques. In today's video, I'll be focusing on sequence shortcut keys using the Alt key, also known as key tips. And if you're on a Mac, these are accessed via the Option key. Let's start with a practical example. Suppose I have a large dataset and want to copy a portion of it. I begin by selecting some rows and columns. Next, I want to paste it into a new sheet. Using the mouse, I click the plus icon to insert a new sheet, select a cell, navigate to the Home tab, open the Clipboard section, choose the Paste option, and then adjust the column widths. I might zoom in to adjust the view and manually fit the columns. As you can see, I'm performing several steps using the mouse. Next, I want to apply some formatting. I select the heading, go to the Home tab, navigate to the Font section, choose a fill color, and pick a color of my choice. Then I apply borders by selecting the entire dataset, returning to the font group, and choosing the All Borders option. I also want to apply a filter, so with the data already selected, I go to the Data tab, and in the Sort and Filter group, select Filter. Finally, I want to sort the data based on order IDs in ascending order by selecting the Sort option and clicking OK. All of this was done using the mouse. That's fine when you have a small dataset, but when you're working with thousands of rows and columns, using the mouse becomes tedious and inefficient. You may even lose your selection midway through. That's where Alt key sequences come in. They allow you to work much faster. Let's do the same process again, but this time entirely with the keyboard using Alt key sequences. First, I'll select some data. I press Ctrl plus Home to go to the first cell, then use Shift plus right arrow and down arrow keys to make my selection. To copy the data, instead of using Ctrl plus C, I'll press Alt, which reveals shortcut keys on the ribbon. Since the copy command is under the Home tab, I press H, then C to copy. Next, I insert a new worksheet. This can be done using the sequence Alt-H-IS. I move to a cell and press Ctrl plus V to paste the data. For auto-fitting columns, I use Alt-OCA. To zoom to selection, I press Alt-WG. To apply borders, the shortcut is Alt-HBA. To color the header row, I select it using Shift plus Ctrl plus right arrow, then press Alt-HH, choose a color, and press Enter. Now, I want to apply a filter. For that, I press Alt-AT. To sort the data, I use Alt-ASS, press Tab to navigate to the column selection, then Alt plus down arrow to choose Order ID and hit Enter. These are just a few of the shortcut keys you can use. You don't need to memorize them all at once. Just start by noting the ones relevant to your daily work. Whether you're a data analyst, data entry operator, or simply managing Excel sheets, these shortcuts will save time and boost your efficiency. The best way to become faster and smarter in Excel is by practicing these sequences regularly. If you have any questions or need clarification, feel free to leave a comment or send me a message. I'll do my best to respond as soon as possible. Thank you. Hi everyone. Welcome back to this Excel tutorial. Today, we'll be talking about one of the most commonly used groups in Excel, the font group, which is available under the Home tab. These tools help you make your spreadsheet clean, clear, and professional. Let's start with the font itself. By default, Excel uses Calibri, but you can change it. To do that, go to your Preferences and navigate to the General section. Please note, the steps might be slightly different for Windows users, but the options are largely the same. The appearance may just vary. In the General section, you'll find an option to change the default font. You can choose any font, set the font size, and save it. On Windows, you'll need to manually save these settings. On Mac, changes are saved automatically. Once done, close the settings. The next time you open or create a new workbook, your selected font will be applied by default. Of course, you can change the font at any time. Let's walk through how to change it manually. First, select the data you want to format. Since we are working with a small table, I'm using the mouse to select the data. Now, I want to apply the Times New Roman font. Click the small arrow in the font drop-down to see all fonts installed on your system. You can browse by collections or categories like fixed width, or simply start typing the name of the font if you remember it. After choosing Times New Roman, you can also select the style like regular, italic, or bold. I'm choosing regular for now. Just remember, always select your data before applying formatting. Next to the font drop-down is the font size option. From here, you can increase or decrease the size. Suppose I want to increase the size of my headers, I'll select them and choose size 18. If the text doesn't fit in the cell, you can expand the column width manually. That should fix the layout. You'll also find quick buttons to increase or decrease font size with a single click. These are handy shortcuts. You can also use the keyboard, press Alt and follow the sequence keys we discussed in the previous tutorial. Now, let's talk about emphasizing your text. You can use bold, italic, or underline. Bold adds strong emphasis, italic gives a slanted style, and underline draws a line under the text. By default, it's a single underline. But if you want a double underline, click the drop-down and select it. If you change your mind, you can easily remove the formatting. Shortcut keys for these are Ctrl+B for bold, Ctrl+I for italic, Ctrl+U for underline. Still, I recommend using the sequence keys in Excel for more control. Now, let's add borders to our data. After selecting the data, go to the Borders drop-down. You'll see multiple options: bottom, top, left, right, no border, and all borders. I'm selecting all borders for now. This will draw light lines around each cell, helping to visually separate the data. It's especially useful for readability. By default, Excel displays grid lines, which can make borders hard to notice. You can turn off grid lines by going to the View tab and unchecking grid lines. This is helpful when you're designing a clean table or form. Now let's add color. After selecting your data again, go to the Fill Color option. It looks like a paint bucket. Click it to see several preset color options. Select the one you like, and it will be applied immediately. You'll also see recently used colors for convenience. If you want more control, click More Colors. On Mac, this opens a detailed window where you can choose colors from a wheel, spectrum, or sliders. You can adjust brightness, hue, and grayscale levels. Windows has similar features, although the interface may look different. I'm cancelling this for now and moving to the font color. Let's change the font color of our header. After selecting it, go to the font color drop-down. By default, it's set to automatic, which you can change in preferences. Suppose I apply a dark blue fill to the header. Now the default black text is hard to read. So, I'll change the font color to white for better contrast. And that covers the main options in the font group. In the next video, we'll dive into the alignment group to control text positioning and layout. See you there. Hello and welcome back. In this video, we're going to explore some additional formatting options in Excel, focusing particularly on alignment. To begin with, let's talk about alignment. As you may already know, before applying any formatting, including alignment, we need to first select our data. For example, let's say I want to apply alignment formatting to the order ID column. I'll start by increasing the column width, selecting the entire column, then navigating to the Home tab and looking for the alignment section. By default, text is aligned to the left, while dates and numbers are typically aligned to the right. You can change this to center, right, or left alignment as needed. Just use the alignment buttons, left, center, and right. Next, let's look at vertical alignment options, aligning text to the top, middle, or bottom of a cell. Suppose I have some data and I increase the row height. Although it might not look great visually at first, these options are helpful when designing forms or structured layouts. Selecting Top Align moves the text to the top of the cell. Middle Align centers the text vertically. Bottom Align places the text at the bottom. You can also adjust the cell size, both width and height, and the text will align accordingly. Now, let's move on to the orientation options under the Format menu. These are especially useful when designing invoices or tables. You can rotate your text using options like Angle Clockwise, Angle Counterclockwise, Vertical Text, Rotate Text Up, Rotate Text Down. If you want more customization, click on Format Cell Alignment for advanced settings. You can specify the rotation angle in degrees and preview the result before applying it. Once you click OK, your text will rotate as specified. To reset it, just set the angle back to 0. Next, let's discuss wrap text. This feature is particularly useful when a sentence or long string of text spills over into adjacent cells. For example, if I copy and paste some long text into a cell and press Enter, it might overflow into the next cell unless there's data in that cell, in which case the overflow gets hidden. To solve this, simply select the cell or range, click Wrap Text, and Excel will adjust the content into multiple lines within the same cell. You can then double-click the row boundary to auto-adjust the row height. The content remains fully visible, and the column width can also be adjusted to auto-fit. Now, if you don't want to use wrap text, but still need the content to fit, you can use Shrink to Fit. This adjusts the font size automatically to match the cell's dimensions. When enabled, it scales down the text so it remains visible without wrapping. Again, if you double-click the row boundary, the height adjusts automatically. At this point, I'd like to mention that I'm sharing these tips based on 25 years of hands-on experience with Excel. I'm not a formal trainer. I'm simply explaining what has worked for me in real-world scenarios. So take notes as I walk you through the practical uses of each option. Moving on, let's look at the Merge and Center feature. This is very useful when you're creating forms or need to center a heading across multiple columns. For instance, if I want to add a heading called Order Details above columns for Order ID and Order Date, I can type the heading, then merge the two cells so the title appears centered. This gives a clean, structured look to your data. You can also explore other merging options by clicking the drop-down next to Merge and Center, such as Merge Across, Merge Cells, Unmerge Cells. To reverse a merge, just select Unmerged Cells, and the data will be split back into individual cells. You can always press Ctrl+Z to undo any changes. Let's now cover one final option: Increase Indent and Decrease Indent. These are useful when you want to shift your content slightly within the cell. For example, if your alignment is set to left, but you want to create a visual space before the text begins, you can select the cells and click Increase Indent. This adds padding inside the cell. To remove it, simply click Decrease Indent. So far, we've covered the font and alignment sections thoroughly. In the next video, we'll move on to additional formatting tools and demonstrate how to apply them in practical scenarios, step by step. Thank you for watching, and stay tuned for the next video. In Excel, we work with many types of data, numbers, dates, and text being the most common. These are the primary data types we enter into cells to perform analysis, build formats, and create templates. In this video, we'll explore different types of numbers and dates, and how to format them based on our specific needs. Let's go step by step. First, let's discuss numbers. Start by entering some numbers into the cells and pressing enter. Now, sometimes we need to present these numbers in different formats. For example, if you're preparing a financial report, you might need to display numbers as currency. Excel provides default formatting options for various currencies. To apply currency formatting, select the cell or range of cells, go to the Home tab, and locate the number group. Click on the accounting number format. Based on your regional settings, the default currency will appear. For me, it shows English, India. You can also choose other commonly used currencies like pound, euro, or US dollar. Let's select US dollars. The number is now formatted with the dollar sign and appears in currency format. Since my region is set to India, the format displays in lakhs and crores. However, this can be changed to millions and billions by updating the system's regional settings. Next, let's explore other formatting types. I'll copy and paste the same number as values to remove any existing formatting. This allows me to apply new formats freely. Suppose I want to display a number as a percentage. I can select the percentage format. Keep in mind that percentage formatting multiplies the number by 100, so plan accordingly. You can either format the range before entering your data or paste the numbers and format afterward. Another option is the comma style format, which removes the currency symbol but keeps the number separators intact. In India, numbers are shown in lakhs and crores. If you want to change this to a different format like millions, adjust the regional settings. You can also use the increase decimal and decrease decimal options to control the number of decimal places shown. Excel provides even more formatting options. Click on the small arrow in the number group to open the Format Cells dialog box. Here, under the Number tab, you'll find categories like General, Number, Currency, Accounting, Date, Time, Percentage, Fraction, Scientific, Text, Special, and Custom. General, no specific formatting. Number offers options to include thousand separators and control decimal places. Currency lets you choose the currency symbol and decimal precision. Accounting, similar to currency, but aligned for financial reports. Date time, various formats depending on how you want dates and times displayed. Percentage multiplies values by 100. Fraction allows display in fractional formats like halves, quarters, eighths, and more. Scientific, useful for very large or small numbers. Text treats numbers as text. Special and custom, used for advanced formatting needs. Let's see how a negative number can be displayed differently. Suppose we select a number format that shows negatives in red or within brackets. Click OK, then input a negative value using Ctrl plus minus. The number updates accordingly. Under currency, you can adjust decimal places or change symbols. Excel lists currencies from various countries. The accounting format behaves similarly. Now let's move to dates. You can enter a date, for example, 1st January 2025, and press enter. Excel automatically recognizes and formats it. But behind the scenes, dates are stored as serial numbers to facilitate calculations. To see this, select the cell, open the Format Cells dialog, and change the format to General. You'll see a number, in this case 45,658, representing the number of days since Excel's start date, 1st January 1900. This system helps Excel perform date-based calculations. Similarly, for time, you can enter a value like 10:30 a.m. Excel stores this as a decimal representing the time portion of a 24-hour day. Again, switch the format to General to see the numeric value. Let's talk about text. Any cell content made up of letters, or even numbers stored as text, is considered a text value. Excel doesn't perform calculations on text. For example, if I type a number preceded by an apostrophe 1, 2, 3, 4, 5, Excel treats it as text. You'll notice a green triangle in the corner indicating a possible issue. Sometimes, when importing data from websites or software, numeric data is mistakenly stored as text. This needs to be converted before using it in calculations. Don't worry, I'll show you how to do that in a later video. Excel also includes text manipulation functions, which we'll cover separately when we focus on text functions. Lastly, let's explore formatting options for dates and times in more detail. Select your date cell, go to More Number Formats, and choose a style. For instance, long date, which includes the day of the week. Similarly, for time, pick from available formats or create your own. You can display time in 12-hour or 24-hour formats with or without seconds. These are some of the basic and intermediate formatting tools you can use in Excel to make your data more readable and meaningful. In the next video, we'll dive deeper into more formatting techniques and explore advanced options. Thanks for watching. Stay tuned for the next video. Hello and welcome back. In this video, we'll discuss the styles feature provided by Excel. We often use Excel to enter data, create reports, and eventually take printouts. These reports can also be shared in PDF or other formats, and even published directly to the internet. To maintain professionalism, especially in large organizations, it's important that our reports are neat, clean, and consistently formatted. You've probably noticed how many companies use predefined templates where the colors, fonts, sizes, and layout are standardized across all reports. Fortunately, Excel allows us to define and reuse such styles, making it easy to maintain consistency and save time when creating reports. Let's explore how to access these styles. If you go to the Home tab and look towards the middle right section, just after the Format as Table option, you'll find the Cell Styles menu. Click the small down arrow to explore all available styles. These styles are categorized for different purposes. For instance, you'll find styles like good, bad, and neutral, which are helpful for highlighting data during analysis. For example, negative numbers can be marked with a bad style, while positive results or key metrics can be highlighted using the good style. Neutral can be used for standard or less important data. These are built-in templates provided by Excel, but you can also create and customize your own styles. There are other categories too, such as for data and model, calculation, input, output, note, and warning. These help to visually distinguish different sections of your report, making it more organized and easier to read. Let me show you a quick example. Suppose I'm creating a report. First, I add a heading. Let's say invoice or simply my report. After typing the text, I can format it using predefined styles instead of manually adjusting fonts, sizes, and colors each time. I'll increase the width of the cell, select it, then go to the Styles section in the Home tab. Clicking on a style like Heading 1 will instantly apply formatting such as font size, underline, and color. You can still modify it further if needed, but using styles saves a lot of time. Now, let's talk about creating a custom style. Suppose I formatted a cell the way I like. Now I want to save that format for future use. I copy the text and paste it as values into a new cell. With no formatting applied yet, I go to Styles, click New Cell Style, and give it a name like My Style 1. You'll see several formatting tabs such as Number, Alignment, Font, Border, Fill, and Protection. For example, I can go to the Fill tab and choose a navy blue background. Since that's a dark color, I'll change the font color to white, make it bold, increase the font size to 36, and select a font like Arial Black. You can also add borders or any other formatting preferences. Once done, click OK. Now your custom style is saved and ready to use. Whenever you create a new report, you can simply apply your saved style to the title or other sections, saving a lot of formatting time. Let's see how this applies to a practical scenario. Suppose I'm doing some calculations. I have some input numbers, and I want to clearly mark input, output, and explanation sections in my worksheet. I'll select the cells containing input data and apply the input style. Then, I'll select the output section and apply the calculation or output style. For any notes or explanations, I can use the note style. When I share this report, the reader will easily understand the structure of the data. It will also look professional, similar to the standards followed in large MNCs, where every report follows a set template with predefined fonts, backgrounds, and formatting rules. By learning to use and create styles, you can save time and ensure a consistent, professional appearance for all your Excel reports. Thank you for watching. If you have any questions, feel free to leave a comment or send me a message. I'll do my best to respond as soon as possible. Thank you, friends. Hello everyone and welcome back. In this video, we'll discuss how to insert and delete rows and columns in Excel, how to adjust their height and width, and explore some useful shortcut keys to make your work faster and easier. Let's get started. We'll begin with inserting rows and columns using the mouse, which is quite simple if you're comfortable with it. First, select the column where you want to insert a new one. To insert a single column, right-click on the column header and select Insert. A new column will be added to the left. If you want to insert multiple columns, select the number of adjacent columns equal to how many you want to add, right-click and choose Insert. Similarly, to insert a row, right-click on the row number and choose Insert. To insert multiple rows, select the desired number of rows first, right-click and click Insert. It's really that simple. Now let's talk about inserting columns and rows using keyboard shortcuts. To select a column, use Ctrl plus space bar. Once the column is selected, press Ctrl plus Shift plus plus to insert a new column. To insert multiple columns, select multiple columns first using your mouse or keyboard, then use the same shortcut. For rows, the process is similar. Use Shift plus spacebar to select the row, and then press Ctrl plus Shift plus plus to insert a new row. Select multiple rows if you want to insert more than one, and use the same shortcut. To delete columns or rows using the mouse, right-click on the selected column or row and choose Delete. To delete multiple columns or rows, select them first, then right-click and delete. Easy. Using the keyboard, the shortcut to delete is Ctrl plus minus. Again, select the columns or rows you want to delete using Ctrl plus space or Shift plus space, then press Ctrl plus minus. This will remove them instantly. Now let's explore how to use the ribbon tools for inserting and deleting. First, select the column or row you want to work with. Then go to the Home tab, click on Insert, and choose either Insert Sheet Columns or Insert Sheet Rows. Excel will automatically insert them based on your selection. You can also use the same method to delete columns or rows by clicking the Delete drop-down. If you want more control, Excel allows you to insert or delete individual cells. Select the cells, go to the Home tab, and under Insert, choose Insert Cells. You'll get options like shifting cells to the right or shifting cells down. Select your preferred action, click OK, and Excel will adjust your sheet accordingly. Similarly, under the Delete drop-down, you can delete cells and choose whether to shift other cells left or up. Next, let's learn how to adjust the width and height of columns and rows. The simplest way is to use your mouse. Hover over the boundary between two columns or rows until you see the double arrow icon, then click and drag to resize. You can also right-click on a column or row, select column width or row height, and enter a specific number to set it manually. For automatic resizing, double-click the boundary between two column or row headers. Excel will autofill the width or height based on the content. To apply this to the entire sheet, click the square at the top left corner of the sheet, above row 1 and left of column A. Then double-click on any column or row boundary. Excel will auto-adjust everything to fit the content. You can also use the ribbon for this. Select the columns or rows, go to the Home tab, then under Format, choose Autofit Column Width or Autofit Row Height. This is very useful when working with large datasets. Additionally, you can set a default column width for new worksheets. Go to Format, Default Width, enter your preferred value, and click OK. This ensures any new sheet or column follows your desired width automatically. Lastly, let's talk about hiding and unhiding columns and rows. If you don't want certain data to be visible or printed, simply select the column or row, right-click, and choose Hide. To unhide, select the range around the hidden data, right-click, and choose Unhide. You can also do this from the Home tab under Format, Hide and Unhide. Make sure you've selected the correct surrounding range. Otherwise, the hidden columns or rows won't reappear. For example, if columns E and F are hidden, and you only select column G and try to unhide, it won't work. You need to select both columns D and G, then choose Unhide. These tools make it easy to manipulate rows and columns, adjust layout, and keep your sheets clean and organized. If you have any questions related to this topic, feel free to ask. I'll try my best to help you out as soon as possible. Thank you for watching. Hello everyone and welcome back. In this video, we're going to learn how to apply borders in Excel using a practical example. I've created a very simple taxable invoice that includes stock items and some basic calculations. However, I haven't yet applied any formatting or finishing touches. So, we'll now use the skills we've learned so far and maybe even explore a few new tools to format it properly. First, let's understand where the border options are located. You'll find them under the Home tab. Click on the border icon and you'll see all available border options. To begin, we need to select the area where we want to apply borders. This is our main section where we'll apply borders first and then move on to other areas. After selecting the desired cells, simply choose the type of border you want: bottom, top, left, right, or all borders. You can also choose no border if you want to remove them completely. If you want to apply borders to all sides in one go, select all borders. You can also choose outside borders if you only want the outer edges highlighted. Let's say I remove the current borders and apply only outside borders. This outlines the area without applying borders between the cells. But I want to separate each cell clearly, so I'll reselect the range and apply a thick box border. This highlights the main section containing multiple cells. To preview the result, use the shortcut Ctrl+P to open the print preview. You can change the page orientation from portrait to landscape if needed. After adjusting the layout and resizing a few elements, we can better fit the content on one page. To enhance clarity, I'll hide the grid lines and return to the normal view. You can also make formatting adjustments while in print preview mode. Now, let's explore more border styles. You can apply double bottom borders, thick bottom borders, or both top and bottom borders at once. Each style is named clearly, so it's easy to choose based on your needs. Next, there's the option to draw borders manually. After selecting this tool, you can draw borders wherever you like: left, right, top, or middle, just by clicking and dragging. You can also use Draw Border Grid, where selecting an area automatically applies a full grid border to the selected cells. If you want to remove specific borders, use the Erase Border tool. Simply click on the areas where you want to remove the borders. Now let's talk about customizing border line color and style. You can choose a different color for your borders by selecting it first, then drawing on your selected area. For example, if I want to apply a red border, I'll choose red and apply it when needed. You can also adjust the border line style and thickness under More Borders. If you decide not to apply any borders at all, you can select none. Once you've chosen your color, style, and line thickness, click to apply the borders to horizontal or vertical lines as needed. You can also use the Visual Preview box to apply borders to specific sides: top, bottom, left, or right. Now it's your turn. Download the practice file along with 2 additional files I've provided. Use your formatting skills to make the invoice more neat, clean, and professional. In the next video, I'll show you how to design a table from scratch and create a clean, simple form. After that, we'll move on to designing a more complex form layout. Your practice session begins now. Thank you for watching and stay tuned for the next video. Hello everyone, welcome back. In this video, we will create a simple table. On the right hand side, we can see we have an employee timesheet. So, we will design the same in Excel and we will save it. We can use it to take the printout or distribute it to some of our companies. So, let's get started. First of all, we will select a cell. We will type employee timesheet. You can use any cell you like. Then, after that, we have name, employee ID, department, week, duration, we can adjust. We already discussed how to adjust the width. So, I will adjust the width like this. We can select the data, make it bold. We can increase the size if we want. We need a font which is big, actually, so that it will get highlighted. And I need to increase the font size as well. So, it is looking quite good, but it is not a professional font. So, I will select some professional font. So, let's find something. Let's say if I select this one, South. Yeah, that's nice. And for this also, I would like to change to, let's say, David. It's fine for me. Okay, that's fine. And now, I want something new. Let's do some practical things. So here, I don't want to enter. I want borders. But in the dotted line, I can simply select this one. But I would like to change it. Some different line styles, like dashes. Yeah, dashes would be great. And now it is fine. Now, I will draw like this, like this, like this, and like this. We can change the color if we want, but this color is looking okay for me. And press the escape button to come out from the drawing tool. Now, I would like to increase the height of the rows as well. So, I selected using the mouse. I'm increasing the height, that's fine. So, I increase the height. Now, I would like to make it in the middle, so I will select this option. So, looking quite good. Now, I would like to draw these. So, after some space, I will enter day, press tab, then date, press tab, then hours worked, and this time I will press enter. So, on the first, now I will select this data. I will make it center. I will change the font equally to. I will select 15 or 14 and press enter. I will change the font, let's say Calibri only. But we can see this has not fitted into our one cell. So, I will select this and I will move over here. And I need some more space for our data. So, this time, I will merge to cells. So, I will select both the cells and come to the Home tab. And here we have merge and make it center. Now again, I will select this one. I will merge and center. I will select and merge and center. And now, I will select Ctrl+C to copy and paste, double-click and paste. We cannot copy-paste the data in the merged cell directly. So, I will select and paste, and I remove this from here. Now, I will select. I will copy this one, and I will select more data. So now, all cells will get merged. Select this data and fit some colors. Change the font color to white. Make it bold. This also, I need to increase. Now, I will select this data. I will apply the border. It is in red. You can change the color as per your choice. So, I am going to change the line color automatically. Also, I want to change the styles to this one only. Now, I am moving to this. Also, I want to increase the height of these cells. So, after selecting, increase the row height like this. Select this option. Now we can feed the data. Come to the View tab. Disable the grid lines. So, looking quite good. So, this is how you can enter. You have to save this file. So, employee timesheet sent. So you can download it for your reference and you can feed the data. And your task is to create the same table. In the next video, we will create some more complex table for our practice. Hello everyone, welcome back. In this video, we will design this complicated form in Excel. We'll be using all the tools we've already discussed and learned in previous sections. Let's begin. First of all, we need to resize the column width. To do this, select the corner, move the width, and adjust like this to create smaller cells. Next, we'll use the merge option to make the required space. But before that, we need to type something. The first one is format R2. I'm increasing the size slightly so you can easily see what I'm doing. Now I can view the print preview and it's aligned with the column. I can increase the width from here and continue working. While the options remain similar, it's not best practice, so I'm undoing and selecting the area again. This is the area where you can apply temporary borders. These can be removed afterward if needed. Now shift this just to the left-hand side. We can now copy, right-click, and double-click on any cell. Right-click, paste, then press Enter. I need to enter date and time, but first, be sure to change the color and line style. Now apply the border. Then select the second line, copy and paste, and press Enter. Change the entire area by selecting here, and switch the font to 8. Margins can also be increased. If additional space is required, you can expand the margins under Page Layout. Go to the Page Layout tab, choose the Margin option, and select Narrow. Now, I've got sufficient margin. We now need to remove this border. Select the Eraser tool, clear the border, and again select the area to apply a border using the Home tab. Click here, then choose All Border. There are some extra columns I can remove. Later, I can reinsert the DDMM and Y fields and align them centrally. It's looking quite neat now. There's enough space available. You may also choose to reduce or increase based on your needs. That completely depends on your form layout. I believe I need a bit more room, adjusting accordingly for additional space. This looks fine now. You'll notice a faint line, that's the preview. Saving this now. This will be saved as our form practice. You can download the Excel file along with a PDF version. Now select and copy, then just below, double-click, right-click, paste, and press Enter. You can either type or copy, whichever you prefer. Double-click and paste, then just copy and paste again. Select this item and make it bold. At this point, type address. Then again, type address. Press Enter and team. Now I'll enter 06 followed by 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. Add borders by selecting this area. Apply outer borders to this area. Select and apply an outside border here as well. Add an outside border for contact. I'll need a bit more room here, and before that, type contact. Then copy and paste. Paste, then select the outer area. Select the first item, remove, then apply all border. Oops, undo. Just the side. Now let's hide the grid lines to preview the result. Looks quite clean. I'll add the outer border here too. After the TIN number, we include Economic Activity Code. Add outer border for Economic Activity Code and apply all border in this area. Next comes this line, select it completely, copy, paste it here, and press Enter. After that, add the description. Start the description from here. Allocate enough space, then add value of goods. Let's proceed with this section. I'll paste it. You'll see it wraps the text. Now I'll select that area, merge it, enable wrap text, and then use value of goods. Copy and paste. This time, I'll use only part of the area. Merge that section. I'll also use this portion and merge it. Description looks fine. Apply all border, or in some areas, just outside border. In this case, apply all border. Now proceed. Enter to A, then description. In description, select this item, copy, and paste. Then select the second line, copy, and paste again. Now select this full area. Apply only outside border. Scroll a bit further down, and now choose this area and fill with color. We need to merge here. Then drag this across, perhaps up to 10 numbers. Merge this part as well, and drag to fill the area. You can use various colors. Enter LS1, LS2, LS3, LS4, then fill with color. Now copy and paste again, and change the sequence to 6, 7, and 8. Apply the same color. Finally, LS9. Remove any extras, then apply all borders. Now for 2B, deductions. Make this bold, use Ctrl plus B. Again, Ctrl plus B. Make it bold. We also need a horizontal line here. Apply bottom border only. Just bottom border. We now need serial numbers. Start from 1, and since you can't input directly inside brackets, make it centered. Use the asterisk symbol or the top left character. I'm not sure of the exact name. Now you can either copy the entire section or go one by one. I'll copy and paste here, then reduce the space a bit. This completes the preview. Let's view and remove the grid lines. The form looks quite polished. Later on, we can start feeding the data entry by entry. This is a solid approach to setting up the borders. In case there are extras, remove them. You can add headers and footers too, which we'll explore later. But this is the method for designing forms. After that, you can print it. You can also enter data directly. Now you can download this Excel form and your task is to complete it, as the lower section contains a lot of details. You'll need to recreate this form in Excel. That's your exercise. If you have any questions or doubts, just reach out. I'll do my best to respond as quickly as possible. Thank you. Hello and welcome once again. In today's video, we're going to learn how to use one of the most useful tools in Excel, the Find and Replace feature. This tool can save you a lot of time when working with large spreadsheets. Let's understand how it works and where you can find it. First, let's look at the Find option. Imagine you're working in a large Excel file with thousands of orders, and you want to locate a specific name, number, or word. Scrolling and searching manually could take forever, and this is exactly where the Find tool comes in handy. To open it, simply press Ctrl plus F on Windows or Command plus F on a Mac. Alternatively, go to the Home tab, navigate to the Editing section, click on Find and select, and choose Find. A small Find and Replace window will pop up. Just type the word or value you want to search for and click Find Next. For example, if I type same day and press Enter, Excel will find the first matching cell. If you click Find All, it will show you a list of all matches along with their cell addresses. You can resize the window, adjust columns, and directly click on any result to jump to that cell in the sheet. Now let's move on to the Replace function, which is even more powerful. Suppose you want to replace all instances of same day with the current date. First, close the Find window and then reopen it, this time choosing the Replace tab or pressing Ctrl plus H. Enter same day in the Find What field and the value you want to replace it with, like today's date, in the Replace With field. You can choose to click Replace to change entries one at a time, or click Replace All to do it in one go. For example, I clicked Replace All and Excel instantly replaced all instances. Click OK to confirm and you're done. Let's now explore some advanced options. In the Find and Replace window, click Options. You can choose to search within the current sheet or the entire workbook. You can also search by rows or columns. By default, Excel searches row by row. You can also look in formulas, values, or comments. There are checkboxes to match case and match entire cell contents, which are useful if you want only exact matches. And now, here's a pro tip. You can find and replace based on formatting. Let's say you want to find all cells with the word second class that also have a red fill. First, format one of the second class cells with red fill. Then, open Replace, Ctrl plus H, type second class in the Find What field, and click the Format button. In the Fill tab, choose the red color. You can also use the Choose Format from Cell option to select the exact formatting from an existing cell. Once done, click Replace or Replace All, and Excel will only replace cells matching both the text and the formatting. That's how you can effectively use the Find and Replace feature in Excel to save time and improve your workflow. If you have any questions, feel free to drop them in the comments. I'll do my best to get back to you as soon as possible. Thank you. See you in the next video. Hello and welcome once again. In this video, we'll take a deep dive into the Clipboard group in Excel, one of the most essential tools to boost your productivity. Whether you're copying data, transferring formats, or using special paste functions, this group provides everything you need. Let's explore each tool step by step. First, we need to locate it. The Clipboard group is found under the Home tab on the ribbon. If you've used any Office application before, you're likely familiar with the basic cut, copy, and paste functions. But in Excel, it offers much more. Often, you'll encounter scenarios where you need to copy or paste specific data or apply formatting already present in your worksheet. This is where Paste Special comes in, which I'll explain shortly. But first, let's cover the basics. The shortcut for cut is Ctrl plus X on Windows or Command plus X on Mac. The cut command removes the selected content and stores it in memory, allowing you to paste it elsewhere. For example, say I have a table and want to move the fourth row. I'd select it using Shift plus Ctrl plus right arrow, then press Ctrl plus X. To move it to a new sheet, I'd use the Alt, I, W sequence to insert a worksheet, rename it using Alt, O, H, R, and then press Ctrl plus V to paste. The data, including formatting, moves to the new sheet. Now, let's talk about copy. Unlike cut, copy retains the original data and stores a duplicate in the clipboard. You can copy formulas, values, or entire rows and columns. For example, copy a cell with Ctrl plus C, navigate to a new sheet, and paste it using Ctrl plus V. You can also select the entire table with Ctrl plus A, copy it, and paste it elsewhere. That's the standard use case. But what if you only want to paste specific elements like formulas or values without formatting? That's where Paste Special comes in. Click the drop-down under the Paste button, and you'll see many icons, each representing a different paste option. Choosing Paste Special opens a window with several groups: Paste, Operation, and more. By default, the All option is selected, which pastes everything: values, formatting, and formulas. Now, let's say you only want to paste formulas. You can copy the data, press Alt, E, S, choose Formulas, and click OK. This pastes only the formula, excluding any formatting. You'll see in the formula bar that the formula is preserved, but the cell's color or font is not. If you select values instead, only the final result of the formula is pasted. No formula, no formatting. I highly recommend using paste as values often, especially if you're preparing data for sharing or finalizing reports. Next, let's discuss some less common but useful options. Paste comments allows you to paste only the comments attached to cells, useful for documentation or collaboration. There's also an option to paste everything using source theme, which applies the theme formatting from the original file. Another option allows you to exclude borders while pasting. Let's say you copy a range with borders. Using this option, everything except the borders gets pasted. Then there's column width. This ensures the pasted content retains the same column width as the source. You might need to use this in two steps. First, paste the data, then paste the column width. There are also combinations like formulas and number formats, which paste formulas along with number formats, but skip color and other formatting. Similarly, values and number formats only pastes values with number formatting. Now, onto operations, a powerful feature. You can use Paste Special to apply basic math functions like add, subtract, multiply, or divide directly during the paste. For example, to double a set of prices, type 2 in a cell, copy it, select your price range, go to Paste Special, choose Multiply, and hit OK. You can also perform addition, subtraction, and division the same way. Another helpful option is Transpose. If your data is in rows but you want it in columns, simply copy the data, use Paste Special, choose Transpose, and click OK. It switches rows to columns or vice versa, very handy. Finally, let's look at Paste Link. If you want to link data from one sheet to another, copy a cell, go to your target location, open Paste Special, and choose Paste Link. This creates a live reference, such that any updates in the original cell reflect automatically in the linked cell. For example, it will appear like is equal to sheet 1, A1. This is a quick and efficient way to maintain live data connections across sheets. There are even more options, especially around formatting and working with images, which we'll explore in the advanced section. Thanks for watching. If you have any questions, feel free to ask. I'll do my best to help you as soon as possible. Thank you. Hello everyone, and welcome back. In today's video, we'll explore an amazing feature in Microsoft Excel called Autofill. Let me give you a simple example. Imagine you have a dataset with 10,000 rows related to customer orders. Your task is to add serial numbers in column A. Now, if you're unaware of the autofill feature, you might start typing manually like 1, 2, 3 and continue all the way down. But if you know how autofill works, you can save a lot of time. Here's how. Enter the first few numbers in the series. Say 1, 2, 3. Then select those cells and double-click the bottom right corner of the selection. Excel will automatically fill in the rest of the serial numbers based on the pattern it detects. If your pattern was 1, 3, 5, for example, Excel will continue the series accordingly. Now, autofill isn't limited to numbers. Let's insert a new worksheet and try it with dates. Enter 1st January 2025 in the first cell. There's no need to type the next date. Just select the cell and drag it down. Excel will automatically fill in a continuous series of dates, 2nd January, 3rd January, and so on. If there's adjacent data on the left or right, you can even double-click the fill handle to automatically extend the series to match the length of your dataset. Once you've used autofill, a small autofill options button will appear. Clicking it reveals several options that are mostly self-explanatory. For instance, if you want to fill only weekdays, months, or years, just select the appropriate option. If you choose Fill Months, Excel will increment by month instead of day. So you'll get 1st January, 1st February, 1st March, and so on. Autofill also carries over formatting if you've applied it. Let's say you've added colors, changed the font, and adjusted the column width. When you drag the fill handle down, Excel copies not just the data, but the formatting too. If you click the Autofill Options button, you'll see other choices like Copy Cells, which duplicates the same value in all cells, Fill Series, which continues the pattern, Fill Formatting Only, which keeps the look but clears the data, or Fill Without Formatting, which keeps the data but drops the formatting. You may already know this. In Excel, dates are stored as serial numbers. So if the formatting is removed, you might see numbers like 45,291 instead of readable dates. That's totally normal. Just reapply the date format if needed. You can also use autofill for text-based sequences. For example, if you enter Sunday and drag down, Excel will automatically fill in the rest of the week, Monday, Tuesday, and so on. The same works for months, Jan, Feb, Mar, and Excel detects whether you're using abbreviated or full names and fills them accordingly. Finally, there's another powerful tool called Flash Fill, which we'll cover in the advanced section of this Excel course. Stay tuned for that, and thanks for watching. Hello everyone, and welcome back. In today's video, we're going to talk about the filter option in Excel, which helps us filter data based on our specific requirements. For example, imagine you have a large dataset containing order details from different customers. You can use the filter feature to isolate only the data you need. Let's say you want to view only the data for orders shipped via first class. To do this, you can use the filter option, which is available under both the data menu and the home menu in Excel. I usually use the keyboard shortcut for this, Alt-A-T on a Windows keyboard. When you press this, you'll see a small drop-down arrow appear on each column header. Click on the arrow in the Ship Mode column, and a list of options will appear. First, deselect all options, then check only first class, and click OK. Now, your table will display only the rows related to first-class shipments. You'll also notice that the filtered rows are highlighted in blue, while the unfiltered rows below remain in black. You can continue navigating using either the mouse or the keyboard. If you want to further filter by a specific state, keep using the keyboard. Press Alt plus down arrow to open the drop-down again. Use the arrow keys to navigate. Press spacebar to deselect all. Then check your desired state, like Georgia, and press Enter. Now, the data is filtered by both ship mode and state. You can apply as many filters as needed. Another way to apply a filter is by right-clicking on a specific cell and choosing Filter by selected cell's value. Filters can also be applied based on color, font, or icon. Once you're done with filtering, you can remove the filter by going back to the drop-down and selecting Clear Filter, or simply use the shortcut Alt-A-C. Excel mainly works with three types of data: numbers, dates, and text. Each data type offers different filter options. For number filters, click the drop-down, go to Number Filters, and you'll see options like equals, does not equal, greater than, less than, between, top 10, above average, and custom filter. Let's say you want to view values greater than 1000, choose greater than, enter 1000, and click OK. To apply a range filter, say between 1000 and 1500, choose between and enter both values. To clear this, again use Alt-A-C or the Clear Filter option from the menu. Next, for date filters, when you click the drop-down, dates are grouped by year, month, and then day. You can expand each level and select specific dates. Under date filters, you'll find options like equals, before, after, between, tomorrow, next month, this quarter, and more. These options allow for highly specific filtering using calendar selections or custom criteria using and/or logic. Finally, let's look at text filters. Suppose you want to filter customer names. Click the drop-down, go to Text Filters, and choose options like equals, does not equal, begins with, ends with, or contains. If you select Contains and type Ken, Excel will display all names containing those letters. For more precision, use equals. Similarly, if you use begins with and enter her, you'll get all names that start with those characters. These filtering options are powerful and easy to use. Take some time to practice with your own data, and you'll get the hang of it quickly. Thanks for watching. Welcome to another episode of Excel tutorial. In this video, we're going to start learning how to use functions in Excel. Before we move forward, let's understand a few basic concepts, just like we learned in school. For performing calculations, we use symbols such as plus, minus, and so on. Similarly, in Excel, we use special symbols to perform calculations. As you can see here, for addition, we use plus sign. For subtraction, minus sign. For multiplication, asterisk sign. For division, /. To perform comparisons in Excel, we also use symbols like is equal to and so on. Now, let's see how to perform a simple calculation in Excel. For example, let's say we have the numbers 10 and 20 in two different cells, and we want to add them together. There are two ways to do this. Like a regular calculator, using cell references for dynamic calculations. Whenever we want to perform a calculation, we always start with an equal sign. As soon as you type equal, Excel understands that you're entering a formula, and most of the other options will be grayed out. So for a simple calculation, just type is equal to 10 plus 20, and then press enter. The result will appear immediately. But remember, Excel is not meant only for static calculations like this. We use Excel to perform dynamic calculations where the result updates automatically when the input values change. That's why we use cell references. So instead of typing the numbers directly, we'll use something like is equal to E4 plus E5. This way, If the values in E4 or E5 change, the result will update automatically. Now, instead of just pressing Enter, if we press Ctrl plus Enter, the cursor stays in the same cell. This is a useful shortcut. Also, if you look at the formula bar, you'll see the formula with cell references, not the actual values, which means the result is dynamically linked. Now let's take a real example. Suppose we have quantity and rate, and we want to calculate the amount. We'll use is equal to J5 asterisk A5. Then press Ctrl plus Enter. As we learned in the previous video, just double-click the fill handle to autofill the formula down the column. And if you want to check the formula in a cell, just press F2 on your keyboard. This will show you the references used in the formula. Now let's say we want to calculate the total of all amounts. Instead of adding each one manually, we'll use Excel's inbuilt sum function. Select the range either with your mouse or keyboard, close the bracket, and press Enter or Ctrl plus Enter. The best part? This result is also dynamic. If any value in the range changes, the total will update automatically. And this is the real power of Excel, something you can't do with a regular calculator. In upcoming videos, we'll explore different types of Excel functions and learn how to use them effectively. Thanks for watching, and stay tuned for the next video. Hello everyone, and welcome back. In the last video, we learned about simple mathematical calculations in Excel. We explored some examples where we multiplied rate and quantity to calculate the amount using cell references. In today's video, we're going to understand those cell references in more detail. Each cell in Excel has a unique name, which is a combination of the column letter and the row number. For example, the currently selected cell is named J7, and you can see this name in the name box. Whenever I want to use this cell in a function or formula, I can refer to it as J7. This is something we've already covered briefly, but let's go deeper. There are 4 types of cell references in Excel. First, relative reference. This is completely relative, which means the reference changes automatically when you copy the formula to another location. Let me show you an example. We have quantity and rate values in cells. As we did in the last video, we'll calculate amount by multiplying them. So, in the formula, we use the reference C22 for quantity, use the asterisk for multiplication, and reference D22 for rate. Now press Ctrl plus Enter to confirm. We have a working formula. When I copy and paste this formula into the cells below, and press F2, you'll see that the references have automatically adjusted. This is called a relative reference. No restriction. The cell references adjust according to the new location. Second, absolute reference. This one's very important, and you'll use it frequently, especially in real-life tasks. An absolute reference doesn't change when the formula is copied. To make a reference absolute, we add a $sign before the column letter and the row number. For example, A1 becomes $A$1, which locks both column A and row 1. Let's take an example. We have subtotals, and we need to calculate sales tax. If we use a relative reference for the tax rate and copy the formula down, the tax rate reference also changes, and that causes incorrect results. But if we use an absolute reference example $D$28 for the tax rate, it will remain constant even after copying the formula. Here's how to do it. Type is equal to E22 asterisk $D$28. Or select the cell and press F4 to automatically apply the absolute reference. Now when I copy this formula down, the subtotal reference updates, but the tax rate reference stays fixed, giving us the correct tax calculation. Third row, absolute reference. This is a partially absolute reference, where only the row is fixed and the column can change. For example, $16 means row 16 is locked, but the column can vary. Let's say we have a list of sales amounts by sales representatives, and different commission rates are listed above. We want to calculate commission amounts. We start by selecting the commission rate and pressing F4 twice. This applies the row absolute reference example L$16. Then multiply by the sales amount L18. Press Ctrl plus Enter, then copy and paste the formula down. You'll notice the commission rate stays fixed in the same row, but adjusts across columns as needed. This is how row absolute referencing works. Row stays constant, column changes as needed. Fourth column absolute reference. Just like the previous one, but here the column is fixed and the row can change. To do this, we press F4 3 times. So we get something like $16 becoming $T16. Let's use the same example of calculating commissions. We'll select the commission rate, press F4 3 times to make the column absolute, then multiply it by the respective sales amount. When we copy the formula across cells, you'll notice that the column stays fixed, but the row updates as expected. These types of cell references are extremely important when working with formulas in Excel. They allow you to build dynamic, accurate, and efficient spreadsheets. Thanks for watching. If you have any questions, feel free to drop them in the comments. In the next video, we'll dive into a brand new topic. See you there. Welcome back everyone to another Excel tutorial. In today's video, we're going to talk about how to handle different types of errors in Excel. When we work in Excel and do calculations or use references from other sheets or cells, sometimes we don't get the result we expect. Instead, Excel shows different types of errors. So, in this video, we'll learn how to tackle these errors, understand the reason behind them, and go through live practical examples to see what causes these errors and how to fix them. Let's start with the first common error in Excel, which is the #div0 error. This error appears when you try to divide a number by 0 or by an empty cell. For example, if you divide 100 by 0, Excel shows this error. This happens because Excel cannot divide a number by 0. It's not a valid calculation. The same thing happens if you divide by a blank cell. So, if you ever see this error in your sheet, it usually means you are dividing by 0, the cell is empty, or you might have used the wrong cell reference. To fix it, check the cell you're dividing by and make sure it's not 0 or blank. The second common error in Excel is the #name error. This error usually happens when you make a spelling mistake in a built-in function, or when you refer to a named range that doesn't exist or is spelled incorrectly. For example, if you want to use the sum function to calculate sum of a range, it works fine. But if you accidentally type =SAM instead of SUM, Excel doesn't recognize the function and shows the #name error. So, if this error appears in your sheet, make sure to check the spelling of your function names and any named ranges you've used. Correcting the spelling will fix the issue. The third common error in Excel is the #NA error. This error usually appears when you're using lookup functions like VLOOKUP or HLOOKUP, and the value you're trying to find is not available in the given range. For example, if you search for the number in a list and that value doesn't exist, Excel will return the NA error. But as soon as the correct value is found in the range, the error goes away. So, this error simply means that the searched value is not available in the specified data. The fourth common error in Excel is the #null error. This error happens when you forget to add a comma between two ranges in a formula. For example, if you want to calculate the sum of two ranges, use some function and give the cell ranges using comma, it's correct. But if you accidentally leave out the comma and type the sum function without comma, Excel doesn't understand the formula and shows the null error. To fix this, just make sure to add the comma between the ranges and Excel will give you the correct result. The fifth common error in Excel is the #num error. This error appears when your formula contains an invalid number. For example, if you try to calculate the square root of -1 using the formula is equal to sqrt -1, Excel will show the num error. That's because negative numbers don't have real square roots. To fix this error, you just need to make sure you're using a valid number in your formula, and Excel will return the correct result. The sixth common error in Excel is the #ref error. This error shows up when a cell reference becomes invalid, Usually because a cell that was being used in a formula has been deleted. For example, if you calculate sum of using two cells, give reference, then delete any cell, the formula will return the #ref error. This means that Excel can no longer find the referenced cell. To fix it, simply check for any missing or broken references and update them correctly. The seventh common error in Excel is the #value error. This error occurs when your formula uses the wrong type of data. For example, if you try to add a number and a text value, like type 10 in number in one cell and 20 as text in another cell, then try to calculate sum, Excel won't understand how to calculate it and will show the #value error. That's because Excel can't perform math using a mix of numbers and text. To avoid this error, make sure that the values in your formulas are using the correct data types, especially when doing calculations. So friends, now you've learned what these common Excel errors mean, why they happen, and how you can fix them with simple steps. If you want to work smart and efficiently in Excel, it's really important to understand and handle these errors properly. If you have any questions or doubts related to this topic, feel free to drop them in the comments section. I'll do my best to answer them as soon as possible. Thank you. Hello everyone. Welcome back. In today's video, we're going to talk about a very important topic, circular references. By now, we've learned how to use formulas in Excel, where we reference different cells to perform calculations and make our sheets dynamic. This means whenever we update a cell value, the result updates automatically. However, sometimes we make a mistake without realizing it. One such mistake involves circular references. If you're not familiar with them, they can cause issues in your calculations without you even knowing. So, let's understand what circular references are. When we perform calculations in Excel, we usually reference other cells. But if the formula in a cell ends up referring back to the same cell, either directly or indirectly, Excel cannot calculate the result because the cell is essentially depending on itself. Let me explain with an example. Suppose we have a few values here, a principal amount, a period, and a rate of interest. We want to calculate the interest using a simple formula. Principal times period times rate divided by 100. That works fine. The formula gives us the result based on the values in three different cells, say B5, B6, and B7. But now imagine, by mistake or without knowing about circular references, I include the cell where the interest is being calculated, let's say B8, as part of the formula itself. If I press Ctrl plus Enter, Excel shows an error message. There are one or more circular references where a formula refers to its own cell either directly or indirectly. Now nothing shows up. So what happened? Earlier, the formula was dependent only on the three input cells. But now, by referencing the same cell within its own formula, we created a loop, and Excel doesn't know how to handle it unless we guide it. In such cases, we can enable iterative calculations in Excel. Here's how. Go to the File menu Options Formulas, and there you'll find an option called Enable Iterative Calculation. Turn it on. Now, you can specify how many times Excel should attempt the loop, say 100 times, and click OK. Once done, Excel will go through that loop up to 100 times and try to give you a result. That said, this feature is rarely used. Personally, I haven't had to use it much in my career, but it's important to understand how to handle it if you ever face this issue. For now, I'm going to disable this option again because we don't need it in our current work. In Excel, since we have access to unlimited cells, we should aim to structure our formulas properly for accurate results. And that's why we use Excel to perform correct and efficient calculations. So make sure this concept is clear to you. Thanks for watching. Stay tuned for the next video. Welcome back to the Excel course. In the previous videos, we explored the basics of Excel, from navigating the interface to entering and formatting data. Now, it's time to take your skills to the next level with one of Excel's most powerful tools, Inbuilt Functions. In this lesson, you'll learn what inbuilt functions are, how they work, the key components behind them, and how to apply them using a real example. Let's get started. Inbuilt functions are predefined formulas built into Excel. They help you perform common tasks quickly and accurately, like summing values, finding averages, counting entries, or working with dates and text. Rather than writing lengthy formulas manually, Excel provides these functions to save you time and ensure consistency in your calculations. When you enter any value in an Excel cell, like a number, word, or date, Excel treats it simply as data. But when you want Excel to perform a calculation or use an inbuilt function, you need to let it know that what you're entering is a formula. To do that, every function in Excel must start with an equal sign. The equal sign tells Excel, this is not just data, it's something to calculate. After the equal sign comes the function name, like sum, average, or if. This tells Excel what kind of task you want to perform. Inside the parentheses that follow, you provide arguments. These can be numbers, text, or cell references. For example, if you type is equal to sum A1, A5, you're instructing Excel to add the values from cell A1 to a 5. Without the equal sign, Excel would just display the text sum A1, A5 and not perform any calculation. So always remember, the equal sign is your way of activating Excel's powerful formula system. Let's take a closer look at the key elements that make up every function in Excel. First, there's the function name. This tells Excel what kind of task you want it to perform. For example, the sum function adds numbers, average calculates the mean, and if applies a logical condition. Next, we have the parentheses, which are used to enclose the function's inputs. These are called arguments. Arguments are the values, cell references, or even other functions that Excel uses to carry out the calculation. Now, it's important to know that there are two types of arguments, mandatory and optional. Mandatory arguments are required. Without them, the function won't work. Optional arguments can be included to give you more control, but they're not necessary for the function to run. For instance, in the round function, both arguments, the number and the number of digits to round to, are mandatory. On the other hand, in a function like VLOOKUP, the fourth argument, range_lookup, is optional. If you leave it out, Excel assumes you want an approximate match by default. Excel also helps you by displaying tooltips while you type, showing which arguments are required and which are optional. Optional ones usually appear inside square brackets. Finally, once the function runs, Excel returns a result. This is called the return value, and it appears right in the cell where you entered the formula. So in summary, every Excel function is made up of a function name, parentheses, one or more arguments, which can be mandatory or optional, and a return value. Hello and welcome back. In the last video, we learned about inbuilt functions in Excel. Now it's time to do some practical examples. I have a data set with 10,000 rows of order data. I've been given a few tasks to perform on this data. First, I need to extract the year from the shipping date in column D. Second, I need to extract the first two letters from the customer ID. And finally, I need to extract the first name from the customer's full name. Let's see how we can practically perform these tasks in Excel. To begin with, I'll use the keyboard as much as possible and avoid using the mouse to save time. First, I'll press Ctrl plus Home to go to the first row, then move one row down, and freeze the top row using Alt, W, F to activate the freeze panes feature we learned earlier. This way, the headers remain visible while scrolling through the data. Next, I'll insert a new column to the right of the ship date column. For this, I use Ctrl plus space to select the column, then Ctrl plus Shift plus plus to insert a new one. I'll name the column Year and press Enter. Now, to extract the year, I'll use the year function. I'll start by typing is equal to year and then select the cell with the date. Once done, I'll close the parenthesis and press Ctrl plus Enter. The function is working, but the value is showing in date format. So, I'll change the format using Alt, H, N, then use the Alt plus down arrow to open the format dropdown and select General or Number. Now, either double-click to fill the formula down or use keyboard shortcuts. Ctrl plus C to copy, go down with Ctrl plus down arrow. Select the range with Ctrl plus Shift plus up and then paste. That completes the first task. Now for the second task, extracting the first two letters of the customer ID. I'll again insert a new column using Ctrl plus space and Ctrl plus Shift with plus. I'll name the new column customer short or something similar. Then I'll use the left function. I'll type is equal to left. Select the cell with the customer ID and enter 2 as the number of characters, then close the bracket and press Ctrl plus enter. This gives the correct result. I'll copy and paste the formula as before. Now, the third task is to extract the first name from the full customer name. Since first names vary in length, we need to use a combination of functions. First, insert a new column and name it first name. We'll again use the left function, but this time, the number of characters will be dynamic. For that, I'll use the search function inside the left function. The formula would be something like is equal to left, cell, search, cell, 1. This works by locating the position of the first space using search, cell, then subtracting 1 to exclude the space itself. This way, we get the first name accurately. Press Ctrl plus enter, and the result appears correctly. I'll double-click to apply the formula down the column. And that completes our 3 tasks using inbuilt Excel functions. In upcoming videos, we'll explore more advanced functions and practical use cases. So, stay tuned for the next one.
Hello everyone, welcome back. In today's video, we will explore 3 important Excel functions: sum, sumif, and sumifs. Alongside that, we'll go through several practical examples to help you understand how to use these functions in real-life scenarios to simplify your daily task. Let's start with the sum function, which most of us are already familiar with. We have used it many times to add numbers and calculate totals. The syntax is very simple. Type equal to sum followed by the numbers or a range of cells you want to add. You can enter numbers manually separated by commas or refer to a range. In Excel, we can apply this in many ways. The most common use case is summing a column of numbers typically placed just below the range. To do this, simply click the cell where you want the total to appear, go to the Home tab and click Auto Sum. Excel will automatically detect the range above and suggest it. If the suggestion is correct, press enter and your sum will be calculated. You can also use a shortcut, press Alt plus equal to and then hit enter to get the same result. Another method is by clicking the Insert function button next to the formula bar, typing sum into the search bar, selecting the function and clicking OK. You can then select your range directly in the dialog box and press OK to calculate the sum. Let's take it a step further. Suppose your data is spread across multiple ranges and you want to calculate the total of all of them. You can simply write equal to sum of, select the first range, type a comma, then select the second range, close the bracket and press enter. This will give you a dynamic total, which means the sum will automatically update whenever the values in the ranges are changed. Now let's move to the next function, sumif. We have already seen how the sum function works. But what if you want to add only the numbers that meet a specific condition or criteria? For example, say you have daily sales data and each sale is tagged with a channel like online or in store. If you want to calculate only the sales made through the online channel, you will use the Sumif function. The syntax for Sumif is equal to Sumif, radius, criteria, and sum range. Range is where your condition will be applied. For example, the channel names. Criteria is the condition you are checking for example, online. Sum range is the range of numbers you want to total if the condition is met. Let's make it dynamic. Suppose I want to enter the channel name like online or in store in a separate cell and have the total update automatically based on that input. In that case, instead of typing the criteria directly in the formula, you reference the cell where the criteria is written. For example, if the criteria is in cell F12, you write the formula in D17 like this. Sumif channel range F12 sales range. A few key points to remember. If you are entering the criteria directly in the formula, wrap it in quotation marks. For example, online. The size of the range and sum range must be the same. They should align cell by cell for accurate results. This function is not case sensitive, meaning it doesn't matter whether the text is in uppercase or lowercase. Now, suppose I want to check totals for different criteria one after another. For instance, first for online and then for in store. I don't need to rewrite the formula. I can just change the text in the criteria cell and the result will update automatically. Lastly, I used a keyboard shortcut here, Alt plus E plus S plus V, which is a quick way to use paste special in Excel. You could also go to the Home tab and click Paste Special manually. Either way, it gets the job done. And as you can see, the total updates instantly. This is how you can use sum and sumif functions efficiently in your Excel workflow. Next, we will look into sumifs for even more advanced conditions. Now, let's move on to an even more advanced function, which is sumifs. Earlier, we were working with only one criterion using sumif, but with sumifs, we can use multiple criteria. To use this, we start by defining the sum range, that is, the range of values we want to total. Next, we specify the criteria range and the corresponding criteria, and we can add as many of these as needed. As we continue entering the ranges and criteria, the filter total will automatically update. For example, let's say I want to calculate some data. I'll start by typing equal to sum ifs, then press tab to activate the formula. First, I give the sum range followed by a comma. Now I'll give my first criteria range and note that it's labeled criteria underscore range 1. Then I give the criteria 1, referencing a cell directly, just like we did in the previous video. After that, I enter the second criteria range, followed by the second criterion, and finally close the brackets. Since I haven't provided any actual criteria yet, the total isn't being calculated. But once I paste the values and set a specific filter, for example, if I want to see the total for Monday, the results will appear accordingly. Remember, I'm just using a small example range for simplicity. In real world cases, you'll often deal with thousands of rows, like in the sheet you'll be downloading. That's when these functions become incredibly useful. Now, let's move toward even more advanced options. Here's an example. I have a dataset that includes dates, regions, and sales. I've been asked to find out how much sales occurred in the North region between January 1st and January 31st. Let's see how we can calculate that. I've already written the formula, but I'll type it again to show you how we can do this quickly and efficiently. Because being fast and smart is key in data handling. First, we type the function equal to sumifs and press tab. Then we define the sum range followed by a comma. Next, we enter the criteria range for the date, and since we are filtering by a date range, our first criterion will be equal to January 1st, 2024. Make sure this is within double quotes. Press comma again, and now we provide the same date range, but this time the criterion will be comma equal to 31st January 1st, 2024. Again in quotes. Now we give the region range as another criteria range and then type north as the criterion. You can also make this dynamic by referencing a cell instead of typing north directly. Next, let's explore wildcards. In this example, I have product names and sales data. Suppose I've been asked to total sales for any product that starts with Pro. Earlier, we worked with full names, but now we'll use wildcards for partial matches. To do this, we use is equal to sum ifs again. Select the sum range, then provide the criteria range which includes product names. For the criterion, use pro asterisk, where the asterisk works as a wildcard for any characters following pro. Close the brackets and press enter, and you'll get the total, say 750, which is exactly what we expect. Now let's go to an even more advanced example. Imagine I have 10,000 rows of order data. I want to enter a region, then specify an amount and find out the total sales for that region, but only for orders less than the given amount. Here's how to do it dynamically. Start with equal to sumifs, press tab, then move to the sheet with your data using Ctrl plus page down. Use Ctrl plus home to go to the top. Then select the sales range using Shift plus Ctrl plus down arrow. Press F4 to lock the range with dollar signs. Press comma. Then again go to the top using Ctrl plus home and select the region range using the same Shift plus Ctrl shortcut. Press comma. Then refer to the cell on your summary sheet where the region name, e.g. South, is entered, say C32. Make sure not to click with the mouse if you don't want the sheet name to appear in the reference. Now, for the second criteria, we'll apply a less than or equal to condition on the sales amount. Type equal to the enter C33, where C33 contains the amount input. This combines text and cell reference using enter, making it dynamic. Press enter and the total will update automatically based on the region and amount entered. So this way we use dynamic combinations of functions to handle complex sales filters. Make sure to practice this with the downloadable sheet and try different criteria combinations. If you have any questions or queries, drop them in the comment section. I'll do my best to answer them all. Thank you friends for watching. Stay tuned for the next video. Hello everyone, welcome once again. In today's video, we are going to learn about three very important built-in functions in Excel: average, Averageif, and Averageifs. The average function is used to calculate the average of a given set of numbers. For example, if we have a list of students' scores and want to find the average, we simply use the average function. We start with the equal sign, type average, select it, and press the Tab key. You can either input numbers directly, use cell references, or provide a range separated by commas. However, giving a full range is the most efficient method, especially if your data is available in a structured table format. After closing the bracket and pressing enter, you'll get the average. As most of you already know, the average is calculated by summing all the numbers and dividing by the total number of values. This is also called the arithmetic mean. That's how we use the basic average function. Now, what if you want to calculate an average based on a specific condition? For instance, if we have student names and their scores, and we want to find the average score of a particular student, you don't need to manually segregate the data. In such cases, we use the Averageif function. This function takes three arguments: the range, the criteria, and an optional average range, which we usually end up needing. Even though it's called optional, it's essential to define what exactly you want to average. To make this dynamic, we'll reference a cell, say E15, right below the criteria label. You can copy paste any student's name here, and the function will automatically calculate the average score for that student. This is done using Averageif. Remember, it supports only one condition. First, we define the range where our criteria student names exist. Then we give the criteria, either typed directly in quotation marks or by referencing a cell for dynamic input. Lastly, we specify the range to average, like the score column. Close the brackets and press enter. The result will be calculated accordingly. Now, if we want to make it fully dynamic, we can delete the fixed name and instead use a cell reference. That way, whenever we change the student name in the criteria cell, the average gets updated automatically. While Averageif works great for a single condition, what if you have multiple conditions? For that, we use the Averageifs function. It allows you to apply multiple criteria like filtering by month and salesperson. Let's say we have a data set of monthly sales by regional salespersons. We want to calculate the average sales dynamically by selecting both a month and a salesperson. So for example, if I choose January and select a salesperson, the function should return their average sales for January. We start with equal to Averageifs. This time the first argument is the average range, that is the sales figures. Then we specify the criteria ranges and their respective conditions. The first range is for salespersons, followed by the salesperson name, again either typed or referenced. The second range is for months, followed by the month criteria. After closing the brackets and pressing enter, the formula will return the average value based on both criteria. For example, if Dev made one sale of 550 in January, it will show 550. If I change that value to 500, the average will update instantly. This method works even better when the data range is larger. If you have any questions related to this topic, feel free to write in the comments section. I'll try my best to respond as soon as possible. Thank you friends for watching. Please come back again.
Hello everyone, welcome back. In today's video, we're going to explain and learn about four built-in functions. The first two are min and max, which are used to find the smallest and largest numbers in a dataset. The syntax is very simple. You can use a range or provide different numbers separated by commas. It works just like the average or sum functions we've used earlier. Next, we'll learn about minifs and maxifs. These functions allow us to apply conditions or criteria. You can use a single condition or multiple conditions. For a single condition, you just provide one criteria range and the criteria itself. For multiple conditions, You provide two criteria ranges along with their respective criteria, and Excel will filter the values accordingly. There's no separate function for handling single versus multiple conditions. Minifs and maxifs handle both. First, we'll use the min function, type is equal to min, and then provide the numbers or the range from which you want to find the minimum value. Close the bracket and press enter. Done. Similarly, for max, use is equal to max, enter the range, close the bracket, and press enter. Very simple. Now let's move on to the conditional part. For example, if I want to find the minimum value based on a specific region, I'll use the minifs function. The syntax is equal to minifs, range, criteria underscore range, criteria. In this case, the criteria, say, region, is stored in cell F13 to make it dynamic. Once entered, the formula will return the minimum based on that region. If you change the value in F13, the result updates automatically. To use minifs with multiple criteria, the structure is the same. Just add another criteria range and its corresponding criteria in the formula. Close the bracket and press enter. Now let's do the same for maxifs. It's almost identical, no difference in logic. First, you define the maximum range, then the criteria range, and finally the criteria itself. For multiple conditions, you define two criteria ranges and two criteria. After that, close the bracket and press enter. Once you start changing the criteria values, you'll see the results update automatically. You can download this file and reuse the examples for practice. If you have any questions or doubts related to this topic, feel free to write them in the comment section. I'll try my best to answer them as soon as possible. Stay tuned for the next video. Thank you. Hello everyone. Welcome back to the Excel tutorial series. In this section, we're going to explore some important date-related built-in functions and calculations in Excel. Although we've already used dates in some basic operations, it's essential to first understand how Excel actually handles dates. As I mentioned earlier, Excel stores dates as serial numbers. For example, the serial number 1 represents 1st January 1900. If you type the number 1 into a cell and then format it as a date from the Home tab, Excel will display it as Sunday, 1st January 1900. Similarly, the serial number 2 will represent 2nd January 1900. This means that behind every visible date in Excel, there is a serial number doing the work. This makes it possible to perform various date calculations using formulas and built-in functions. With dates, we can calculate the number of days between two dates, determine the difference, and even create dynamic reports. But there's much more to it than just that, and I'll show you some live, practical examples to help you understand better. You've already learned how to enter a date in Excel. You simply use slashes or dashes as separators. For example, if I type 01/01/2025, Excel will automatically recognize it as a date. As soon as you select the cell and check its formatting from the Home tab, you'll notice it's set to a date format. You can choose from different date format options here as well. Now let's talk about one of the most important and dynamic date functions in Excel, the Today function. Today doesn't require any arguments and returns the current system date. That means every time you open the workbook, the date will automatically update to reflect the current day. You can format it as a long date or a short date, whichever suits your needs. You might be wondering, where would this be practically useful? Let me give you an example. Imagine you've built an interest calculation sheet for your customers. Since interest needs to be calculated daily, using the Today function helps update the number of days automatically. So your interest values will always stay accurate. Similarly, if you maintain a list of outstanding invoices and want to check if any of them are overdue, Today can help identify those that have crossed their due dates. Another great use case is in reports. Let's say you want to display today's date at the top of a report. Instead of typing it manually every day, you can use the Today function so that it updates automatically. You can even combine Today with text using the text function and the ampersand symbol to display a proper sentence. For example, if you want the sentence to say, today is 3rd July 2025, you can write this formula, equals today is ampersand text open bracket today open and close brackets, comma, and then in quotes, the format you want, like ddmmyy dot. Close the text function and press enter. Excel will now show the sentence with today's date, and it will keep updating daily when the file is opened. Now let's move on to another important function, the date function. This is used to create a date when you have separate values for the year, month, and day. The syntax is simple, equals date open bracket, year, comma, month, comma, day, and then close bracket. You can reference other cells for each part. This is very useful when you need to combine values into a single date, or when your calculations return individual parts of a date and you want to reassemble them. For example, if you have year, month, and day in 3 different cells, you can use the date function to combine them into a proper date. This also stays dynamic. If any input changes, the date automatically updates. Next, let's talk about the date value function, which is especially useful when you import data from systems like ERPs or the web. Sometimes, dates appear in text format, and Excel doesn't recognize them as actual dates. That means you can't use them in any calculations. In such cases, you use the date value function to convert a text-based date into a proper serial number. For example, if you have a date written as 25th July 2025 in a text format, Excel won't treat it as a real date. But when you apply the date value function to that cell, Excel will convert it into a valid serial number representing that date. Once it's converted, you can format it and use it in any kind of calculation, just like a normal date. So these were some powerful and commonly used date functions in Excel: today, text, date, and date value. Make sure to practice them using the worksheet we've provided for download. In the next video, we'll continue exploring more advanced and useful date-related functions. Thank you for watching. So friends, let's begin with our second example. In the first one, we learned the basics. Now, we'll start learning about calculations. These are primarily used to find differences between dates, though the purpose can vary. For instance, if we perform a simple subtraction, we can get the difference. In this example, I've entered a start date and an end date to demonstrate. We can begin the calculation by typing the equals sign. As you may already know, subtraction is always done by subtracting the smaller value from the larger one. So, if we subtract a past date from a recent date, we'll get a positive number. For example, if we subtract 1st January 2025 from 11th January 2025, the result will be 10 days. This is because the 11th day hasn't been completed yet. We're calculating the difference, not the total number of days completed. Now, if we want to calculate the difference using a built-in function, Excel provides one called days. It's designed to calculate the number of days between two dates. The syntax is very simple. It takes only 2 arguments, both of which are mandatory. Start with the equals sign, type days, then open the bracket. First, enter the end date, followed by a comma, then the start date. Close the bracket and press enter. That gives you the result. There's another function called Datedif, which we'll explore in detail later. This function is extremely useful. Though it's considered a hidden function, you won't find it listed in Excel's formula suggestions or the function search. But it works perfectly. Datedif takes 3 arguments: the start date, the end date, and a unit, for example, D for days. So, when we start typing Datedif, Excel may not show autocomplete help, but the function will still work. Enter the start date, the end date, and then within double quotes, type D. Press enter, and you'll get the same result, 10 days, just like with the previous methods. Among all these, Datedif is often the most useful because of its flexibility. But you can use any of these functions based on your needs. Now let's move on to dynamic calculations. By dynamic, I mean scenarios where the end date keeps changing. For example, if you're preparing an outstanding report. In such cases, you can use the today function as the end date. Let's say you have a specific start date, but you don't know the end date because it's ongoing and keeps increasing daily. So, instead of a fixed end date, we can use the today function directly in the formula or in a referenced cell. Then subtract the start date from today's date. If I use the days function with today as the end date and a specific start date, Excel will calculate the difference automatically. Each time you open the sheet, the result will update based on the current date. Now let's talk about an important function, network days. This is used to calculate working days, excluding weekends. It's especially useful for things like payroll calculations. Network days takes 3 arguments. The start date and end date are mandatory, and holidays are optional. Why include holidays? Because if there's a holiday within the date range, it should also be excluded from the working days count. For example, let's take all the days of January 2025. I've highlighted Saturdays and Sundays in yellow. I'm also considering 2 holidays, 21st January and 28th January. I've listed these holidays separately. And now when I use the network days function, I enter the start date and end date. Without entering the holidays, the result is 23 days, since 8 days are weekends. But if I include the holiday list in the formula, Excel subtracts those 2 holidays as well, giving us 21 working days. One more important point. By default, Excel considers Saturday and Sunday as weekends. But that might not apply to your country or company. For example, in some Gulf countries, Friday is the weekend. For such cases, Excel provides the networkdays.intl function. With networkdays.intl, you enter the start and end dates like before, but when you press the comma, you'll see options to choose your weekend pattern. Excel provides 17 options to customize your weekends. For example, if only Sunday is your weekend, you can select that. This way, Excel will count Saturdays as working days, increasing your total working days accordingly. Lastly, there's another useful function called workday. This is used when you know the number of working days and want to calculate the future date. For example, if a project is assigned and you have 250 working days to complete it, you can use workday to find out the completion date. Just provide the start date and the number of working days. You can also include holidays, and by default, Excel will exclude weekends, Saturday and Sunday. You'll get the expected completion date, say 17th December 2025. Again, if your weekend is different, use workday.intl. This version lets you define your own weekend pattern and calculate accordingly. So, all these functions, days, datedif, networkdays, networkdays.intl, workday, and workday.intl are extremely useful in real-world scenarios. In the next video, we'll explore another very important function, date value. We'll learn it in detail with examples. So stay with us and keep learning. Hello friends. In this video, we'll learn how to use the Datedif function in Excel. This function helps you calculate the difference between 2 dates in terms of years, months, or days. It basically takes 3 arguments. The first argument is the start date. This is the beginning of the period you want to calculate from. The second argument is the end date, the final date of the period. You can either type the date directly or use a cell reference. And the third argument is called the unit, which is very important. The unit tells Excel what kind of difference you want to calculate, years, months, or days. Below, I've listed all the units along with what they calculate. Y gives you the number of completed years between two dates. M gives you the number of completed months. D calculates the total number of days between the dates. There are also a few more specific options. MD calculates the number of days, ignoring the months and years. YM calculates the months, ignoring the years. YD calculates the days, ignoring the years. Let's understand this with an example. Here, I've entered 1st January 2000 as the start date, and for the end date, I've used today's date. When you download this file, the current date will be shown automatically, but you can change it if needed. Now, let's use the Datedif function. Just like we mentioned in the previous video, you won't find any help for this function in Excel because it's a hidden one. Here's how we write the formula. So, I start with the formula, select the start date, add a comma, then the end date, another comma, and finally enter the unit in double quotes. For example, if I type Y and press enter, it will show the number of completed years between the two dates. Now I'll copy the same formula and change the units to demonstrate different results. M will show the total number of months. D will give the total days. MD will calculate only days, ignoring months and years. YM will calculate months, ignoring years. YD will calculate days, again ignoring years. Each of these options is useful in different scenarios. I encourage you to practice using them. It's a very important and powerful function. If you have any questions related to this topic, feel free to write in the comments or the question section, and I'll do my best to help you. See you in the next video with a new topic. Thank you, friends. Hello friends, and welcome once again. In this video, we'll explore some essential time-related functions in Excel, how to enter time, calculate time differences, and use these calculations in attendance or working hours tracking, which is extremely useful. We'll go over each concept in detail, along with examples. Let's start by understanding how to enter time in Excel. As I mentioned earlier, date and time are actually stored as numbers in the background. Excel simply changes the display format to show them as date or time. For example, if I want to enter 11:30 a.m., I'll type 11, then 30 for minutes, then seconds separated by colons, followed by AM or PM. Excel will automatically recognize this as a valid time. If you enter a number like 0.54, Excel interprets it as a fraction of a 24-hour day. You can convert this number into time format using the Home tab and choosing Time Format. It will then show what portion of the day this decimal represents. If you switch the format back to General, it will display the original decimal number again, because time in Excel is simply a fraction of a full day. To enter the current system time, press Ctrl plus Shift plus. This inserts the current time as a static value. It won't update automatically. For dynamic time that updates every time the sheet is refreshed, use the Now function. This returns both the current date and time. If you only want the time, subtract today from it and format the result accordingly using the time format options. You can also display time with custom text using the text function. For example, you might write the current time is and then use the text now HH MM SS AM PM format. Remember, whenever you use text, the format must be placed inside double quotation marks. This way, your output looks clean and human readable instead of showing the raw decimal number. Next, let's say you have hours, minutes, and seconds in separate cells and want to combine them into one time value. You can use the time function, which takes 3 arguments: hours, minutes, and seconds. Just type is equal to time, hour, minute, second. If the result doesn't look right, apply a time format to that cell using the format options. Sometimes, you might copy time values from external sources like ERPs or websites. These might come in as text and won't work in calculations. In that case, use the time value function to convert the text into a proper time format Excel can work with. Now, if you want to extract parts of a time like hours, minutes, or seconds from a time value, use the hour, minute, and second functions respectively. For example, if a cell contains 11:23 and 55 seconds AM, you can extract each part individually using these functions, which is especially useful for automating attendance sheets. Let's move to the next example, calculating working hours. This is one of the most common uses of time functions in Excel. Suppose you have entry and exit times for each day. You can subtract the entry time from the exit time to get the time worked. But to get the result in hours, you must enclose the subtraction in parentheses and multiply by 24. Also, set the cell format to General to see the decimal hour value. After that, use the sum function to total the working hours for the week. If you want to calculate pay, simply multiply the total hours by the hourly rate. For example, if someone worked 20 hours and earns $20 per hour, the formula will give you the correct total pay. This method works well for regular shifts, but night shifts can be tricky. If a shift starts at 9:30 p.m. and ends the next morning at 6 a.m., the subtraction will result in a negative number. To solve this, use the mod function is equal to mod end underscore time start underscore time 1 asterisk 24. This handles the rollover across midnight and returns the correct number of working hours. Now, let's say you have decimal hour values and need to convert them into minutes or seconds. Simply multiply the decimal by 60 to get minutes or by 3600 for seconds. Similarly, if you have minutes and want to convert them to hours, divide by 60 for seconds, divide by 3600. Sometimes you may want to round these time values. For example, to round time to the nearest minute, multiply the time value by 1440, the number of minutes in a day, use the round function, and then divide back by 1440. Similarly, to round to the nearest hour, multiply by 24, round, and divide again by 24. These techniques are helpful for cleaning up your time data. And that's a complete overview of time functions in Excel. These are very important, especially when working with attendance sheets or calculating hours and pay. If you have any questions or doubts, feel free to ask in the comments. I'll try to answer them as soon as possible. Thank you for watching, and stay tuned for the next topic. Hello friends, welcome back. In this video, we're going to learn about some important logical comparison functions in Excel. Let's begin with one of the most essential functions, the if function. The if function allows you to make logical comparisons between values. So, if you have multiple values, this function helps you return either true or false. Based on the result, whether it's true or false, you can perform different actions. So basically, the if function is a decision-making tool. Here's the basic syntax. If, open bracket, logical test, comma, value if true, comma, value if false, close bracket. It has three parts. First, the logical test. This is where we tell Excel what condition we want to check. For example, we can use comparison operators like equal to, greater than, or less than, or even combine other functions within the test. Often, we use a cell reference to compare the value in that cell with something else. Second, what should happen if the condition is true? We can display a message, do a calculation, or run another formula. Third, what should happen if the condition is false? Again, we define what action Excel should take. Although the third part, value if false, is optional, we recommend you use it for better clarity. Let's take a simple example. Imagine we have students' test scores. The test was out of 100 marks. One student scored 78, another scored 48. Now we want to check. If the score is greater than 50, display pass, otherwise display fail. When we have just a few values, it's easy to write manually. But for many students, we'll use the if function. Here's how. Type equals. Then if, that's IF, and press tab. For the logical test, reference the cell with the student score, let's say B12. Then write B12 greater than or equal to 50. If the condition is true, we want to display pass. So we type pass inside double quotation marks. If the condition is false, we display fail again in double quotes. Close the bracket and press enter. Now you can copy the formula down to the other rows. You'll see that wherever the score is above 50, Excel shows pass, and where it's less, it shows fail. Let's look at an advanced use case. We have salespersons and their monthly sales. Based on their performance, they get a bonus. The rule is, if someone makes sales greater than or equal to 1 lakh, that's 100,000. They receive a 10% bonus. Otherwise, they get a fixed incentive of 2,000 rupees. Here's the function. Equals. If, then open bracket. Give the reference for the sales amount. Let's say the sales are in cell G5. Now write the condition. G5 greater than or equal to 1 lakh. If that's true, we calculate the bonus as G5 multiplied by 10%. Otherwise, simply write 2000. Close the bracket and press enter. Now, use Ctrl plus D to copy the formula down. To check the formula, press F2. You'll see that for sales above 1 lakh, the bonus is calculated. Otherwise, a flat 2000 rupees is given. One more advanced scenario. We want to check if an employee is eligible for a loan. There are two conditions. Credit score must be 700 or more. Monthly income must be 25,000 or more. Only if both conditions are true, the employee is eligible. For this, we use the AND function inside the if. Here's how the formula goes. Equals, if, open bracket, then AND, open bracket again. First condition, credit score cell, let's say D5, greater than or equal to 700. Then a comma. Second condition, monthly income may be E5, greater than or equal to 25,000. Close the AND bracket. Now, if both are true, we display eligible, otherwise not eligible, both inside quotation marks. Close the final bracket and press enter. Try changing the values. For example, reduce the income to 20,000 and it shows not eligible. Now reduce the credit score to 600 and again it becomes not eligible. That's how the if function works with multiple conditions. In the next video, we'll learn about more advanced logical functions, where we can handle even more conditions easily. So stay tuned for the next part. Hello everyone, welcome back. In the last video, we learned about the if function, which helps us check a single condition and take action accordingly. But what if we have multiple conditions to evaluate and want to take action based on which condition is true? In such cases, we can use nested ifs, but those formulas can get very complicated and hard to manage. That's where Excel gives us a better solution. The ifs function, spelled as IFS. So in this video, we will talk about the ifs function and learn how and where to use it. The ifs function is a logical function that allows you to test multiple conditions and take action based on the first condition that is true. The basic syntax is equals IFS, then condition 1, action 1, condition 2, action 2, and so on. You can check up to 127 conditions using this function. Let's take an example. We have a range of scores. If the score is below 60, the rating is poor. If it is between 60 and 74, the rating is average. If it is from 75 to 89, the rating is good. If it is 90 and above, the rating is excellent. We also have a list of employees with their names and scores. We want to assign a rating based on the score. Since we have multiple conditions, we'll use the IFS function. I've already written the function, but let's build it step by step. Start with typing equals IFS, then open bracket. Our first logical test is, if cell C23 is greater than or equal to 90, then we want to display excellent, written in double quotation marks since it's text. Next, if C23 is greater than or equal to 75, then display good. Then, if C23 is greater than or equal to 60, display average. And finally, if C23 is less than 60, then display poor. That covers all the conditions. Now, if you accidentally put an extra comma in the formula, Excel will show an error like, you have entered too many arguments for this function. Once corrected, copy the formula and paste it to the cells below. The ratings will automatically update if the score changes. That's the power of the IFS function. Let's take one more example. We want to calculate commission rates based on the sales amount. Here's the structure. If the sales in cell C37 are greater than or equal to 1 lakh rupees, the commission should be 10%. If it's greater than or equal to 75,000, then 7.5%. If it's greater than or equal to 50,000, then 5%. If it's less than 50,000, then 2%. Since these are numeric values, we won't use quotation marks. We close the bracket and press enter. Then we format the result as a percentage and increase the decimal precision if needed. Now this commission calculation is fully dynamic. If you change the sales figure, the commission will update automatically. So this is how you can use the IFS function in Excel to check multiple conditions and return the desired result. In this video, we've shown how to return text, numbers, and percentages using IFS. You can also include calculations if needed. In the next video, we'll explore a new topic. Thank you. Hello friends, welcome back. In today's video, we will learn about the VLOOKUP function. VLOOKUP, which stands for vertical lookup, is a powerful tool in Excel. It searches for a specific value in the first column of a table and returns a matching value from another column in the same row. VLOOKUP syntax. Type equals to VLOOKUP, then open parenthesis. The function has 4 arguments, out of which the first 3 are mandatory, and the fourth one is optional. But it is very important, which we will understand with examples. First argument, lookup value. This is the value you want to search in another table. Second argument, table array. This is the range from which you want to fetch the data. It can be from another sheet, workbook, or table. Third argument, column index number. This is the column number in the table array from which the value will be returned. Fourth argument, range lookup. This is optional. You can type false for an exact match or true for an approximate match. Let's understand with a practical example. We have a product price list and we've received a sales order. We have been given the product ID, but the name and price are missing. We'll use the price to calculate the amount using quantity multiplied by price. We are asked to fetch the name and price from the price list using lookup. In the price list, first column, product ID. Second column, name. Third column, price. This means we can pull values from any column on the right-hand side of the first column. Let's start writing the function. Type equals to VLOOKUP, then press tab. First argument, lookup value. If we have only one value, we can type it directly. But if we have many values in different cells, we give the cell reference. Let's say the product ID is in cell A2, so we'll type A2. Then, type comma. Second argument, table array. Now, select the entire table range where data is stored. Since we'll use this function in multiple rows, we'll lock the range using F4 key to make it absolute. Third argument, column index number. If we want to bring the name, which is in the second column, type 2, then type comma. Fourth argument, range lookup. For exact match, type false or type 0. Then, close the parenthesis and press enter. Now, the name like keyboard will appear automatically for the matching product ID. Copy the function and paste it in the cells below. You'll see that names like mouse are fetched automatically. Now, we will use the same formula to get the price. We just change the column index from 2 to 3. Then, press Ctrl and enter together and paste the function below. Now we can multiply the price by quantity to get the amount. And whenever the price changes in the list, the amount will update dynamically. Let's take another example, sales target. We are given a table with employee names, sales regions, targets. In another table, we have employee names, sales achieved. We want to combine these into one. Let's use VLOOKUP. Type equals to VLOOKUP, then press tab. First, lookup value cell with employee name. Type comma. Second, table array from first column to target column. Select the range and lock it with F4. Third, column index, target is in third column, so type 3. Type comma, and for exact match, type false or 0. Close parenthesis and Ctrl plus enter. Now copy and paste the formula below. You'll see targets fetched automatically. Now, we'll get sales achieved using the second table. Type equals to VLOOKUP. Use the employee name as lookup value. Select the second table, lock it with F4. Type 2. For second column, sales achieved. Type false, close parenthesis, Ctrl plus enter, copy and paste it below. Everything is dynamic. If you update any value, results will update. Let's now understand the difference between exact match and approximate match. Suppose we have a tax slab table, and we have incomes listed for salespersons. Now, we want the tax rate to be calculated based on income. We'll use approximate match here because income will fall within a range, not exactly match. Type equals to VLOOKUP. Give income as lookup value. Select the tax slab table, lock it with F4. Type 2. Then for approximate match, type true or 1. Close parenthesis, Ctrl plus enter. Let's say income is 60,000. The tax rate comes as 5%. If we change income to 1,30,000, tax rate becomes 10%. This is the power of approximate match. Now suppose you have a large data set, say 10,000 orders. You have product ID, quantity, but the rate is in another sheet called product master. You can use VLOOKUP across sheets. Type VLOOKUP. Lookup value, product ID, table array. Select entire columns in the other sheet. Column index, type 3 for price. Range lookup, type 0 for exact match. Close parenthesis, Ctrl plus enter. Double-click to apply down the column. Let's see an advanced example, bonus eligibility. You are given a table with employee performance scores, a bonus policy table based on department. Eligibility rule. If the score is 80 or above, the employee is eligible. Bonus amount depends on department and is looked up from the second table. We'll use a combination of if and VLOOKUP. First, use VLOOKUP to fetch the score. Lookup by employee name. Select table with scores, lock it. Type 3 for third column, type 0 for exact match. Now we use if function. Type if the score is greater than or equal to 80. Then use VLOOKUP to fetch the bonus by department. Else return text not eligible in double quotes. Close both parentheses. Ctrl plus enter, copy and paste. Now see, everything updates automatically. If you change, score eligibility updates. Department bonus updates. Sales eligibility can be revoked. This is the power of dynamic Excel formulas using VLOOKUP and if together. If you have any questions, drop them in the comments. Thanks for watching. In the next video, we will learn advanced versions of this topic. Stay tuned. Hello and welcome once again. In this video, we are going to learn about HLOOKUP, also known as horizontal lookup. In the last video, we learned about VLOOKUP, where the lookup was done vertically. That means if a value is present in the leftmost column, we could search to the right and fetch related values from another column, either from the same table or even from another sheet. But in VLOOKUP, the base of the search is the columns. Now, there can be situations where we need to fetch data from rows instead of columns. For this, we use HLOOKUP, which stands for horizontal lookup. It works on rows. We define the value to search in the first row of the table, and then it returns data from the row number we specify. Let's look at the syntax of HLOOKUP. We write it as lookup with 4 arguments, out of which the first 3 are mandatory and the 4th is optional, but recommended. Now let's take a practical example. We have a grading table of a student. In the first row, we have subjects, math, English, and science. In the second row, we have their grades. In the third row, we have the names of the teachers. And in the fourth row, we have the room numbers. Our task is to make this data appear vertically. Since the subjects are arranged horizontally in columns, and we need to pick related data from below, we will use the HLOOKUP function. Let's begin. Type equals HLOOKUP, open bracket. First, we provide the lookup value, that is, the cell where the subject is written. Let's say it's cell A2. Type A2, comma. Now we give the table array, that is, the full table from where we want to pick the data. Make sure you select only the rows from the top row where the subject is written till the row from which you want to fetch the value. After selecting the table, press F4 to lock the range. Then type comma. Now enter the row index number. For example, if we want the grade, which is in the second row, we type 2, then comma, and finally, we type 0 for an exact match, and close the bracket. So the final formula would be type equals HLOOKUP, open bracket, A2, comma, selected table range, comma, 2, comma, 0, close bracket. Then press Ctrl plus enter to apply the formula. Now, copy the cell, paste it down into the other rows. Then change the row index number to get different information. For example, to fetch the teacher's name, change the row index number to 3 and again press Ctrl plus enter to get the room number. Change the row index number to 4 and apply the formula the same way. Now you will see that, based on the subject name, we are able to fetch the grade, teacher name, and room number from the horizontal table above. That is how we use HLOOKUP. If you have any questions, feel free to write them in the comments section. Also, for practice, you can take the same data we used for VLOOKUP, convert it into a horizontal format, and try it using HLOOKUP. Thank you, friends, for watching. Stay tuned for the next video. Hello everyone, welcome back. In this video, we'll learn about XLOOKUP, which is a very powerful function for searching values in Excel. It's highly flexible and modern, and it replaces older functions like VLOOKUP, HLOOKUP, and LOOKUP. The XLOOKUP function takes 6 arguments. Let's go through them one by one. First, the lookup value. This is the value you want to search for. It works the same as in VLOOKUP or HLOOKUP. Second, the lookup array. In older functions, we gave a range. But here, We only give a row or a column because XLOOKUP allows us to fetch values not only from the right, but also from the left side, which was a limitation in VLOOKUP. Third, the return array. This is the row or column from which we want to fetch the value. You need to define the entire range here. Fourth, if not found. Here, you can specify what should be shown if no matching value is found. You can write a text like not found inside double quotation marks or even do a calculation. Fifth, match mode. You define how the match should be done. Type 0 for exact match. Type -1 for exact match or next smaller value. Type 1 for exact match or next larger value. You can even use wildcards here. Sixth and last, search mode. This defines the direction of search. You can choose either first to last or last to first. So, XLOOKUP is a highly flexible function that can do both vertical and horizontal lookups. You don't need to use both VLOOKUP and HLOOKUP anymore. Just one function does it all. It can fetch data from both left and right. It also replaces older nested if functions and index match combinations. Let's understand it with an example. We have a product list in one table and a sales order in another. We want to fetch the product name and price based on the product ID in the sales order. To do this using XLOOKUP, type XLOOKUP. Now, open bracket. First, give the lookup value. That is, the cell where the product ID is written. For example, cell A2. Then, say comma. Now give the lookup array, which is the column in the product list where the product IDs are stored. Select the entire column. You can press F4 to lock it if you plan to copy this formula later. Then, say comma. Next is the return array, which will be the name column. Select the column where the product names are listed and press F4 to lock it as well. Then, say comma. Now, if you want to define a value when the product ID is not found, you can type something like not found inside double quotation marks. Then, say comma. Now for match mode, type 0 for exact match. Search mode is optional, so you can skip it. Now, close the bracket and press Ctrl plus Enter. Copy this formula down to get all product names. To fetch the price, do the same steps again. Type XLOOKUP. Then press Tab. Give the lookup value as the product ID cell. Then, comma, give the lookup array, which is the product ID column. Lock it. Then, comma, return array will be the price column. Lock it. Then, comma, and type 0 for exact match. Close the bracket and press Enter. Now you can multiply price by quantity to get the total amount. Second example. We have a sales table that shows how much each employee has achieved. We want to fetch targets and achievements from another table using employee names. So, first, type XLOOKUP. Lookup value will be the employee name cell. Then, comma, go to the target table and select the column where employee names are listed. Press F4 to lock it. Then, comma, select the target column and lock it too. Then, comma, if not found, you can type NA inside double quotation marks or leave it empty. Then, comma, type 0 for exact match. Close the bracket and press Enter. Now do the same to fetch the achieved amount. Third example. Let's say you have a large data set of over 10,000 rows, and you want to fetch the rate of a product based on product ID from another sheet. Type XLOOKUP. Press Tab. Lookup value will be the cell that has product ID. Then, comma, go to the product master sheet. Select the product ID column, then comma, select the price column. Then, comma, type 0 for exact match. Close the bracket and press Enter. Double-click to fill down the formula. Fourth example. Let's use an income tax slab rate to find the tax percentage based on income. We have a table where income ranges are given and their corresponding tax percentage. Type XLOOKUP. Give the cell reference where income amount is mentioned. Then, comma, select the income range column, lock it. Then, comma, select the tax percentage column, lock it. then, comma, type 0, then, comma, type -1 to get approximate match with the next smaller value. Close the bracket and press Ctrl plus Enter. Now change the income value to test. For example, 2,10,000 gives 20%, 1,60,000 gives 30%, 50,000 gives 5%. So the function is working perfectly. Fifth example. Let's say you have a bonus policy table and employee data. You want to give a bonus only to those who scored 80 or more. First, fetch the score using XLOOKUP based on employee name. Then, in the bonus column, use the if function. Type if, then, inside bracket, if score is greater than or equal to 80. Then, use XLOOKUP again to fetch the bonus amount based on department. Use department as lookup value, department list as lookup array, and bonus amount as return array. Lock the ranges. Type 0 for exact match. Then, if not found, type 0. Close all brackets and press Enter. Copy and paste down the formula. You'll see employees who scored less than 80 are getting 0 bonus. Last example. Let's use XLOOKUP for horizontal lookup. You have names in the first column and subjects in the first row. To fetch the math score of Shyam, use type XLOOKUP. Use Shyam as the lookup value. Then, comma, select the row that contains names. Then, comma, select the row that contains math scores. Close the bracket and press Enter. If you copy this formula, remember to press F4 to lock the lookup arrays. So, that was the use of XLOOKUP in Excel. If you have any questions, feel free to ask in the comment section. Thanks for watching and stay tuned for the next video. Hello everyone, welcome back. In this video, we are going to talk about two very important Excel functions, subtotal and aggregate. As you may already know, for basic calculations like average, count, maximum, minimum, product, and so on, Excel provides us with separate inbuilt functions. But Excel also gives us advanced options for more flexible scenarios. Let's say we have some sales data, and this data may contain errors or filtered rows. Now, when we apply a filter, we might want to exclude the hidden rows from our totals. For such cases, the basic functions like sum or average may not give us the desired results. That's where subtotal and aggregate come in. Subtotal is the older function, and aggregate is the newer one with more features. Still, it's important to learn both. So friends, let's get started. Subtotal function. As I said, the subtotal function in Excel helps us perform calculations like sum, average, and count. Its main benefit is, it gives us the ability to include or exclude filtered or hidden rows. Here is the syntax. Type subtotal open bracket. Now we have two arguments. First argument is a number that represents the function you want to use. Excel supports 11 functions inside subtotal. For example, to perform average, use the number 1. To perform sum while excluding hidden rows, use the number 109. If you want to include hidden rows, use the number 9. Let's see an example. Let's say I want to find the total of a range. Type subtotal open bracket. Now select the function. If I want to perform sum while excluding hidden rows, I will type 109, then say comma. Now, select the data range, for example, cells B2 to B30. Then close the bracket and press Ctrl plus Enter. You will now see the total value. If I hide some rows, like row 30 and row 31, you will notice the total value stays the same because hidden rows are not included. To include hidden rows in total, just change the formula. Type subtotal open bracket 9, data range close bracket and press Enter. That's the basic difference. Function number 9 includes hidden rows and function number 109 excludes hidden rows. Aggregate function. Now let's move to the aggregate function, which is even more powerful. Sometimes we receive data with errors after performing calculations. Subtotal cannot ignore error values, but aggregate can. With aggregate, we can perform operations like average, sum, maximum, minimum, count, count A, and more. Plus, we can ignore hidden rows, error values, even nested subtotals. The syntax for aggregate has 4 arguments. First argument, a number that tells which function to use. Excel supports 19 functions inside aggregate. Second argument, a number that tells which type of values to ignore. For example, 0 means do not ignore anything. 1 means ignore hidden rows. 2 means ignore error values. 3 means ignore both hidden rows and error values. Let's see an example. Let's say we have a table with month, region, and sales columns, and we want to calculate the total sales. Type aggregate open bracket. For the first argument, select the number 9 for sum. Type 9, comma. For the second argument, if I want to ignore error values, I will type 5, comma. Now select the data range, for example, cells C2 to C15. Close the bracket and press enter. Now the total will be calculated correctly, even if there are hidden rows or error values. Let's say I filter the region column to show only East. Then the total will update automatically to show only the visible data. Similarly, if I filter by month and select only February, the total will reflect sales for February only. Now, let's test how aggregate handles errors. I have a table showing revenue month-wise, but some rows contain errors. If I use the regular sum function, it will give an error. But using aggregate, we can ignore those errors. Here's how. Type aggregate open bracket. For average, the function number is 1. Type 1, comma. Now for options, to ignore error values, type 6, comma. Then select the data range. Close the bracket. Press enter. You will now get the correct average value, ignoring the errors. The aggregate function is very useful when building dashboards, reports, and charts where you want the data to update dynamically and avoid showing errors. So friends, I hope you now understand both subtotal and aggregate functions clearly. Make sure to practice them. They are very important and will be helpful in your daily work. If you have any questions or doubts, feel free to write in the comments or send me an email. I will try my best to respond as soon as possible. Thank you, friends. Hello and welcome once again. In today's video, we are going to learn about the filter function. This is a new function in Excel, and it is part of what we call dynamic array functions. Many such functions have been introduced, and the most important ones will be included in this course. I will explain them thoroughly because learning them is very important, especially if you want to create dynamic dashboards or work on MIS reports. These functions are extremely useful. The filter function is a dynamic array function that helps filter a range based on some criteria. It is completely dynamic. Before we had dynamic arrays, we mostly used pivot tables for such tasks. But the problem with pivot tables is that even though they are dynamic, they do not auto-update. That means, if any data changes, we have to manually refresh the pivot table from the Data tab for the report to get updated. But with these functions, that's not needed. They offer more flexibility, which is why we should use them more. Now let's understand the syntax of the filter function. It has 3 arguments. First, array. Second, include. This is mandatory. Third, if empty, this is optional. In the array argument, we provide a simple range from where we want to pick the data. In the include argument, we specify the criteria on which basis we want to filter the data. Let me show you how this function works. Here I have some sales data. I have names of salespersons and their respective sales values. Now I want to bring data of only one specific salesperson by filtering it. To do this, type filter, then open bracket. Now give the range, for example, cell A2 to cell B10. Now say comma. In the second argument, we write our condition. Let's say we want to filter by salesperson name. So we select the same range of names and say equals to Bob. Make sure to write Bob exactly in double quotes. Then close the bracket. Now press enter. You will see only Bob's data appears. But notice, the headers do not come automatically. Only the data is returned. So, we will have to copy and paste the headers separately. To make this even more dynamic, instead of typing the name directly, you can refer to a cell. For example, in cell D1, you can create a drop-down list using data validation. Go to the Data tab, then choose Data Validation. Under Settings, select List, then give the range of salesperson names. Press Enter and then click OK. Now whenever you choose a name from the drop-down, the data will get filtered accordingly. This is how you can make it fully dynamic. As I mentioned earlier, this is especially useful in EMIS and dashboard reporting. Let's now take it to the next level, using multiple conditions. For multiple conditions, we use logical operators like and or. Let's start with and in Excel and is represented by the multiplication operator, that is, the asterisk sign. When we use asterisk between two conditions, both conditions must be true for the data to appear. Let me show an example. We have salary data for different employees. Now we want to filter data for only those employees who belong to the sales department and have a salary greater than 60,000. Let's write this step by step. Type filter, open bracket. Now give the full range, for example, cell A2 to cell C10. Say comma. Now we write the condition. And since there are two conditions, we open another bracket. First condition. Select the department column, for example, cell B2 to cell B10. Say equals to sales. Write sales in double quotes. Close the bracket. Now write asterisk. For and. Open another bracket. Select the salary column, for example, cell C2 to cell C10. Say greater than or equal to 60,000. Close the bracket. Now close the final bracket and press enter. You will now see only those records where the department is sales and salary is greater than 60,000. Now let's talk about OR conditions. When using OR, we use the plus symbol, which behaves like OR logic. That means if either condition is true, the data will be shown. Let's say we want to filter employees who belong to either sales or finance department. Here's how. Type filter. Open bracket. Give the full data range. Say comma. Now for include condition. Open bracket. Select the department column, for example, cell B2 to cell B10. Say equals to sales in double quotes. Close bracket. Now write plus. Open bracket again. Select same department column. Say equals to finance, also in double quotes. Close bracket. Close final bracket and press enter. Now, you will get data for both sales and finance departments. We will learn how to sort this using sort or sort by function in the upcoming videos. Now what if we want to combine both and or? Let's say we want data of sales department employees whose salary is greater than 60,000 and all employees from finance department regardless of their salary. This time, we'll group the conditions using brackets. Here's how. Type filter. Open bracket. Select full range, for example, cell A2 to cell C10. Say comma. Now open bracket for or condition. First group. Open another bracket for and. Select department column equals to sales. Write asterisk. Then select salary column greater than or equal to 60,000. Close inner bracket for and. Then write plus. Second group. Open bracket. Department column equals to finance. Close bracket. Finally close the outer brackets and press enter. You will now see data for sales employees with salary above 60,000 and all finance employees. If you change the salary of any finance employee below 60,000, the data will still be included. That's the power of dynamic filtering. Remember, we could do this using pivot tables too, but they're not truly dynamic in the way filter is. So mastering this function is essential. You can download this file and practice on your own. Try creating your own filtering criteria. Try combining with other functions like sum and subtotal. In upcoming videos, we'll cover even more advanced array functions. If you have any questions, feel free to drop a comment. I will try my best to answer them. Thanks for watching and stay tuned for the next video. Hello everyone. Welcome once again. In today's video, we will learn another dynamic array function in Excel. It is called sort. Along with that, we will also look at its advanced version, which is Sortby. As the name suggests, the sort function is used to dynamically sort data. Earlier, we had already learned the filter function. All of these dynamic array functions are especially useful when we prepare dashboards or MIS reports. Usually, we first filter the data and then sort it accordingly. So learning this function is also very important. Let's begin with the sort function. It has four arguments. The first argument is the array. This means the range of data we want to sort, and this is mandatory. The remaining three arguments are optional, but it is highly recommended to define them. In the second argument, we mention which column or row to sort by. Otherwise, by default, the data is sorted using the first column. The third argument is to decide whether we want to sort in ascending or descending order. And the fourth argument is used if you are sorting by row instead of column. Let us see a simple and useful example. Suppose I have a sales data set. Now I want to sort this data. Type the formula equal to sort B to 2E10. Now just press comma. We will first try this without any extra arguments. You will see all the data has been sorted using the first column by default. Now suppose I want to sort it using the second column, which is the sales amount. Then I will edit the formula. After the range, type comma. Then in the second argument, type 2 because we want to sort by the second column. You will see the data is now sorted based on the sales amount. Now suppose you want to sort in descending order instead of ascending. So after typing 2, type comma. And in the third argument, -1. Then close the bracket and press enter. Now let's move on to another example. Here I have a larger data set with employee detail. Let's say I want to sort it based on location, which is the fourth column. Type the formula equal to sort A to 2E20. Type comma. Then type 4. Now I want to sort this in ascending order. So again, type comma. Then type 1. Then type close the bracket and press enter. You can now see the data is sorted by location in ascending order. Now I will show you how to use sort with filter. Let's say we first filter the data based on department is sales, and then sort it. We will use the filter function first. Type the formula equal to filter A to 2E20, where column C equals sales. Now we have filtered data showing data only the sales department. Suppose now I want to sort this filtered data based on location. I will copy the entire filter formula, then delete the earlier then type the formula to sort equal to sort. Paste the filter formula inside the sort function. Type comma. Then type 4. Then type location is the fourth column. Then type comma. Then type comma in ascending order. Close the bracket and press enter. Now you can see only shows sales department employees sorted by location in ascending order. Let us move on to the Sortby. The difference between sort and Sortby is that sort allows sorting only by single column, whereas Sortby allows sorting by multiple columns. Let's see how to use Sortby. Type the formula Sortby equal to Sortby A to 2, then type comma. Then type comma. Say I want to sort by name, which is column B 2 to B20. Then type 1 for ascending. Then type 1. Now I want to sort again by location, which is column D. D2 to D20. D2 to D20. 1 for ascending. Type comma 1 close for ascending and press the bracket. And now the data is first sorted by location. And then whenever you want to sort by multiple columns, use Sortby. For single column sorting, These functions can also be combined with other dynamic functions with other dynamic functions Excel dashboards for advanced or Excel dashboards or you can download this practice sheet. You can download this practice sheet and if you have any questions, feel free to contact me through the comments. Thank you for watching. Stay tuned for the next video. Stay tuned for the next video. Hello everyone. Welcome back. In this video, we will learn about text-related functions in Excel. These include upper, lower, proper, lay, trim, left, right, mid, search, find, substitute, and replace. We will learn all of these functions with examples. Let's start with upper, lower, and proper. As the names suggest, these functions are used to convert text cases. All three functions take only one argument, which can be either a direct text or a cell reference. In our example, I have written some names in different formats. We want to convert them into uppercase, lowercase, and proper case formats. So first, we type upper. Then we give the cell reference. Now press Ctrl plus Enter. Next, for lower, we type the function name and give the same cell reference. Similarly, for proper, we type the function and give the reference. Now I will copy these formulas down. You can now see, in the first case, all letters are in uppercase. In the second case, all letters are in lowercase. In the third case, only the first letter of each word is capital. Now let's talk about the lay function. The lay function is used to count the number of characters in a text string. It includes all letters, numbers, spaces, and special characters. Even extra spaces are counted. In our example, I have written a name with extra spaces between the words. These spaces will also be counted. The syntax is simple. Type the function lay, then give the cell reference. Now press Ctrl plus Enter. Copy the formula to other cells. You can observe the count. If I remove one space manually, the character count decreases. For example, earlier it was 16 characters. Now it is 15 characters. Now, let's move to the trim function. Trim is used to remove extra spaces from a text. Here is an example. I have written a name with many unnecessary spaces. Type trim, then give the reference of the cell. Close the function and press Ctrl plus Enter. You will see that now only a single space remains between the words. To verify this, I will use the lay function again. Before applying trim, the length was 16 characters. After using trim, it becomes 11 characters. That means all the extra spaces were removed. Now let's learn left, right, and mid functions. Starting with left. Left is used to extract a specific number of characters from the left side of a text. It takes two arguments. First is the cell reference. Second is the number of characters to extract. For example, if I want to extract the first 4 characters, I type left, give the cell reference, then type 4, and close the function. Now press Ctrl plus Enter. You will see the first 4 characters are extracted. But what if the first names in our list have different lengths? In that case, we will make it dynamic using search or find functions. Next is the right function. It works similarly to left, but extracts characters from the right side. For example, type right, give the cell reference. Then type 5 and close the function. Press Ctrl plus Enter. It extracts the last 5 characters. Now let's talk about the mid function. Mid is used to extract characters from the middle of the text. It takes 3 arguments. First is the text reference. Second is the position to start from. Third is the number of characters to extract. For example, type mid, give the cell reference. Then type 5 as the starting number. And again type 5 to extract the next 5 characters. Close the function and press Enter. You can see that starting from the 6th character, 5 characters have been extracted. Now, to make the function dynamic, we will use the search function. The search function is used to find the position of a specific character in the text. It takes 3 arguments. First, the character you want to search. Second, the text in which to search. Third is optional. Let's type search and say we want to search for W. We type W as a text input, give the cell reference, and close the function. Press Ctrl plus Enter. The output tells us the position where W appears in the text. Let's also learn find. It works like search but is case sensitive. For example, if you type W in small letters in the find function, it won't match capital W. So, find is case sensitive, but search is not. Also, find does not support wildcards, while search does. Now let's say we want to extract the first name from a full name. First, we find the position of the space using search. We search for a space, give the cell reference, and press Enter. Now, we subtract 1 from this result because the first name ends just before the space. Use this value inside the left function. Type left, give the cell reference, and as the second argument, paste the search -1 value. Press Ctrl plus Enter. Now the first name is extracted dynamically. Even if the name changes, it will still extract only the first name. You can use the right function similarly to get the last name. This can be your practice task. Now let's talk about substitute. This function is used to replace a specific word or character in the text. It is very useful in cleaning or correcting data. It takes 4 arguments, out of which the first 3 are required. The full text or reference, the old text you want to replace, the new text to replace with, and the optional 4th argument is the occurrence to replace. For example, type substitute, give the cell reference. Then in double quotes type the old word, like Miller. Then in the next argument, type the new word, like Matthew. Close the function and press Ctrl plus Enter. Now you can see that Miller has been replaced with Matthew. Here's another example. Let's say we want to remove the hyphen symbol from a phone number. Type substitute, give the cell reference. In old text, type the hyphen, and in new text, leave it blank. That way the hyphen will be removed completely. Now finally, let's learn about the replace function. Unlike substitute, replace works based on position, not text. It also takes 4 arguments. First, the text reference. Second, the starting position. Third, the number of characters to replace. Fourth, the new text. For example, type replace, give the text reference. Then type 5 as the starting position. Type 2 as the number of characters to replace. And type the new text like AD or X. Close the function and press Enter. You will see that characters at position 5 and 6 are now replaced. You can change the values to test and learn more. Now let's compare the difference between substitute and replace. Replace works on positions, whereas substitute works on matching text. Replace does not care about exact text. It replaces characters starting at a certain position. Substitute finds and replaces based on exact match. Both are not case sensitive. So friends, this is how you can use text functions in Excel for your daily work. If you have any questions related to these functions, feel free to comment below. I will try my best to answer as soon as possible. Thanks for watching. Stay tuned for the next video. Hello and welcome back. In today's video, we will talk about the offset function in Excel. The offset function is used to return a new cell or range by moving a certain number of rows or columns from a given starting point. This function becomes very useful when you want to create dynamic ranges or fetch data flexibly. For example, suppose we want to sum the last 3 months of data, and this data keeps getting added every month. New rows keep getting inserted, but we always want to start from the last row. In such cases, we need to move down from the top and then select the last 3 rows dynamically. Here, the offset function is extremely helpful. Whether you are creating dynamic charts, fetching values based on drop-downs, or building auto-updating formulas, the offset function is quite powerful and important to learn. This function has 5 arguments. 1. Reference. This is the starting point from where your range will begin. 2. Rows. This defines how many rows to move. If you provide a positive number, the selection moves down from the reference cell. If you provide a negative number, the selection moves up from the reference cell. 3. Columns. If you give a positive number, the selection moves to the right. If you give a negative number, the selection moves to the left. Note, this number should never be 0. It must be either +1, -1, +2, or any other number except 0, because we always need to select at least one column. 4. Height. This is optional. It defines how many rows to include in the final range. For example, suppose we are at a particular cell and move down 6 rows, but we want only the last 3 rows to be summed. So, we define height as 3 to move back up, and only include the last 3 rows. 5. Width. This is for columns. You can use it to define how many columns to include. Let's understand this with an example. I have month names listed from January to June, and I have a target to always sum the last 6 months of data. Now summing the existing 6 months is easy, but when July is added, the range has to be adjusted manually, and that becomes difficult. So our goal is to make this range dynamic and automated so that we do not need to touch the formula again. Let's start writing the formula. Type the formula, equal to sum and open bracket. Now inside this, we need to give a range. But since the range is not fixed and keeps increasing, we will use the offset function. Type offset and open bracket. The reference will be the header cell from where the data starts. Then we type a comma. Now we want to know how many rows to move down. Since the data increases every time, we need to count how many rows have data. So we will use the COUNTA function. Type COUNTA and open bracket. Select the range where the data is being added. It will count all the non-blank cells and give the number of rows with data. Then close the bracket. Now type a comma. For the columns, we do not want to move left or right, so we write 0. Now for height, we want to get the last 6 months of data. So we type -6. This moves the selection up by 6 rows. For width, we do not need anything special, so we can leave it blank or write 1 if required. Now close the offset bracket. Then close the sum bracket. Finally, press enter. Now we have the sum of the last 6 months. To test if this is dynamic, I will add data for August. Then press enter. And as you can see, the result updates automatically. We can verify this by manually summing the last 6 rows. Type sum, select the last 6 cells. Then press Ctrl plus enter. You will see that the result is the same. So this is how you can use the offset function. It is very powerful and extremely useful when building dashboards or MIS reports. Every time data is added, if your formula is dynamic, you can easily pick up the new values. If you face any issue related to this, feel free to ask me in the comment section. Or you can email me. I will try my best to answer as soon as possible. Thanks for watching and stay tuned for the next video. Hello everyone. Welcome back. In today's video, we are going to talk about one of the most powerful features in Excel, the pivot table. A pivot table helps you summarize, analyze, explore, and present your data in a dynamic and interactive way. Whether it is totals, averages, counts, or percentages, a pivot table can give you all the answers without writing a single formula. Now, what are the benefits of using a pivot table? First, it saves time. Second, it helps you create instant reports. And third, it allows you to slice and filter large datasets with just a few clicks. Important data preparation for pivot tables. But before creating a pivot table, there are some important things to take care of, and for good reason. For a pivot table to work correctly and provide accurate insights, your data needs to be structured in a specific way. Make sure your data is well organized with headers in the first row, headers or column titles. Tell Excel what kind of data is in each column. For example, sales amount, date, or product. Without clear headers, Excel won't understand what data it's summarizing, And your pivot table fields will just show generic names like column 1, column 2, making it impossible to analyze. And no blank rows or columns. Blank rows can trick Excel into thinking your data ends prematurely, so it might not include all your information in the pivot table. Blank columns, while less impactful, can also lead to confusion or unnecessary blank fields in your pivotable options. Avoid merged cells. Merged cells look neat for presentation, but they are problematic for data analysis, especially with pivot tables. When cells are merged, Excel doesn't know how to treat the individual data points, leading to errors or incomplete data being pulled into your pivot table. It's best to unmerge them and repeat the data in each cell if necessary for analytical purposes. And keep the data in a tabular format, meaning one row for each record and one column for each field. This is the most fundamental rule for data used in pivot tables. Each row should represent a unique entry or transaction in record, and each column should contain a single, distinct type of information, a field. For instance, if you're tracking sales, each row should be one sale, and separate columns should exist for date, product, quantity, and price. This structure allows the pivot table to correctly group, summarize, and filter your data based on these distinct categories. Without this clear structure, your pivot table will either produce errors or its summaries will be incorrect and unreliable. So now that you know what a pivot table is and why it is useful, let's jump into Excel and see how to create one step by step. Creating your first pivot table. Step 1. Prepare your data. Before creating a pivot table, make sure of these three things. Your data should be in tabular format, with each column having a proper heading. Avoid any blank rows or columns. If your date is in full format, like day, month, and year, it is better to create a separate year column using the formula equal to year, open bracket, date cell, close bracket. For example, equal to year, open bracket, A2, close bracket. Step 2. Select the data. Click anywhere inside your data table. You can also press Ctrl and A to select all rows and columns. Step 3. Insert the pivot table. Now go to the top menu and click on the Insert tab. Then click on Pivotable. It is usually the first option in the Tables group. A dialog box will open titled Create Pivotable. Let's understand the options. First, Excel asks, select a table or range. If you already clicked inside your data, this will be automatically selected. Next, it asks, choose where you want the pivotable report to be placed. Here you have two choices. New worksheet. This is the default option. Excel will create a new sheet and place the pivot table starting from cell A1. It helps keep your data and reports separate. Existing worksheet. You can also choose to insert the pivot table into your current sheet. If you select this, Excel will ask for a location. Click inside the location box, then click on the cell in your sheet where you want the pivot table to start, for example, cell H2 or any other blank area. But in our case, we will create the pivot table in a new worksheet. So, select New Worksheet and then click OK. After you click OK, Excel creates a blank pivot table in a new worksheet. On the right-hand side, you will see the Pivotable Fields pane. This panel is divided into two main sections. Let's understand both. Top section, Field List. At the top, you will see a list of all column headings from your dataset. Each item here is called a field. For example, if your table has columns like date, year, zone, product, and sales amount, all of these will be listed here as selectable fields. You can tick the checkboxes to add them or drag and drop them into specific areas below. Bottom section, 4 areas to build your pivot table. Just below the field list, you will find 4 boxes that control how your pivot table will be arranged. Let's go through each one. Filters area. This is used when you want to filter the entire pivot table based on a specific field. For example, if you drag product to the filters area, you can choose to view sales for only one product at a time. Columns area. This defines how your columns will be displayed in the pivot table. For example, if you drag zone here, the table will show separate columns for each zone, like North, South, East, and West. Rows area. This controls the rows of your pivot table. For example, if you drag year here, each row will represent a different year. Values area. This is where the actual calculations happen. When you drag a numeric field, like sales amount, into the values area, Excel will automatically apply the sum function and calculate the total sales based on the row and column structure. You can drag one or more fields into each area. Excel will instantly update the pivot table on the left side as you build it. So in our case, we will drag year into the rows area, drag zone into the columns area, and drag sales amount into the values area. Now that your pivot table is showing total sales by zone and year, it is important to format the numbers properly so they are easier to read and look more professional. Go to the values area in the pivot table. This is where the total sales amount appears. Right-click on any of those numbers. A menu will appear. From this menu, select Number Format, not Format Cells, but specifically Number Format. This option controls how your numeric data will be displayed inside the pivot table. A dialog box will open showing different categories like General, Number, Currency, Accounting, and more. For sales data, you usually have two good choices. Number format. This displays plain numbers. You can choose how many decimal places to show, for example, 0, 1, or 2 decimal points. You can also check the box that says use 1000 separator, which adds commas to large numbers. Currency format. This adds a currency symbol, such as the rupee sign or dollar sign. It is useful when you want the values to clearly represent money. Just like in the number format, you can also adjust decimal places and choose how negative numbers appear. Once you have selected the format you want, click OK. Your entire values column in the pivot table will now be updated with the new formatting. And that's it. Your pivot table now looks clean, clear, and ready to present. In the next step, we will look at how to further customize and analyze this data to make your reports even more powerful. Hello and welcome once again. Now we are going to start creating a pivot table from our sales order data. We have already learned the steps. First, select any single cell from the dataset. Then go to the Insert tab. Click on Pivot Table. In the dialog box, select New Worksheet. Now click on OK. The pivot table will be created on the left-hand side of the new sheet. And on the right-hand side, you will see the Pivot Table Fields panel. We have already learned about the different parts of this panel. Let's begin. First, pick the field named Segment and drop it into the rows area. Next, pick the field named State and drop it just below Segment in the rows area. You'll now notice that the pivot table on the left has expanded and is displaying data. At the top, you'll see Consumer. Under that, all the sales orders related to that segment are grouped by different states. But everything is coming in a single column right now. Now let's drag the City field and drop it below State in the rows area. Now, at the top, we have Consumer. Below, there are the states where sales orders were issued. And under each state, the cities where those orders were placed. Everything is still being displayed in a single column and in an expanded format. Let's now take the Region field and drop it in the columns area. You'll see that several columns have now been inserted based on region. Scroll a bit down and drag the Sales field into the Values area. Now you have a fully formed pivot table. Let's look at some design options related to the pivot table. Whenever you create a pivot table, two new tabs appear in the ribbon. One is Pivotable Analyze, and the other is Design. If you click anywhere outside the pivot table, these tabs will disappear. Click back on any cell inside the pivot table, and they will reappear. The first tab is for Analysis, where you can manage various settings, including turning features on or off. The second tab, Design, includes options related to appearance. Let's fix a few things first to improve the table. We will first adjust the column widths to make the data look better. Select any cell in the pivot table. Go to the Pivotable Analyze tab, then click on Options. In the Options window, enable for empty cells show and type 0. Then enable Autofit column widths on Update. Click OK. Now the data looks well organized and professional. This is always my first step after creating a pivot table. Next, let's clean up the numbers. You can either right-click on any number and choose number format, or go to the Values area, click on Sum of Sales, and then click Value Field Settings. From there, go to Number Format and set it to either number or currency. These are the changes I always apply to every pivot table. Now let's explore more design options. Click anywhere inside the pivot table, then go to the Design tab. The first section includes 4 layout options: Subtotals, Grand Totals, Report Layout, Blank Rows. Let's talk about subtotals first. As you can see, for each consumer segment, a subtotal is shown. For example, in column F, you can see grand totals, and in row number 6, a subtotal for each state is shown. This includes all cities and sales orders under that particular state. Right-click anywhere in the row area. Go to Expand or Collapse, and select Collapse Entire Field. Now, the cities are collapsed, and we no longer see the detailed data. You will now see a plus sign next to each group. Clicking on this will expand and show the hidden data. To hide it again, click the minus sign, or right-click and use Collapse or Expand options as needed. Let's say we collapse the entire consumer segment. Now you can see only the subtotals for each consumer. The states and cities are hidden. If we click the plus sign next to consumer, we can see which states are under that segment, and under each state, which cities. Now let's remove all subtotals. Right-click anywhere in the pivot table. Click on Subtotals, then select Do Not Show Subtotals. You'll see that all subtotals are removed. Now click again inside the pivot table. Go back to Subtotals and select Show All Subtotals at bottom of group. You'll notice a new row is inserted below each group showing the subtotals. The last option in subtotals is Show Subtotals at top of group, which is the default option. You can use either top or bottom according to your preference. Now let's understand the grand totals option. First, collapse the pivot table completely so only top-level rows are visible. Now, go to the Design tab and click on Grand Totals. If you select Off for rows and columns, the grand totals will be removed from both the right-hand side and the bottom. If you want to show grand totals again, go back and choose On for rows and columns to show both, On for rows only to show totals at the bottom, On for columns only to show totals at the right. I usually keep both turned on as it helps in analysis. Let's now expand the pivot table again. Next is Report Layout. Click on Report Layout. Right now, the data is displayed in compact form, which means all row fields are shown in a single column, one below the other. Select Outline Form to see a more spread out view. Now, each row field like segment, state, and city will appear in separate columns. If you want the labels in each row to repeat for easier copying or filtering, click on Repeat All Item Labels. This way, every row will display the full label chain, such as consumer, state, and city, all repeated in each row. This is especially useful when exporting or applying formulas like VLOOKUP or XLOOKUP. I prefer using this format without subtotals. That's just my personal style when preparing data for analysis. Now let's look at the blank rows option. If you want to insert a blank row after each group, go to the Design tab, click on Blank Rows, and select Insert Blank Line after each item. This will create visual separation between groups. To remove them, go back and click Remove Blank Line after each item. Now let's explore the pivotable style options. You can choose to highlight row headers, column headers, banded rows, or banded columns. Each of these options adds formatting styles. Click on the Styles drop-down to explore formatting presets. They are categorized into light, medium, and dark themes. You can select any style based on your preference. So, these were the key options under the Design tab. In the next video, we'll explore the Pivotable Analyze tab and learn about all the tools available for deeper data analysis. See you in the next video. Thanks for watching. Hello and welcome. In this session, we will explore several key settings related to pivot tables in Microsoft Excel that are essential for every beginner to understand right from the start. Let us begin with a practical example. First, select any single cell from your data range. Then, go to the Insert tab, click on Pivot Table, and choose the option to place it in a new worksheet. Make sure the New Worksheet option is selected and then click OK. Once the pivot table is created, two main sections will appear. On the left side, you will see the pivot table layout. On the right side, the pivot table field list. Let us begin building the pivot table. First, drag the field named Order ID into the rows area. Then, drag the field named Order Date just below Order ID, also into the rows area. You will notice that Excel automatically creates 3 additional row fields: years, quarters, and months. Even though we added only dates, Excel grouped the data by year, quarter, and month. This happens because Excel applies automatic grouping to date fields by default. If you scroll down in the field list, you will see that the fields year, quarter, and month have been added automatically. To remove this automatic grouping, you have 2 options. First, manually uncheck the year, quarter, and month fields in the list. Second, right-click on any group date inside the pivot table and click Ungroup. This will remove all date groupings. However, Excel will apply this grouping again the next time you add a date to the pivot table. To disable this behavior permanently, follow these steps. Go to the File menu. Click on Options. In the Excel Options window, select the Data tab. Enable the checkbox that says Disable automatic grouping of date or time columns in pivot tables. Click OK. Now, Excel will no longer group dates automatically in future pivot tables. Let us delete this worksheet and return to the sheet named Orders. Select any cell, go to the Insert tab, and click on Pivot Table. Click OK. Enable the checkbox for Order ID. This time, Excel will insert the values exactly as they are, without grouping. Currently, the pivot table is shown in compact layout. We have already covered how to convert it into tabular layout in a previous tutorial. Now let us explore another important configuration. Remove all the fields from the pivot table. Then, drag the field named Status into the rows area. Drag the field Segment into the columns area. Finally, drag the field Sales into the Values area. Now, suppose the data in the Orders sheet is updated, a new row is added or values are changed or deleted. After refreshing the pivot table, you might notice that the column widths have changed automatically. To prevent this and keep your formatting consistent, follow this tip. Click on any cell in the pivot table. Go to the Pivot Table Analyze tab. Click on Options in the first group. In the Options window, uncheck the box that says Autofit Column Widths on Update. Then click OK. Now, even after refreshing the pivot table, your column widths will remain unchanged. Let us move to another useful setting. In many pivot tables, some cells may appear blank. This usually means that there is no data available for those combinations of row and column labels. Blank cells can make your report look incomplete or unprofessional. To fix this, do the following. Click any cell inside the pivot table. Go to the Pivot Table Analyze tab. Click on Options. In the field labeled For Empty Cells Show, type 0. Then click OK. Now, all blank cells will display the number 0. This makes your report clearer and easier to interpret. You may also enter text such as not available. However, when the pivot table contains only numeric values, using 0 is recommended. This ensures that your data can still be used in further calculations without errors. Let us address another common issue. Sometimes you may want to reference a pivot table value in another worksheet or workbook. For example, you may want to refer to the sales amount for California. Typically, you would type the equals word and then click on the cell inside the pivot table. Instead of a simple reference like cell B8, Excel may insert a complex formula that starts with Getpivotdata. This can be confusing and may cause issues if the pivot table structure changes. Although Getpivotdata has specific use cases, you may wish to turn it off for basic referencing. To disable Getpivotdata, follow these steps. Click on any cell in the pivot table. Go to the Pivot Table Analyze tab. Click on the small arrow under the Options button. Click on the option labeled Generate Getpivotdata to uncheck it. Now, when you reference any cell in the pivot table, you will get a simple reference like cell B8 or cell C8. These are some of the essential pivot table settings that every Excel user should learn early in their journey. Before diving into advanced pivot table reports, understanding these foundational settings is highly recommended. We will continue to explore more features and settings in upcoming videos and real-world examples. Thank you for watching. See you in the next video. Stay tuned. Thank you. Hey there, and welcome back. Glad to have you in this video where we're diving into some advanced pivot table options that can really level up your data analysis. Now, before we jump in, I hope you've had a chance to practice the topics we covered in the previous videos. It'll make things a lot smoother from here. Alright, let's get started. We'll begin by creating a brand new pivot table using our sales orders data file. Why this one? Because it's packed with a variety of useful data, perfect for our examples. So first, click on any cell inside your dataset. Then head over to the Insert tab, click on Pivot Table. And when the box pops up, make sure you select New Worksheet, then hit OK. Once your blank pivot table layout appears, here's what we'll do. Drag the product category field into the columns area. Then drag the sales field into the values area. Simple, right? Now let's clean it up a bit. Go to the Design tab, click on Subtotals, and choose Do Not Show Subtotals. Then, select Show in tabular form so everything looks neat and easy to read. Feel free to adjust the column widths if anything looks cramped. Okay, now let's talk about summarizing those sales values. Click on any cell in the sales column, then right-click and choose Show Values As. Now, you might remember that earlier we used the value field settings to change things like totals and averages, and you can still do that. But here's a faster way. Just right-click and you'll see options like Count, Average, Maximum, Minimum, and more right at your fingertips. In this video, we're going to explore a bunch of advanced pivot table options, and trust me, they can really help you create powerful dashboards and IMAIS reports. So stay with me and be sure to practice these steps as we go along. Let's begin with one of the most useful features, applying rank. Now, by default, pivot tables show values with no calculation. But when we have sales data categorized by product, it's not immediately obvious which category is doing the best or the worst. That's exactly where ranking comes in. It helps us see that clearly. Here's how to do it. Right-click on any value under the sales column, go to Show Values As, and scroll down to find the rank options. You'll see two choices here, rank smallest to largest and rank largest to smallest. But before we apply this, we'll need to display the ranking in a new column. So drag the sales field into the values area again. If Excel gives you a warning that says the field name already exists, just add a space at the end of the name. That's an easy fix. Next, rename the new column as rank and align the heading to the right so it looks tidy. Now, right-click on any cell in the rank column, go to Show Values As, and select rank smallest to largest. You'll be asked to select a base field. Choose category, since that's what we used in the rows area. You'll now see ranks appear next to each product category. To make it even more clear, you can sort the rank column from A to Z using the Data tab. Let's also clean up the formatting. Right-click on a sales number, go to Number Format, select Currency, and set decimal places to 0. For an even sharper look, go to the View tab and turn off grid lines. That simple change gives your table a clean, professional appearance. So now, your pivot table shows the product category, the sales amount, and the corresponding rank. For example, office supplies might show the lowest rank if we've chosen smallest to largest. And if you want to flip the order, it's just as easy. Right-click on the rank column again, go to Show Values As, and this time, choose rank largest to smallest. Make sure you set the base field to category again. This will update the ranks so that the category with the highest sales appears as rank 1. Now, if you want to break this down even further, let's say, by subcategory, here's what you can do. Remove category from the rows area and add subcategory in its place. As soon as you do that, you'll notice the rank column disappears. That's because the rank was based on the category field, which we just removed. To bring it back, you'll need to apply the rank again, just like before. Right-click on the sales value, go to Show Values As, choose Rank, and set the base field to subcategory this time. And that's how you can easily switch the ranking to work with different levels of your data. Alright, now let's explore another powerful feature, percentage of grand total. To do this, first, add the sales field one more time into the values area. This creates a second sales column, which we'll use to show percentages. Now, right-click on this new sales column, go to Show Values As, and select percentage of grand total. Once that's done, let's make things clear. Rename the column to percentage of sales. Feel free to adjust the column width and alignment to keep everything neat and easy to read. And there you go. Your pivot table now shows the sales amount, the rank, and the percentage of the total sales, all in one clean view. At the bottom of the column, you'll see the percentages add up to exactly 100%. Now, if you want to hide that grand total without removing it completely, here's a quick trick. Go to the Home tab, click on Number Format, and choose More Number Formats. From there, select Custom, and in the input box, type 3 semicolons, then click OK. This will make the total value invisible. But it's still there, Excel just won't display it. It's a nice way to clean up your report without losing the data behind the scenes. Alright, let's move on to the next example. Start by copying the current worksheet so we can build on it without changing the previous one. In this new sheet, go ahead and remove the rank column and turn off subtotals. We won't need them this time. We'll keep the sales field just as it is. But instead of showing data by category, let's now focus on time. So drag the order date field into the rows area. Once the dates appear, right-click on any date, choose Group, and then group them by years. And just like that, your sales data is now organized by year. Next, go to the Design tab, select Show in Compact Form, choose Subtotals at bottom of group, and insert a blank row. These layout changes will make the pivot table much easier to scan and understand. Now you should be seeing a clean view of yearly sales totals. If you like, feel free to adjust the alignment or even rename the row heading to something like year and month, whatever helps make your report clearer. Now let's apply the percentage of parent total calculation. Add the sales field again into the values area. Right-click on this new field, go to Show Values As, and choose percentage of parent total. When prompted, set the base field to years, and then click OK. You'll now see the percentage contribution of each month within its respective year. This helps you understand how each month is performing relative to the entire year, a great insight for trend analysis. Lastly, don't forget to update the column header to something like percentage of sales so it's clear to anyone reviewing the report. Next, let's talk about another really helpful tool, the running total. To get started, make a copy of your previous pivot table so you don't lose anything we've already built. In the new sheet, rename the field where we'll calculate this as running total. Now go ahead and remove the percentage column, since we won't need it here. Then, add the sales field again to the values area and rename this one as running total per month. Right-click on this new field, go to Show Values As, and select Running Total In. When the dialog box appears, choose Month as the base field and then click OK. Let's clean it up a bit. Right-click the column again, go to Number Format, choose Currency, set the decimal places to 0 and hit OK. Now take a look. You'll see how the values build up over time. For example, January shows its sales number by itself, but February adds up January and February. March includes all 3 months, and so on. That's your running total. It shows how your data accumulates month by month. If you want to view this as a yearly running total instead, you can change that too. Just go back to Show Values As, select Running Total In, and this time choose Years as the base field. Now you'll see the cumulative total year by year. For example, 2014 will show just that year's total. 2015 will add up totals from both 2014 and 2015. And 2016 will include all 3 years, and so on. Want to view the same thing as a percentage? No problem. Just right-click, go to Show Values As, and choose Percentage Running Total In. Set the base field as month. Now the pivot table shows how much each month is contributing to the overall running total in percentage terms. And if you want to switch that to yearly percentage running total, just change the base field from month to years. Alright, we're almost there. Let's wrap up with one last technique, calculating differences. Start by copying the existing pivot table one more time so we can work on a fresh copy. Now, go ahead and remove the percentage column. We won't need that for this part. Next, add the sales field again to the values area. Then right-click on this new sales field, go to Show Values As, and select Difference From. You'll see a couple of settings pop up. For the base field, choose Month, and for the base item, choose Previous. What this does is show the change in sales from the previous month. So if sales drop from January to February, the value will show as negative. And if you've applied number formatting, that negative number will appear in red. Now, if you'd rather calculate the difference year by year, you can do that too. Just change the base field to years and keep base items set to previous. This will now compare sales between years, showing you how much they went up or down compared to the previous year. Don't forget to rename the column, heading to differences so everything stays clear. And if you want to see those differences as percentages, that's easy too. Go to Show Values As, choose Percentage Difference From, set the base field to month, and the base item to previous. Now your pivot table will display how much this month's sales have increased or decreased in percentage terms compared to the previous month. And with that, we've covered all the advanced pivot table techniques for this session. Keep practicing these features, things like ranking, running totals, percentages, and differences, because they'll really sharpen your skills and make your reports stand out. Hello and welcome once again. Let's spend a little time today discussing one of the most powerful functions available in Excel's function library, the Getpivotdata function. This function becomes especially useful when you're creating dashboards and you're working with a large dataset but only need a few specific values. For instance, when you want to extract key performance indicators or a summary of sales figures, you don't need the entire dataset, just a single value picked and displayed in a specific area. That's exactly where the Getpivotdata function shines. Let's walk through an example. Suppose we have a sales order dataset with 10,000 rows. To analyze this data, we start by inserting a pivot table. This time, we'll choose to place the pivot table in the existing worksheet. After inserting, we drag the sales field into the values area. Now we have the total sales figure showing in the pivot table. Let's format the values slightly for readability. Assume I want to reference this value on another sheet, maybe to build a dashboard or KPI report. A traditional approach would be to go to the target cell, type a reference to the source cell, for example, something like cell P9, and now the value, say 19,956.19, appears. Let's also apply bold formatting to this number. Now here's the issue. If we go back and modify the structure of the pivot table, say we move category to the rows area, the cell reference changes. Instead of showing the correct value, the reference now points to a different cell or returns incorrect data like the word furniture instead of the sales figure. Suppose the new value now appears in cell Q9 and the sales figure has changed to 1,70,000. That causes problems if you've linked multiple KPIs to specific cell references, as these can break or show incorrect results when the structure changes. This is exactly the problem that the Getpivotdata function solves. Let's go back. I will copy the original linked value into a new cell for reference. Now, instead of manually typing a cell reference, I click into the pivot table cell containing the sales figure. Excel automatically inserts the Getpivotdata function, which retrieves the sales data dynamically from the pivot table, currently, the total from cell P9. Now when I press enter, the value appears correctly. Here's the advantage. If I now make structural changes in the pivot table, for example, removing region from the columns area, the value in our new cell automatically updates to reflect the new structure. Even if I remove the category field, the formula responds accordingly and shows either the updated value or blank if there is no matching result. This makes Getpivotdata a very powerful tool when you want to show a specific value in a dashboard and ensure the calculation always adapts dynamically to changes in the pivot table. Let's explore another advanced use case. Suppose I've created a pivot table where the rows contain subcategory and columns contain segment. Now I want to extract a specific value based on 2 dimensions, for example, the sales figure for binders in the corporate segment. If I do this the traditional way, I might go to the intersecting cell, say cell D10, and link it directly. But again, if I change the structure of the pivot table, this reference breaks. Instead, I want to give the user more flexibility. Let's say I've created 2 drop-down lists, one for subcategory and another for segment. These drop-downs allow users to select different values dynamically. I want the sales figure to update automatically based on the selected subcategory and segment. To achieve this, I use the Getpivotdata function. Suppose I want to get the sales for binders in the corporate segment. I select the cell where I want to display the sales figure, type the function by clicking the pivot table cell, and Excel automatically generates the formula. The formula includes the field name sales, the pivot table location such as cell A3, the first filter segment equals corporate, the second filter subcategory equals binders. Now I want this to be dynamic. So I replace corporate with a reference to the cell where the segment is selected from the drop-down list. Similarly, I replace binders with a reference to the selected subcategory. Now, whenever I change the subcategory drop-down to, say, chairs, or update the segment to home office, the formula automatically updates and shows the correct sales figure, for example, 56,000. This makes the Getpivotdata function extremely powerful when building dynamic, interactive dashboards. If you have any questions about this function or run into any issues while implementing it, feel free to ask in the comment section or send me an email. I'll do my best to respond as soon as possible. Thank you for watching. Please come back again for more Excel tips and tutorials. Hello and welcome back. In today's video, we are going to learn how to create charts using pivot tables in Excel. Let's get started. Imagine you have a large amount of data from sales orders in your worksheet. This data has many different fields, like categories, subcategories, and sales numbers. In previous sessions, we learned how to create different tables from this data step by step very thoroughly, and how to use these tables to prepare our Management Information System or MIS. Sometimes, though, Just looking at the numbers in a table does not make it clear what the data is trying to tell us. It can be hard to quickly understand which item has the highest sales or see patterns simply from numbers. This is where visualization helps. By making a chart, you turn numbers into pictures, making the information much easier to understand at a glance. To do this, we use charts, and in particular, we can create a chart directly from a pivot table. Let's see how to do this. First, let's create a pivot table. Choose the range of your sales data by selecting the cells that contain your sales order information. Then, go to the Insert menu. Next, click on Pivot Table. Excel will ask where you want to put this pivot table. Select New Worksheet. This will give you a new, blank sheet. Now, let's add fields to the pivot table. Drag the subcategory fields to the rows section and drag sales to the values section. Likewise, place your sales values in the values section. Now, the table shows you the sum of sales for subcategory. However, just looking at this data might still not make it clear which category has the highest sales or which has lesser sales. For instance, you may see that the value for chairs seems higher and phones also have a significant value, but the difference is not instantly clear. Here, a chart can help you see the comparisons much better, immediately and visually. Creating a pivot chart is very simple. Just like making a pivot table, you select your pivot table, go to the Insert menu again, but this time select Pivot Chart. Excel gives you a choice of several chart types. For this kind of data, column charts often work best, as they are very clear for comparing totals across categories. After selecting your preferred chart type, such as a column chart, click OK. You can then adjust the size of this chart to make it bigger so it's easier to see. At this point, your chart will show the sum of sales for each subcategory. Each bar's height represents its total sales. If you want, you can change the chart's appearance by using the built-in chart design features. Just click on the Design tab, hover the mouse over different styles, and many options will appear. You can pick the one that feels right for your presentation. There is another powerful feature: filtering. Let's say your sales data includes a state field. If you move the state field into the filters area, you'll then get a drop-down above your pivot table and pivot chart, letting you filter all the data by state. For example, if you only want to see sales for a particular state, simply select that state from the drop-down and click OK. The chart will instantly update, showing only the data for the selected state. You can also select multiple states at once. When you select, for instance, 3 states together, the sum you see in your pivot table and the visualization in your chart will be combined for all those 3 states. Selecting all will show you the complete data again. If you want to focus on just one product category, you can move the category field to the filters as well. Deselect, select all. Choose furniture alone and hit OK. Now, both the table and the chart show only the data for furniture, and you can see only the relevant subcategories. You can customize your chart further. For example, different colors in your columns will represent different product categories. You can make the chart bigger and close the pivot field pane for a cleaner look. Using filters and formatting options, you can make your chart as clear and useful as possible. Pivot charts are extremely important for management information systems and dashboards because they turn data into visual insights. Explore these features, experiment with the different chart styles and filter options, and deepen your understanding of how each chart element works. That's it for today's tutorial. Thank you for watching, and I'll see you in the next video with a new topic. Thank you. Hello and welcome once again, dear friends. Let's dive into one of the most engaging and useful features of Excel: creating and formatting charts. Charts are powerful tools that allow us to visually represent our data, making it easier to understand patterns, compare values, and communicate insights more effectively. And the best part is creating a chart in Excel is both simple and flexible. To begin with, we need a dataset. In this case, I have a basic sales table with months listed in column, such as January, February, and March, and corresponding sales figures in another column. Once your data is ready, simply select it. You can use your mouse or keyboard, whichever you're comfortable with. Next, head to the Insert tab in the Excel ribbon. Here, you'll find a group called Charts, which contains various chart options. If you're unsure which chart type is best for your data, Excel offers a recommended charts option. Clicking this gives you a list of chart types based on your dataset. Now, let's say we want to create a clustered column chart. Once selected, Excel will instantly generate a chart using your data. On the chart, you'll see vertical bars representing sales figures for each month. These bars help you quickly visualize which months had higher or lower sales. To make this even clearer, we can enable data labels that display the exact sales figures on top of each bar. So, instead of guessing, you'll see the exact values for each month directly above each column. When we look at numbers in a data table, it's not always easy to spot which month had the highest sales. But the moment we switch to a chart, everything becomes clear at a glance. That's the real power of charts. They make comparisons easier and help present data in a way that's instantly understandable for the user. You'll also notice a plus icon on the upper right corner of the chart. Clicking this opens the Chart Elements panel. This is where you can choose to show or hide elements like axis titles, chart title, data labels, grid lines, and even the legend. We'll be covering each and every chart element in detail in the upcoming lectures, so you'll get a clear understanding of how they work and how to use them effectively. Now I'm going to delete this chart and show you how to insert a new one without selecting the data first. Simply click on any blank cell, go to the Insert tab, open the chart options, and select the column chart. At this point, Excel will insert a blank chart. But don't worry, configuring it is quite straightforward. Just right-click on the chart and choose the option called Select Data. From there, you can start building your chart by defining the data series and selecting the appropriate ranges. For instance, we can name our series as Sales and select the sales values from the Sales column. Next, for the horizontal axis labels, we can choose the month names from the Month column. Once that's done, your chart will be fully populated and ready to customize. There's also a quick shortcut that many professionals use to save time. Simply select your data and press Alt followed by Function key 1. This instantly creates a chart using your default chart settings. By default, Excel usually inserts a column chart, but you can change this to a line chart or any other type if you prefer. To update the default chart type, go to the Insert tab, click on the small arrow in the Charts group to open the Full Chart dialog box, then switch to the All Charts section. Right-click on the chart type you want to set as default, and choose the option Set as Default Chart. From now on, whenever you press Alt followed by Function key 1, Excel will insert your newly selected default chart type automatically. Now, let's talk about formatting, one of the most overlooked but important aspects of chart presentation. You can easily resize your chart to make it more readable or to better fit your worksheet layout. Just click on the chart to activate it, then place your cursor on any corner or edge. When the resizing handle appears, drag it outward to increase the size or inward to reduce it. Now, if you want to customize the appearance of your chart, simply click on any element. For example, the chart title, the vertical or horizontal axis labels, or the bars themselves. As soon as you select an element, Excel automatically displays formatting options on the right-hand side. These options allow you to change things like colors, borders, font styles, and even special effects, helping you tailor the charts look to match your presentation or report. For example, if you want to change the color of the bars in your column chart, start by clicking once on any of the bars to select the entire series. Then, go to the Format tab in the ribbon. Under the Shape Styles group, click on Shape Fill. You'll see a color palette appear, and as you hover over each color, Excel will show you a live preview directly on the chart making it easy to decide which color looks best. Let's say you prefer a shade of green. Simply click to select it, and your chart will update immediately with the new color. You can also customize the borders around the bars. Click on Shape Outline, where you can adjust the border color, change the line style, and even apply gradient effects for a more polished look. For even more control, use the Format panel on the right side, where you'll find advanced options like border transparency, thickness, dash type, and joint type. All of these tools allow you to fine-tune your chart's appearance to match your style or branding perfectly. Now suppose you want to add a second data series, for instance, to compare actual sales against a target. Simply add this second column of data. Another simple way to include new data in your chart is by extending the chart's range. To do this, first click on the chart to select it. You will see a highlighted outline around the data range that the chart is currently using. Now, place your cursor on the small handle at the bottom right corner of this highlighted box. Click and drag it to include the next column of data. As soon as you release the mouse, Excel will automatically update the chart, and the new column of data will appear as an additional series on the chart. Alternatively, you can use the Select Data dialog box to add the new series, just like we did earlier when we added the sales figures. Right-click on the chart and choose the option called Select Data. In the dialog box, click on Add to insert a new series. Then, enter a name for the series, such as Actual or Target, and select the corresponding values from your worksheet. Once done, click OK, and the new series will be added to your chart right alongside the existing data. Managing multiple data series in a chart is quite simple. If you ever need to rearrange the order of the series, give them more meaningful names, or remove any that are no longer needed, just right-click on the chart and choose the Select Data option. In the dialog box that appears, you'll find buttons to move up or move down, allowing you to change the sequence in which the series appear. You can also click Add to insert a new series, or select an existing one and click Remove to delete it from the chart. It's a flexible way to keep your chart organized and relevant as your data evolves. Let's also explore category order. Sometimes, you'll notice that the months appear from bottom to top instead of top to bottom. You can reverse this order by right-clicking the vertical axis, choosing Format Axis, and enabling the option called Categories in reverse order. Just like that, your axis adjusts to a more natural top-down flow January to December. And now, let's take a moment to fine-tune the visual presentation of the chart. If the data labels appear too small or hard to read, simply click to select them. Then, go to the Home tab where you can increase the font size, make the text bold, or apply a different font color based on your preference. The same applies to the chart title. By default, Excel might display it as Sales or something similar. Click on the title to select it, and you can change the text to something more meaningful. You can also reposition the title to place it above the chart, center it, or move it wherever it looks best. And just like with the data labels, you can format it using font style, size, and color options to give your chart a clean and professional appearance. Speaking of positioning, data labels can be placed in a variety of locations based on what works best for your chart. You can choose to display them at the inside end of each bar, at the inside base, at the outside end, or even as a callout for more emphasis. It's a good idea to try a few different positions and select the one that offers the best readability and overall balance for your chart layout. Now here's something a bit more dynamic. Suppose you want to add another version of the actual series, maybe to demonstrate a specific scenario or highlight duplicate values. You can do this by going back to the Select Data window and clicking on Add Series. Give it a name like Actual Duplicate and select the same values used for the original series. Excel will then add this as an additional layer to your chart, visually displaying both series side by side. If at any point you no longer need this duplicate series, simply return to the Select Data window, select the series you want to remove, and click Delete. The chart will update instantly to reflect the changes. And finally, if you'd like to display the data table directly below your chart, Excel makes that easy too. You can turn on the Data Table option, and it will show the underlying values in a clear, tabular format just beneath the chart. This is especially helpful when you want to present both numbers and visuals together in one place. That's the real power of charts in Excel. They're not just about numbers. They're about telling a story through data. Whether you are comparing monthly performance, highlighting targets, or identifying trends, charts make it easier for your audience to understand the insights behind the information. So take some time to explore, experiment, and enhance your spreadsheets using clear and meaningful visualizations. Thank you for watching, and I look forward to seeing you in the next session. Hello everyone, and welcome back. In today's session, we are going to create a chart and take a closer look at its various elements. Since we have already covered the basics of chart creation, let us briefly revisit the steps. First, select the dataset you want to visualize. Next, go to the Insert tab located on the ribbon. Then, choose one of the most commonly used chart types, which is the column chart. Once selected, the chart will be generated automatically. You can adjust its size to better fit your screen or layout preferences. Now, let us begin exploring the different parts that make up a chart. In the upper right corner of the chart, you will notice a green icon. This represents chart elements. When you click on it, a list will appear showing various components that you can choose to show or hide based on your needs. The first item on the list is axis. The horizontal line at the bottom of the chart is called the x-axis, while the vertical line on the left side is known as the y-axis. If you choose to uncheck the axis option, you will see that the numbers or labels along these lines are removed. This can be helpful when you want a simpler or cleaner visual presentation. Next, let us discuss axis titles. When you enable this option, you will notice editable text boxes appear along both the x-axis and the y-axis. These titles help describe what the data along each axis represents, and you can customize the text based on the context of your chart. If you feel that axis titles are not necessary for your visual, you can simply turn this option off. Next, we have the chart title, which is typically displayed at the top of the chart. If you want to remove it or change its position, you can click the arrow next to the chart title option. This will show a few placement choices, such as placing the title above the chart or using a centered overlay. For more control, you can select the option called More Options. This opens a formatting pane on the right side of the screen, allowing you to customize the appearance and placement of the title. A clear and descriptive chart title is especially helpful when you are presenting your data to others. Now let us revisit data labels, which we touched on in earlier sessions. Data labels are the numeric values that appear directly on top of each column in the chart. Enabling them makes your data easier to read at a glance. Once turned on, you can also choose where to place the labels. Common positions include center, inside end, and inside base. For example, if your chart includes two data series such as chairs and tables, you can customize the labels separately for each one. To format data labels, simply click on one of the bars, such as the orange bar representing tables. Then, go to the Home tab. From there, you can change the fill color to black, the font color to white, and adjust the font size to improve readability. Now, let us move on to customizing the data labels for the Chairs series. Start by clicking directly on one of the data labels that represents the Chairs series. Make sure that only those specific labels are selected and not the entire group of labels. This allows you to apply formatting changes to just the Chairs labels without affecting the others. First, change the position of these labels to center. This means the value will appear right in the middle of each column, making it visually balanced and easy to read. Next, go to the Home tab on the ribbon. From here, you can modify the orientation of the text. Set it to vertical. This is especially helpful if the column is narrow or if you want the labels to fit neatly without overlapping. After that, change the font color to white. This ensures that the text stands out against a darker background or bar color. If the labels are still not clearly visible, consider changing the fill color of the bars themselves to create a better contrast. You might choose a darker or lighter shade based on what improves readability. These small adjustments not only enhance the look of your chart, but also make your data easier to interpret for your audience. Remember, thoughtful formatting can greatly improve the effectiveness of your visual presentation. Next, let us look at how to adjust the appearance of the data series, specifically the width and spacing of the columns in your chart. To begin, double-click on any data bar within the chart. This will open the Format pane on the right side of your screen, where you can make detailed adjustments. In the Format pane, make sure the correct data series is selected. Once selected, you will see two important options: Series Overlap and Gap Width. The Series Overlap setting controls the amount of space between multiple series within the same category. For example, if you have columns representing both chairs and tables in each month, adjusting the overlap will either bring them closer together or space them further apart. The Gap Width setting manages the space between the categories themselves. This affects how wide or narrow the columns appear and how much white space is left between groups of columns, such as between different months or departments. By fine-tuning these settings, you can make your chart easier to read, more visually balanced, and better suited to your presentation style. Now, let us explore how to change the overall look and feel of your chart using chart styles. Start by clicking anywhere on the chart to activate it. Once selected, go to the Chart Design tab located on the ribbon. Here, you will find a variety of predefined styles to choose from. These styles adjust the color scheme, background, borders, and other visual elements of your chart. You can simply hover your mouse over any style to see a live preview of how your chart will look with that particular design. When you find one that fits your presentation, click on it to apply the style. Keep in mind that applying a new style may also affect elements like data labels or axis formatting. If that happens, you can always go back and manually reformat those elements to match your preferred design. This flexibility allows you to maintain both visual appeal and readability in your chart. Next, let us talk about legends. Legends are the colored labels that help identify each data series in your chart. To manage them, click on the green plus icon located near the chart, then check or uncheck the option for legend. Once enabled, you can choose where the legend appears. Common positions include the right side, left side, top, or bottom of the chart. You can select the position that best fits your layout and makes the chart easier to read. Each color shown in the legend corresponds to the color of the bars or lines in the chart itself. For instance, if the chair series is shown in blue and the table series is shown in orange, these same colors will appear in the legend next to their respective labels. Using legends effectively helps your audience quickly understand what each visual element in the chart represents, especially when there are multiple series involved. Lastly, let us take a look at the data table option. If you want to display the underlying source data directly below your chart, you can enable the data table. To do this, click on the green plus icon next to the chart and check the box for data table. Once enabled, you will have to display options. You can choose to show the data table with legend keys, which includes the colored indicators that match each data series, or you can choose to show it without legend keys for a cleaner look. If you would like to further customize the appearance of the data table, click on the More Options link. This will open the formatting pane on the right side of your screen, where you can adjust various design elements to better match your overall chart layout. Displaying a data table is particularly useful when you want to provide both a visual summary and the exact figures in one view, making your chart more informative and easier to interpret. Now let us explore a few more advanced chart elements that can enhance the depth and clarity of your data visualization. Error bars are helpful when you want to show the level of variability or potential inaccuracy in your data. They represent a margin of error, often expressed as a percentage. For example, if you're presenting estimated sales figures and expect some fluctuation, you can use error bars to visually indicate that possible range. This adds context and helps your audience interpret the reliability of the values more effectively. Grid lines are the horizontal reference lines that run across the chart. They help viewers align data points with the corresponding values on the y-axis. Depending on your design preference or the amount of data shown, you may choose to turn grid lines on or off. Disabling them can create a cleaner look, while enabling them improves readability and precision. Trend lines are used to show the general direction or movement of data over time. They help highlight patterns, such as growth or decline. Old trend lines are most commonly used in line charts. You can also apply them to column charts when you want to emphasize a trend. For example, if the trend line moves from the lower left to the upper right, it indicates an upward trend. This could represent a consistent increase in sales from January to December. On the other hand, a downward trend line may highlight areas of decline that need further attention. Incorporating these elements allows you to present not just the data, but also its context, trends, and reliability, which can be incredibly valuable when analyzing or presenting information. Let us now take a closer look at the options available in the Chart Design tab. This tab gives you full control over how your chart looks and behaves, allowing you to customize it according to your needs. Here are some of the key features you can explore. You can add or remove chart elements such as titles, labels, legends, and more, all with just a few clicks. The Quick Layout feature offers a variety of preset chart arrangements. These layouts adjust the position of key elements like the title, legend, and data labels, helping you find a clean and professional look in less time. You can also change the color theme of your chart. Choose from vibrant, colorful palettes to more subtle, professional tones, depending on the audience and purpose of your presentation. Chart styles offer additional visual enhancements, such as background shading, border effects, and font styling. Hover over each option to preview how your chart will look, then click to apply the one that suits your design. The Switch Row and Column option allows you to rotate your chart data. This is especially useful when you want to change how categories and series are displayed, for instance, shifting months from the horizontal axis to the vertical axis or vice versa. You can also use the Select Data option to modify the data source behind the chart. This is helpful when you need to update the range or include additional categories without rebuilding the chart from scratch. The Change Chart Type option allows you to switch from one chart style to another, such as changing a column chart into a line chart, a pie chart, or any other type that better suits your data story. Finally, you have the option to move the chart to a different location. You can place it on a new worksheet or move it to any existing one. If you choose to move it to a new sheet, Excel lets you assign a name to that sheet. The chart will remain linked to the original data source, so any updates or changes made to the source data will automatically reflect in the chart, keeping everything dynamic and up to date. These features within the Chart Design tab help you create well-structured, visually compelling charts that align with your presentation goals. And that brings us to the end of this lesson on how to format and customize chart elements in Excel. In the next session, we will dive into the various types of charts available, including line charts, pie charts, statistical charts, waterfall charts, and sparklines. We will also discuss the best use cases for each chart type to help you present your data in the most effective and impactful way. Thank you for watching, and I look forward to seeing you in the next lecture. Hello and welcome once again. I'm glad to have you back. In today's video, we're going to explore the different types of charts available in Excel. And more importantly, we'll learn when to use each chart type and how to use it in the most effective way. Charts are powerful tools that help us present data visually, so it's easier to understand and explain. But the key is to choose the right chart for the right situation. Let's start with something we've already discussed, and that is the column chart. If you missed it, I highly recommend checking it out because it forms the foundation for many other charts. Now, let's move forward and take a look at the line chart. Let's begin with the line chart. A line chart is one of the best tools when it comes to identifying trends over a period of time. If you're trying to understand whether your data is showing an upward trend, a downward trend, or if it's staying more or less the same, then the line chart is your go-to option. Let me give you a simple example. Suppose I have monthly sales data for two items. One is chairs and the other is tables. Now, if I just look at the numbers in a spreadsheet, it's not easy to spot whether sales are increasing, decreasing, or fluctuating. The numbers are there, but they don't tell the full story at a glance. So here's what I do. I select the entire dataset, go to the Insert tab at the top of the screen, and from the chart options, I choose the line chart. Excel gives us quite a few styles to choose from. You'll find basic 2-dimensional line charts and even 3-dimensional versions if you want a bit more visual depth. There are also area-based line charts that shade the area below the line to show volume. And yes, these also come in both flat and 3-dimensional formats. Now, let me tell you about one of my personal favorites. It's called the stacked line with markers. This version not only shows the lines, but it also places visible dots or markers at every single data point. These small circles make it super easy to notice exactly where the values are changing month by month or point by point. And here's another helpful feature. If you're comparing multiple items like chairs and tables, and you want to focus on just one, you can easily remove one of the lines. For example, by removing the line for tables, you'll be able to concentrate entirely on how the sales of chairs have performed over time. So that's the line chart. Simple, clear, and incredibly useful when you want to spot patterns and trends in your data. Now let's talk about another very popular chart type, the pie chart. A pie chart is great when you want to show how different parts contribute to a whole. It uses a circular shape to represent your total value, and then slices it up to show each item's proportion within that total. It's perfect for showing percentages, shares, or distributions. For example, imagine you have sales data for several products in the month of January. You want to see which product contributed the most and how the others compare. To do that, you simply select the data, make sure to include both the product names and their sales figures, then go to the Insert tab on the ribbon. From the chart options, choose the pie chart. Once you insert it, Excel will instantly create a circular chart that shows each product's share of the total. You'll also notice that Excel offers multiple options. There is the classic pie chart, and then there's the 3-dimensional pie chart, which adds a bit of visual depth if you prefer a more stylized look. To make your pie chart even more informative, you can turn on data labels. This will display the exact percentage value for each slice directly on the chart. That way, viewers can quickly understand how much each category contributes. For a more polished presentation, you can use the quick layouts available in the Chart Design tab. These layouts instantly rearrange the chart elements, like the title, labels, and legend, to give you a better visual balance. You can also experiment with different color themes to match your report style or brand colors. And of course, you can adjust the overall chart style to make it cleaner, bolder, or more vibrant depending on your audience. So if you ever need to present parts of a whole in a clear and visually appealing way, the pie chart is a simple and effective choice. Next, let's take a look at the donut chart. A donut chart is quite similar to a pie chart, but with a little twist. It has a hole in the center. This makes it visually unique and also very useful when you want to compare two sets of values side by side within the same visual space. For example, let's say you have sales data for various products for the months of January and February. You want to compare how the sales changed from one month to the next. To do that, first select the columns that include both January and February sales. Then go to the Insert tab, click on All Charts, and choose the donut chart. Once the chart appears, you can resize it to fit better on your worksheet and apply formatting to make it more readable. In this chart, you'll typically see two rings. The inner ring can represent January, and the outer ring can represent February. Or, vice versa. The important part is that each ring represents a different set of data, allowing you to see the changes at a glance. This layout makes it really easy to spot trends. For instance, if you look at the segment for oranges and see that in January it was around 14%, and in February it increased to 22%, that immediately tells you that orange sales have gone up. To enhance the chart even further, you can apply data labels to show exact percentages, use bold colors for better contrast, or explore different styles from the Chart Design tab to suit your presentation. So, if you're looking to compare category-wise values across two time periods in a neat, circular format, the donut chart can be a great choice. It's both informative and visually engaging. Now let's move into the world of statistical charts, starting with the histogram chart. A histogram is a fantastic tool when you want to understand the distribution of a dataset. It helps you see how values are spread across different ranges. This is especially useful when you're working with large amounts of numeric data. Let me give you an example. Suppose you have the age data of around 400 to 500 customers. You're trying to understand your customer base better, and you want to see which age groups are most common. Instead of going through the data manually, a histogram can instantly give you that overview. Here's how to create one. First, select the column that contains all the age values. Then go to the Insert tab at the top of your screen. From there, navigate to the column chart options and choose the histogram chart. Excel will take it from there. It will automatically group the age values into ranges, which are called bins. For example, you might see ranges like 18 to 25, 25 to 30, and so on. Each vertical bar in the chart represents how many customers fall within that age bracket. Now, if you want to customize how the data is grouped, you can do that too. Simply double-click on any of the bars in the chart. A panel will appear on the right side of the screen. From there, you can adjust the number of bins, in other words, how many age groups you want to show. For example, instead of 8 bins, you might want to reduce it to 6 or increase it to 10. Excel will instantly regroup the data and update the chart to reflect your new selection. This lets you control the level of detail you want to display. Histograms are especially helpful when you need to spot patterns. Are most of your customers in their 20s? Are there fewer people in the senior age groups? A quick glance at the histogram gives you these answers without any complex calculations. So whenever you're working with continuous numeric data and want to analyze how it is distributed, the histogram chart is a smart and effective choice. Now let's move on and talk about the scatter chart. A scatter chart is especially useful when you want to compare two different variables and observe how they relate to each other. It helps you identify patterns, spot correlations, or even detect outliers in your data. Let's take a simple example. Suppose you have a list of students, and for each student, you've recorded their height and weight. Now, you want to find out if there's a relationship between these two variables. For instance, does height tend to increase along with weight? To create this chart, you'll need to define both the x-axis and y-axis values. Start by clicking on a blank cell to position the chart. Then go to the Insert tab, find the Chart section, and choose Scatter Chart. Now comes an important step. In the chart that appears, right-click and choose Select Data. Here, you'll enter your x values, which could be height, and then your y values, which could be weight. Once entered, Excel will plot each data point as a dot, showing the height and weight combination for each student. Once your chart is ready, you can go a step further by adding a trend line. The trend line helps you see the overall direction of the data. For example, as the height goes up, you might observe that the weight also tends to go up. This indicates a positive correlation between the two. And here's something even more powerful. You can choose to display the equation on the chart. This shows the mathematical formula behind the trend line. Additionally, you can also display the R-squared value. This number tells you how well the data fits the trend. The closer it is to 1, the stronger the correlation. So to sum it up, If you're ever looking to compare two sets of numeric values and explore how they move together, the scatter chart is the perfect choice. It's simple, accurate, and provides a deeper layer of analysis with just a few extra clicks. Now let's explore a powerful chart that is especially helpful in financial analysis, the waterfall chart. The waterfall chart was introduced in Excel version 2016, and it's become a favorite for presenting step-by-step changes in values. It's particularly useful when you want to visualize how a starting value, like revenue, turns into an ending value, like net profit, while clearly showing all the intermediate steps in between. Let's walk through a common scenario. Suppose you have a profit and loss summary. Your data starts with gross revenue. From there, you subtract the cost of goods sold, then operating expenses, maybe interest and taxes, until you finally reach profit after tax. To create this chart, first select your data, make sure the values are in the correct order, from top-line revenue all the way down to final profit. Then go to the Insert tab and choose the Waterfall Chart option from the list. Once your chart appears, you can resize it as needed to make it more readable. Now, there's one important step. Excel may not automatically recognize which bars should represent total values. So, you'll need to define these manually. Click on any bar that should be treated as a total, for example, the starting gross revenue or the final profit after tax. Then open the Format pane on the right-hand side. Under Series Options, enable the option called Set as Total. Doing this tells Excel that the bar is a fixed total, not a step in the calculation. Once formatted, you'll notice that different colors are used for different types of values. For instance, the green bar could represent gross revenue, which is your starting amount. The orange bars usually indicate deductions, things like cost of goods sold or various expenses. And the blue bars show positive values, such as additional income or gains. At the end of the chart, you'll see the final bar. This is your profit after tax. It gives you a clear view of how each individual factor contributed to the final result. So, if you want to break down financial data in a clean and easy to understand format, the waterfall chart is the perfect visual tool. It tells the story of how money flows in and out and helps your audience follow the steps from beginning to end. And now, let's wrap up our charting journey by talking about something small but incredibly powerful: sparklines. Sparklines are tiny charts that live inside a single cell. Yes, just one cell. Even though they're small, they're super effective when you want to show trends without taking up too much space. That's why they're perfect for dashboards and compact reports where space is limited, but insights are still important. Let's go through an example. Imagine you have monthly sales data for different regions like Northeast, Northwest, Southeast, and Southwest. You want to quickly see how sales are moving in each region across the months. Here's what you do. First, select the data for one region, just the row of monthly sales. Then go to the Insert tab, and under the Sparkline section, choose Line Sparkline. Excel will ask you for two things. First, the data range, that's your row of monthly values. Second, the location where you want the sparkline to appear, usually the cell right next to that row. Once you enter both, just click OK. And there you have it. A neat little line appears inside the cell, showing the sales trend, whether it's rising, falling, or fluctuating over time. It's a great way to get a quick visual without building a full chart. Now, if you prefer a different look, you can also choose a column sparkline. This version shows vertical bars instead of a line, giving a slightly different feel, but still showing the same trend. To make your sparklines stand out more, you can increase the height or width of the row or cell where they appear. This gives the chart more room to breathe and makes it easier to read. So if you're creating a summary or a dashboard and want to pack in trend visuals without cluttering the sheet, sparklines are a simple yet smart solution. They show just enough to help you spot patterns, and they do it all in a single cell. And with that, we wrap up today's session on the different types of charts available in Excel. We've explored a variety of charts, from line charts to pie charts, donut charts to histograms, and even more specialized ones like waterfall charts and sparklines. Each of these chart types serves a unique purpose and helps you tell your data story more effectively. If you'd like to dive deeper and learn how to use these charts in real-world scenarios, I invite you to check out our full Excel visualization course. In that course, we go beyond the basics and show you hands-on techniques, best practices, and tips to make your reports and dashboards truly stand out. If you have any questions or thoughts about what we covered today, feel free to drop them in the comments section. I'd be happy to help. Thank you so much for watching. I appreciate your time and attention. And don't forget there's more to come. Stay tuned for our next lecture, where we continue to sharpen your Excel skills one step at a time. Hello everyone, and welcome back once again. In today's video, we are going to explore a very interesting feature in Excel, and that is the map chart. Just like the name suggests, a map chart is used when you want to display data on a map in a visual and easy to understand way. Let me walk you through a simple example to make this clearer. Imagine I have a list of countries. Along with each country, I also have its approximate population, and the values are shown in millions. Now, instead of showing this data in a plain table or a regular column chart, what if we want to actually display it on a world map? That is, we want to see the countries filled with color or shades that represent their population sizes. That is exactly what we are going to learn in this session. But before we jump into the steps, let me tell you something important. When you create a map chart for the very first time, your computer must be connected to the internet. This is because Excel uses an online service to plot the data on the map. It needs that connection to fetch the right location details and apply the visuals accordingly. Now here's the good part. Once the map chart has been successfully created, you can disconnect your computer from the internet. The chart will remain as it is, and you will be able to use and view it without any issues. But keep in mind, if you make any changes to the data later, for example, you update the population numbers or add more countries, then you will again need an internet connection to refresh and update the chart. So, to sum it up, you need internet only at the time of creating the chart and whenever you make any updates. Otherwise, it will continue to work offline without any problems. Alright, now that we understand the basics, let's move forward and see how to actually create a map chart in Excel step by step. Now let's talk about how to insert a map chart in Excel. The process is actually very simple and straightforward. Let's go step by step. Step 1. First, select your dataset. That means you highlight the cells that contain your country names and their corresponding population numbers. Step 2. Once your data is selected, go to the Insert tab on the Excel ribbon at the top of your screen. This is where you will find all the chart options. Step 3. Inside the Insert tab, look for a section called Charts Group. Within that group, you will clearly see an icon labeled Maps. Just click on that. At this point, depending on your Excel version and internet connection, you might see a small message that says Premium Only. Do not worry. Just wait for a few seconds. As long as your computer is connected to the internet, the map chart will automatically appear on your screen. Now let's take a look at our current example. You will see that countries like India and China are showing up in darker shades. That is because they have the highest population figures in our list. Then come countries like the United States, Indonesia, Pakistan, and Brazil. These countries also have large populations, but slightly lower than India and China, so their color shade is a bit lighter. As we move further down the list to countries with lower population numbers, the color on the map starts to fade. This effect is known as color grading. It helps us understand the intensity of values just by looking at the map. Darker colors mean higher values, and lighter colors represent lower values. And that's the beauty of a map chart. It turns plain numbers into a powerful visual story. In the next part, we will explore how to customize the chart, add data labels, and format it to make it even more impactful. Now that your map chart is ready, let's learn how to format it and make it look even more polished and professional. To begin with, simply right-click anywhere on the chart. Alternatively, you can double-click on the chart. This will open a panel on the right-hand side of your Excel window called the Format Chart Area pane. From this pane, you can customize different parts of the chart easily. Let me walk you through a simple example. First, look for an option called Chart Options in the top drop-down of that pane. Click on it and then select Chart Area. This will highlight the entire chart background, which means any changes you make will apply to the full chart, not just a small portion of it. Now let's say you want to change the background color of the chart. In the same pane, look for an option called Fill. Click on Fill and you will see a few choices. The first one is Solid Fill. This lets you pick a single color to apply across the entire background. Choose any color that matches your presentation style or branding. Next, you have Gradient Fill. This adds a gradual blending effect between two or more colors, which can make the chart look more dynamic. Then comes Pattern Fill. This allows you to apply textured or patterned backgrounds like stripes or dots. There is also an option called Picture Fill. With this, you can actually use an image as the background for your chart. And finally, if you prefer a clean look, you can reduce the transparency or even make the chart background fully transparent. All of these formatting tools help you personalize your chart and make it more visually appealing, especially when presenting to a larger audience or including it in reports. Now, let's focus on the chart title. We have already talked about chart titles in earlier videos, but here's a quick reminder. Click directly on the chart title that appears above the chart. Once it is selected, simply start typing to enter the heading of your choice. This could be something like Population by Country or World Population Map, whatever suits the message you want to deliver. You can also change the font, size, color, and alignment of the title using the formatting tools on the Home tab. Now let's look at the legend. The legend is the small guide that usually appears on the right or bottom of the chart. It tells us what the different shades or colors on the map represent. For example, darker colors may indicate higher population values, while lighter colors show lower values. If you want to reposition the legend, click on it once. You will see small handles appear around it. Now you can drag it to a different location like the top, bottom, left, or right side of the chart wherever it fits best visually. And just like other chart elements, you can also format the legend. Right-click on it or use the Format pane to change the font style, size, and background color. These small adjustments can really enhance the clarity and visual appeal of your chart. Now let's take a look at the plot area. The plot area is the part inside the chart where the actual map is displayed. It's different from the chart area, which covers the entire outer frame including the background and titles. To work with the plot area, simply click anywhere inside the map, but not on the title or the legend. Once the plot area is selected, you'll notice only the section where the map is drawing gets highlighted. This confirms that you're working with the plot area and not the outer chart area. Now, just like we did earlier, you can go to the Format pane on the right side. If you try filling this area with a solid color, you'll notice that only the inner map area changes, while the rest of the chart remains the same. This helps you clearly understand which part of the chart you're formatting. But for this example, let's keep things simple. So go to the Fill option and choose No Fill. This keeps the background of the map clean and distraction-free, helping your data stand out more clearly. Now let's talk about the most important formatting section when working with a map chart, and that is the series. The series refers to the actual data that the map is built on. This includes the values that determine how each region is shaded or colored. To format the series, first click on the map itself. Then, in the Format Chart Area pane on the right, look for a drop-down that says Chart Options. Click on it and choose Series from the list. Once you select Series, you will see several new options appear under the heading called Series Options. Let's go through them one by one. The first option is Projection. Projection controls how the map is shaped or stretched on the screen. You can experiment with different projection styles to see which one looks best for your data, but in most cases, the default option works just fine. The next setting is Map Area. This is a very useful option, especially when your data is focused on a specific set of countries or regions. For example, let's say your dataset includes only 10 countries. But right now, Excel is showing the entire world map, including many countries that are not even in your data. If you want to keep the map clean and focused, you can change the setting. Click on Map Area and choose the option that says Only Regions with Data. The moment you select this, Excel will zoom in and show only the countries that are part of your dataset. Everything else will disappear, making your chart easier to read and visually more relevant. This small setting can make a big difference when you are presenting or printing the chart, especially if you want your audience to focus only on the data that matters. You can choose to display Best Fit Only or Show All. These options determine how country names or data labels appear on the map. Now let's move on to customizing the colors in your map chart. By default, Excel applies a standard color theme to represent your data. But the great thing is you can easily change that to match your own preferences or to better highlight certain values. Here's how it works. Once you've selected the series in the Format pane, scroll down until you see the option for Series Color. This is where you can set up a custom color scale. You'll notice that Excel lets you define different colors for different value ranges. For example, you can choose a very light color, such as pale yellow or light blue, to represent the lowest values in your dataset. These are the regions or countries with the smallest numbers. Then, for values in the middle range, you can pick a medium tone, something like orange or medium blue. This gives a balanced look and shows areas that fall in the average range. Finally, for the highest values, you can go with a deep or dark color, such as dark red, navy blue, or deep green. These shades immediately draw attention and show where the data is the most intense or the highest. This kind of color gradient helps your viewers understand the data at a glance without even needing to read the exact numbers. Just by looking at the shades, they can tell which areas are high, medium, or low. It's a powerful way to tell a visual story with your data. And with that, your map chart is not only functional, but also visually engaging. Now let's talk about a real-life use case. You might be wondering, where exactly is a map chart useful in day-to-day work? Well, while we may not always use it to show population data, map charts are extremely helpful when working with business-related information. Let me give you a few examples. You can use a map chart to show sales performance across different states or regions. This gives you a clear visual picture of where your business is doing well and where it might need improvement. You can also use it to display profit distribution by region. For instance, darker areas can represent high profit zones, while lighter ones may indicate lower profits. Another great use is to show the number of clients in each area, which regions have the most customers, and where you might want to focus your marketing efforts. Or you might want to show the locations of your company's offices. A map chart can make that instantly visible and more engaging than just listing the addresses. All of these examples are perfect situations where a map chart helps you present geographic data in a visual, easy-to-understand format. But there's something important to keep in mind. A map chart in Excel only supports one data series at a time. That means you can only show one set of values in one chart. You cannot display multiple metrics together like sales and profit in the same map chart. Now let's look at one final example. Suppose you have population data for various states in the United States. Here's how simple it is to create a map chart. Step 1. Select your dataset. This includes the state names and their population figures. Step 2. Go to the Insert tab in the ribbon. Step 3. Click on the Map option, and the chart will appear on your sheet automatically. It really is that easy. And if you want to make the chart even more informative, you can add or remove data labels, which are the exact values shown directly on the map. You can do this from the Format pane or by clicking on the chart elements. And that's it. You now know how to create, format, and customize a map chart in Excel. If you have any questions or run into any issues, feel free to reach out in the comments or message box. I will do my best to help you as soon as possible. Thank you so much for watching, and I will see you in the next video with a brand new topic. Hello and welcome back. In this video, we are going to explore a very useful feature in Excel called Whatif analysis. This feature is available under the Data tab inside a group called Forecast. Now, when you click on the small drop-down arrow under Whatif analysis, you'll see three options: Scenario Manager, Goal Seek, and Data Table. In this session, we'll focus on the first two, Goal Seek and Scenario Manager. We'll understand their purpose and learn how to use them with practical, real-life examples that you can apply both at work and in your personal life. Let's start with Goal Seek. Imagine this scenario. You have a loan amount. The loan term is already defined, and the interest rate is also provided. Using this information, we have calculated the monthly EMI using a built-in Excel function. But let's say you don't want to pay more than 15,000 as EMI. Currently, the EMI is coming out to around 16,000. So, your question is, if I want my EMI to be 15,000, what should the interest rate be? That's exactly what Goal Seek helps us calculate. Understanding the EMI formula. We used a financial function called PMT to calculate the EMI. Let me break it down. In the formula, the first argument is the interest rate. Since the given interest rate is annual, we must divide it by 12 to get the monthly rate. The second argument is the number of periods. For a 3-year loan, it becomes 36 months. The third is the present value, or the loan amount. Since this is an outgoing payment for you, we use a negative value. Either enter the loan amount with a minus sign, or multiply it by -1. Once you enter the formula and press enter, Excel gives you a result. In this case, it is showing a monthly EMI of around 16,000. Now, you don't want to manually change the interest rate again and again to guess the EMI. That's where Goal Seek helps. Using Goal Seek to find interest rate. Here's how to do it. Step 1. Select the cell that contains the EMI formula. Let's say this is cell C13. Step 2. Go to the Data tab on the ribbon. Step 3. In the Forecast group, click on Whatif analysis and select Goal Seek. A dialog box will appear with 3 inputs. Set cell. This is the cell where the EMI formula is. We choose cell C13. To value, this is the target EMI you want. We type 15,000. By changing cell, this is the cell where the interest rate is entered. For example, cell C11. Click OK. Excel will now calculate and show you the exact interest rate required so that the EMI becomes exactly 15,000. Since neither the loan amount nor the loan term has changed, Excel reduces the interest rate to match the desired EMI. That's the power of Goal Seek. You give it a goal, and it seeks the input needed to reach that goal. Another real-life example, break-even pricing. Now, let me show you one more powerful example. Something we face in business. Let's say you are producing a product. Your fixed cost is $5,000. Your variable cost is $20 per unit. You are planning to sell 200 units. Your goal is to find out the break-even price, the minimum selling price at which you make zero profit or loss. Let's understand the calculations. Total revenue is calculated as units multiplied by selling price. Total cost is the sum of fixed cost and the total variable cost, which is units multiplied by variable cost per unit. Profit is then calculated as revenue minus total cost. Suppose you initially enter a price of $70 per unit. Excel will calculate revenue and profit accordingly. Now, you want to find the exact selling price where profit becomes 0. Here's how to do it with Goal Seek. Select the profit cell, for example, cell C36. Go to Data, click on Whatif analysis, and choose Goal Seek. Set cell C36. To value 0. By changing cell C33, this is the cell where selling price is entered. Click OK. Excel will now calculate the exact price at which you break even. Let's say it shows $45 per unit. That means if you sell at $45, your profit will be 0. So, you should never sell below this price. If you want to make a specific profit, you can increase the desired value, and Excel will calculate the new required price. Scenario Manager, comparing multiple scenarios. Now let's move on to the second tool, Scenario Manager. Let's say you don't know what price to set, but you want to see the profit at different price levels, for example, at $50, $60, and $75. You can use Scenario Manager to create and compare all these possibilities. Here's how. Step 1. Select the profit cell, such as C36. Step 2. Go to the Data tab and click on Whatif Analysis, then choose Scenario Manager. If any old scenarios are there, delete them first. Click Add to create a new scenario. Now enter a name for your scenario. For example, price equals 50. In changing cells, select the selling price cell, which is C33. Leave the rest as is and click OK. Enter the value as 50 and click Add. Repeat the same steps. Scenario 2, price equals 60. Enter value 60. Scenario 3, price equals 75. Enter value 75. Now click OK to close the Add window. Click on Summary to generate a report. In the Summary window, Results cell will be C36, where profit is calculated. Click OK. Excel will now create a new table showing all your scenarios with their corresponding profit values. You'll see that at price 50, your profit is $1,000. At 60, it is $3,000. At 75, it becomes $6,000. This kind of comparison is extremely helpful for decision making. You can use Scenario Manager in many situations, like planning sales targets, projecting profits, adjusting costs, or forecasting growth. Closing notes. So that's how you can use Goal Seek and Scenario Manager in Excel to do backward calculations, perform break-even analysis, and make data-driven decisions with confidence. If you have any questions or need help applying these tools in your own work, feel free to ask in the comments. Thank you so much for watching. See you in the next video with another useful topic. Hello everyone, welcome back to today's video. In this session, we're going to learn all about named ranges and the name manager in Excel. As you all know, every person and everything in this world has a name. In the same way, when we work in Microsoft Office, specifically Excel, we deal with spreadsheets and workbooks. Inside these workbooks, there are cells where we input data, and these cells already have their own names based on their column and row positions. For example, column A, row 1 is cell A1. But sometimes, we need to assign our own custom names to particular ranges of cells, shapes, or charts. Why? Because when we're dealing with a large set of data, referring to specific cells by their usual column row names can get complicated and confusing. So, to make things easier, we give certain cells or ranges meaningful names according to their purpose. Then, we can use these names anywhere in our workbook instead of the cell references, making formulas and navigation simpler. Let me show you a practical example. Here, I have some sales data organized by region. I want to calculate a commission based on sales. Suppose the commission rate is stored in a single cell, say cell C17. Normally, I would refer to cell C17 directly for the commission rate in my formulas. But imagine if the data grows bigger and the commission rate is far away somewhere else in the sheet, it would be annoying to keep entering that cell reference again and again. Instead, I can define a name for that cell. So, when I select cell C17, I open the name box where you see the cell reference and I type a descriptive name, for example, commission rate. Important note, when giving names, do not put spaces. So, instead of writing commission rate with a space, write it as one word like commission rate or use underscores or other conventions to remember it easily. After entering the name, press Enter. Now, when writing formulas, instead of typing C17, I simply use the name commission rate. Traditionally, to calculate commission, you multiply the amount by the commission rate. If you type a formula like amount cell reference multiplied by C17 Excel might warn you that the name is already defined and suggest using it. You can accept that, and from now on, your formula will show commission rate instead of C17. You can also keep C17 if you want, but the benefit of naming is that your formulas become clearer and easier to understand. Now, suppose you copy this formula down many rows. Instead of manually changing cell references, the named range makes your life easier because the name commission rate always points to the correct cell, regardless of where you paste the formula. You can also define names for ranges instead of just single cells. For example, the sales data range might be named Sales. You can define range names either by typing them in directly or by using the Name Manager found under the Formulas tab. The Name Manager is a powerful tool where you can see all the names defined in your workbook. You can select a name and edit it or delete it if needed. You also have options to define new names here. When you define a new name, after selecting the range, you can give the name, and you'll notice that Excel suggests a name based on your selection. You can accept the suggestion or change it. One important setting here is the scope of the name. Scope determines whether the name is valid. If you set the scope to the whole workbook, you can use that name in any sheet within the workbook. But if the scope is limited to a particular sheet, the name works only in that sheet. After naming the ranges or cells, you can use these names in formulas anywhere within their scope. For example, you can write a formula to sum the range named total sales by typing sum and inside the brackets putting total sales. This will give you the total of all sales in that range. Similarly, you can multiply the sum by commission rate to calculate total commission. Formatting the commission rate as a percentage makes it clearer in reports. One key point to remember is that names defined in one workbook cannot be directly used in another workbook. Finally, through the Name Manager, you can maintain all your named ranges and cells, add new ones, edit existing ones, or delete them as needed. So, that was an introduction to named ranges and the Name Manager in Excel. In the next video, we will see practical examples of how to use these names effectively in real-life professional and personal scenarios. I hope this explanation helps you understand the concept clearly. Thank you for watching. Hello everyone, welcome once again. We were talking about named ranges earlier, and in this video, we will learn an advanced use of them. Here, I have some sales data organized by region and month. The task I want to perform is to retrieve the sales data for any particular month and region and display it below. There are many ways to do this in Excel, but we will use named ranges to do it simply and effectively. Now, this example shows a very small table. But imagine you have a much bigger data set where finding a particular value can be challenging. By using named ranges, you can easily identify and extract the required data. First, what do? Look at the headings across the top, for example, East, West, North, and South. Select these headings along with the sales data beneath them. Then go to the Formulas tab and click on Create from Selection under Named Ranges. When the prompt appears, specify that the names should come from the top row because our headings are on the top row. Click OK. Now, the entire table is saved as named ranges automatically. You don't have to do this one by one. Excel does this in bulk, which makes it very easy and quick. Next, select the sales data along with the month names on the right-hand side. Again, go to Create from Selection, and this time Excel will automatically detect that the heading is in the left column and select it for naming. Click OK. Now, both the regions and months are saved as named ranges corresponding to your data. Very easy, right? You can start doing this from today. Close the dialog. Now, whenever you want to retrieve data, for example, the sales for North region in the month May, you can write in a cell equals and then start typing North and press space. Then type May and press enter. If you press F2 to edit and confirm, you will see the result fetch the exact data in the intersection of North row and May column. This way, you get the intersection data directly, which is very useful. You can also do this with drop-down lists to make it more interactive. But this is already a very easy method to pull out specific information from large datasets. If you have any questions or queries related to named ranges, feel free to ask me in the comments. I will try my best to respond quickly. Thanks for watching. See you in the next video with new topics. Hello and welcome once again. Let's start our analysis with a practical example. We have received Amazon sales data, which includes the entire transaction information such as sales, sales returns, and cancellations. This data is provided by Amazon in Excel format. Now, we have separate files for April, May, and June. We saved all these files in one folder. This is where Power Query becomes a huge advantage. Once you set it up one time, whenever you add new data, for example, the data for July, simply placing that new file into the same folder will automatically add it to all your reports. Then, all you have to do is click a refresh button and all your reports update instantly. But keep in mind, your data structure must remain consistent. This means the columns and their order in every file should be exactly the same. If there's any change in the input structure, you will need to modify your setup accordingly. So, be careful about this. Let's begin by opening Excel. We create a new file and go to the Data tab. Here, you will see an option called Get Data. Click on it. You will see many options, such as importing data from files, databases, online services, and more. We want to import data from files, so hover over From Files. You can import data from Excel files, CSV or text files, XML files, JSON files, or even from a folder. Since we want to combine multiple files, we will use the option to import from folder. This is the best choice to merge multiple files at once. If you wanted to use a single file, you would select that particular file and import it. But for this case, since we have multiple files, select the folder where your files are saved and then click Open. After selecting the folder, you will see all the files available inside that folder. Their names and related information will be displayed. At the bottom of this window, you'll see a few options. Since we want to combine the files, click on Combine and Transform Data. This will start some background processing, so please wait for the new window to open. This new window shows the combined files data. On the right-hand side, you will see all the columns that have been combined. At the top, there's an option to select which file to use as a sample for the column headings. You can decide to keep the first file's headers, second file, or a particular file. This tells Excel how to treat the headers. The first row will be treated as the headings and the rest as data. There is also an option to skip files with errors in them, which you can select if needed. Click OK to proceed. Your data will connect, and Power Query will load it for you in its own format. This window will look a little different from standard Excel. At the top, there are menus. On the left is the query list, and on the right side is the very important Query Settings panel. Here is where you will see the different steps Power Query takes to process your data. Think of these steps like macros or VBA code. Every action you perform is recorded as a step. For example, filtering data, removing columns, changing data types, and you can review or edit these steps later if needed. If you click on the gear icon next to any step, you can change the details of that step. For example, if you click on the first step, you will see the source location of your data files. The following steps might include filtering hidden data, applying custom functions, removing unwanted columns, expanding combined data, and changing data types. Now, your data is loaded and ready, so let's start working on it. Power Query also creates some helper queries automatically, which we do not need to modify. You can collapse those for cleanliness if you want. Our main focus will be on the query named Amazon or whichever name your query has. You will see that all your data is combined month-wise. The source file names are displayed so you know which data came from which file. Since the data is large, you can scroll down or press Ctrl and End keys to jump to the end of the data to review. This dataset is quite big, which is great as it gives you many opportunities to analyze. Now, looking at the data, you will notice some things like blank invoice numbers. This means some orders were cancelled before shipping, so no invoice number was generated. We do not want those records in our final data, so we will filter out these blank invoice numbers. You will also see transaction types such as cancelled orders, free replacements, refunds, shipments, etc. Here, refund means sales returns and shipment means sales. We will use these transaction types to create separate queries if needed. Before filtering transaction types, let's clean the data a bit. First, select unwanted columns like source file name and GSTN number, and remove them by clicking Remove Columns under the Home tab. Then, filter the invoice number column to exclude blanks by unchecking the blank value and clicking OK. This keeps only shipped orders that have an invoice number. The invoice date column currently shows date and time as a timestamp. For our report, we only want the invoice date without time. You will notice a calendar icon next to this column header, indicating it is a datetime data type. Excel and Power Query handle data types carefully. Data can be treated as text, number, datetime, and so on, affecting calculations. If a column is text, calculations won't work properly even if it looks like a number. So, we'll convert the invoice date column to the date data type to remove the time portion. Select the column header, then choose date as the data type. You will see in the query steps on the right that this action is recorded. Next, we move past transaction type for now and look at other columns. Some columns we do want, like order ID, and some we do not, like shipment ID or shipping postal code. You can select multiple columns by holding the Ctrl key and clicking them, then remove all unwanted columns at once. For example, select shipment ID, shipping postal code, and country columns if you want to remove them. Since you know all shipments are within India, the country column is not needed. We'll keep columns like product name, SKU, which is the product code, invoice value, payment method, credit note, and credit note date. For the credit note date, just like invoice date, convert it to the date data type to remove any time part. Once you finish all editing and cleaning, go to the Home tab and click Close and Load. This will load the cleaned, formatted data back into an Excel sheet in your workbook. Now you can clearly see the combined data for April, May, and June, all nicely formatted with only the columns you need. If you add new monthly files into the folder, like July data, just go to the Data tab and click Refresh All. Your report will update instantly with the new data included. Isn't that amazing? All your repetitive work of copying or pasting is saved now. You have a nicely structured format that updates automatically. Power Query is extremely powerful for data analysis. In the next video, we will learn how to segregate data further using this file. Before we finish, remember to save your Excel file with this Power Query setup so you don't lose your work. See you in the next video. Hello everyone, welcome back. In the last video, we learned how to import data into Power Query. We also deleted unwanted columns, formatted some data, converted dates, and removed timestamps. Today, we will learn how to segregate or split this data. For example, I have a column named Transaction Type. This is my base column. It contains 4 types of transactions: cancel, free replacement, refund, and shipment. Now, I want to create separate tables for each of these transaction types. So, I want one table for shipment sales, one for refund sales or returns, one for cancellations, and so on. This way, I can analyze each type of transaction separately and understand how to use them better. So, in this video, we will go through this process step by step. Let's jump back to Power Query. Click on Edit Query. Here, you will see the data we already imported. We named it Amazon data. First, right-click on this query and duplicate it. The reason is, once we start making changes, if there's a mistake, it can be difficult to reverse. So, duplicating the query allows us to keep the original safe. You can give this duplicated query a new name, like version 2 or any name you prefer. Now, since I have already done the first step for the original query, this new query is ready for further changes. You can check the top, where it shows the query name Amazon data version 2. Now, let's say I want to extract just the sales data. To do this, go to the transaction type column. First, deselect or disable the Select All option. Then, filter it to only show shipment transactions. Click OK. And now the table will display only shipment data, which represents sales. Next, we need to work with the order date column. Since dates were not changed previously, you can format this here as needed. For example, you can change the date format to your preferred style. If you want to remove any columns, like the order date itself, because you already have the order number or you do not need it, you can simply delete that column. Now, about the shipment type column. I want this column to appear at the very end since I rarely need to refer to it. To do that, just drag and drop this column to the last position. Similarly, if there are columns like credit note date or credit note number that are not relevant for sales, you can delete them. If you have a column like payment method and you find it useful, keep it. Otherwise, you may remove it as well. Let's move the invoice amount column close to the quantity column for easier analysis. Just drag and drop it beside the quantity column. Before loading this table, I want to sort the data. Select the invoice date column, then click on the sorting option to sort the data by date. This helps keep the data organized. Once you are done with sorting and arranging columns, click Close and Load. This will load the filtered and sorted sales data into a new table. Rename this as Sales Data and don't forget to save your file. Using a similar method, you can filter and create separate tables for sales returns, cancellations, and shipments. Just apply filters for each transaction type accordingly. Before I finish, I want to show you how to split a column into multiple parts if needed. For example, if you see a column with a name SKU that has hyphens or minus signs separating data, you might want to split it like we do in Excel using left, right, or mid functions by specifying the number of characters. In Power Query, you can do the same thing using the Split Column option. Select the column, click Split Column, then choose how you want to split it, for example, by a delimiter such as a hyphen or a space. You can also choose whether to split at the leftmost occurrence, rightmost, or every occurrence of that delimiter. For instance, if your column has 2 hyphens, you can split it into 3 columns on each occurrence. This is a powerful feature for cleaning and structuring your data. If you prefer using the Merge Columns option, select both columns by clicking on one and then holding the Ctrl key while clicking the second. Next, go to Add Column and choose Merge Columns. Choose your separator, maybe a space or a hyphen, name this merged column and click OK. Your new combined column will appear at the end of the table. If needed, you can split this merged column again using the techniques we discussed earlier. Now, let's talk about calculations. For example, if you have a column called Invoice Amount that already includes tax, but you want to separate the taxable amount and the tax itself, here is what to do. Suppose the total amount given in the Invoice Amount column includes 18% tax. You want 2 new columns, one called Taxable Amount and another called Tax. First, create a new column, say Invoice Value, where you convert negative numbers to positive because sometimes sales returns or refunds come as negative values. You can multiply the amounts by -1 to do this. To create this new column, go to Add Column, then Custom Column. Name it Invoice Value or any relevant name. In the formula, select invoice amount and multiply it by -1. Check for any errors before clicking OK. If no errors, the new column will be created with positive amounts. You can delete the original negative column if you want, since calculations use the new one. Then, create another new column named taxable amount. In the formula, divide the invoice value by 1.18, 1.18. This removes 18% tax to leave the taxable price. Format it as currency or number as you want, specifying decimals as needed. Finally, create one more column called tax. In the custom formula, subtract taxable amount from invoice value. This gives you the tax component of the invoice. Convert this column to currency format too. After all these steps, go to the Home tab, then close and load. Your sales and return data will be loaded with all these transformations applied. You will see columns like credit note number, credit note date, invoice value, taxable amount, and tax amount included in your final table. Similarly, you can filter cancellation data and load it as a separate table for your tasks. So, friends, that was an overview of Power Query. If you want to learn in detail, I have created a separate comprehensive course available on the platform Urmi. You can join there because putting everything in one video can be confusing. In that course, we cover all features thoroughly. Thanks for watching. If you have any questions or queries, please write them in the comment section. I will do my best to answer them as soon as possible. See you in the next video with a new topic. Thanks again. Hello everyone, welcome back. In this video, we are going to talk about a very powerful tool in Excel called Power Pivot, and we will learn how to use it step by step. So far, we have learned about regular pivot tables. In pivot tables, you take one table and create different reports from it. You can filter the data and summarize it easily. But what if your data is spread across different tables or even different sheets? How can we merge that data and prepare a report from multiple tables? Today, we will see how to do that with a practical example. Let me show you my example. I have some sales data from invoices. In column A, there's the invoice number, then the invoice date and product ID. After the product ID, there is customer ID, followed by quantity and rate. All this data is in one table. Now, the task I received is to find the total sales based on the customer names or based on the product names. But here is the catch. The customer names and product names are in different tables, possibly on different sheets. Also, this report should be dynamic, meaning whenever new data is added in the sales table or new products or customers are added, the report should update automatically. Traditionally, you might use functions like VLOOKUP or XLOOKUP to fetch customer names and product names into your main table, then create a pivot table and refresh the data. That works fine, but is slow and can get complicated. Instead, we will learn a more advanced, faster, and professional way to do this using Power Pivot. Let's get started. First, you need to enable Power Pivot in Excel. You will see a tab at the top called Power Pivot. If it is not visible on your computer, no worries. Just follow these steps. Go to the File menu, then Options, then Add-ins. At the bottom, next to Manage, select COM Add-ins and click Go. You will see an option called Power Pivot for Excel. Check that box and click OK. Once enabled, the Power Pivot tab will show up in your Excel. Next, before we dive into Power Pivot, we need to convert our data on all three sheets into official Excel tables. Why? Because Power Pivot works best with tables. To do that, select the data on the sheet, then press Ctrl and T together. This opens the Create Table dialog box. Make sure the option My Table Has Headers is checked and click OK. Now, rename each table properly so it is easy to identify them later. For example, for invoice data, name the table Invoice Data. For the Products table, name it Products. And for the Customers table, name it Customers. Once all your data is turned into tables with proper names, Select one of the tables. For example, the invoice data table. Go to the Power Pivot tab and click on Add to Data Model. This imports the table into Power Pivot. You can minimize or close this window afterward. Do the same for the products table and the customers table. Add both to the data model. Now all three tables are available inside Power Pivot. Now, here comes the important part: creating relationships between these tables. This means we will tell Excel how these tables connect with each other through keys like Product ID and Customer ID. To create relationships, go to the Design tab inside Power Pivot and click on Create Relationship. Or a simpler way is to go to the Home tab in Power Pivot and click on Diagram View. You will see all three tables laid out like a diagram. Look for the Product ID column in the Products table. This should be unique IDs. Drag this Product ID onto the Product ID column in the Invoice Data table. This creates a relationship between these two tables. Next, do the same for Customer ID. Drag Customer ID from the Customers table onto the Customer ID column in the Invoice Data table. Now, these relationships are created. You can save this setup by clicking the Save button. If you ever want to edit or view these relationships later, go back to the Design tab and click Manage Relationships. You will see all the connections you have created here. This relationship setup is like doing a VLOOKUP, but much cleaner and only once. You don't need to paste formulas repeatedly in your workbook anymore. Next, let's do some calculations inside Power Pivot. Go to the Invoice Data table inside Power Pivot, and we want to calculate the total sales value, which is quantity multiplied by rate. To do this, click on Add Column at the far right. Give this new column a header name, for example, Sales Amount. Now, write the formula here. Every formula in Power Pivot starts with an equals sign. But since we are speaking it out, just know it begins with equals. Type quantity, and you will see all fields related to quantity appear. Select the quantity field in the Invoice Data table. Then type multiply and select the rate field from the Invoice Data table. Press Enter. The calculation will automatically fill down for all rows. Similarly, you can add other calculations like tax, discounts, or any number or date-based formulas you need. Don't forget to save your work. Now, let's create a pivot table using this Power Pivot data. Inside the Power Pivot window, click Pivotable. Choose to add it to a new worksheet and click OK. You will see the regular Pivot Table Fields panel. But this time all three tables will appear here: Customers, Products, and Invoice Data. Now, to get total sales by customer name, expand the Customers table and drag the customer name field to the rows area. Then expand the Invoice Data table and drag the Sales Amount field to the Values area. You will get the total sales for each customer. Similarly, if you want product-wise sales, just remove the customer name and expand the Products table instead. Drag the Product Name field to Rows and Sales Amount to Values. The great thing is when you add new data to any of these tables, just refresh the pivot table and your report updates instantly. You can even make reports showing which customers bought which products, quantities purchased, and so on by dragging and dropping fields in the rows and columns areas. You can apply subtotals, filters, and formatting to make your report look clean and professional. Power Pivot is an advanced, powerful version of pivot tables that is extremely useful for data analysis. I highly recommend practicing this. I will share the Excel file with these tables as is, so you can download and try this out yourself. If you have any questions or queries related to this topic, please let me know in the comments section. I will try my best to answer them as soon as possible. Thank you for watching, and see you in the next video with a new topic.